I literally try to make this as legit as possible so you can like have an actual a way to like learn something. I don't want to just like like the basic thing whenever you learn a new language, right? It's like learning variables and like learning lists and dictionaries, data structures, things like that. But I didn't just want to go ahead and just come on here and just kind of go through the steps. Instead, I thought it'd be a lot better if I show you how to learn yourself. But obviously, it's not like I'm just show you and then just not do anything. So I'm actually going to show you stuff. So I do have like a little agenda schedule planned out for a little bit here that we could go through. And I spent some time on this, so I think it'd be like just a decent way to like learn things. First thing, introduction. So a little bit myself. I thought it would be funny if I don't know anything about programming, right? And I just come on here and like just gonna teach you. It reminded me of I think it was like a Mandela speech or something like that, where there was this guy on stage. I don't know if you've seen this video, like this guy on stage, and he's like signing, it's like doing sign language to like the crowd. But apparently he didn't know anything and he was just kind of doing random stuff. So I thought it was hilarious. And I thought, okay, well, if I gotta tell you, like I know how to program and things like that, or else you're just kind of learning from someone that doesn't know what to do. So yeah, I'm a computer science student actually, and I've been programming for a while now. I stayed about 5 years. But even though like beyond the classroom, I do my own stuff, which is kind of funny, right? Because whenever you go to like to study programming, you think, okay, I'm gonna study programming so they could teach me what to do. I found that for the most part, especially at the beginning, they kind of teach you like very basic stuff, which is expected, right? If you're just starting out, there's no way you can just start making projects. You could actually know how to do things. So, but like just beyond the class, I've done like freelance work. I've built my own stuff, and I kind of have some examples here. Where did I put that in here? We'll kind of talk about it later. But I do have a YouTube channel, and in that YouTube channel, I just kind of post different things. I am running Windows here. I was going to do this on Linux because I wanted to actually teach you some stuff on Linux too. But like my computer is just kind of struggling with the GPU, my laptop, which is what run Linux. So it's like kind of one of those things where I don't want to, it's like a squealing noise and you hear it. So I don't want to like be talking and then you hearing this squealing noise in the background. It's so annoying. So I figured let's just go with the gaming PC because I know this can handle it. So yeah, there's different things here, right? Like I've built different programs here. And you're always welcome to come. People usually like this one a lot. It's like a unlimited storage program. It's really interesting. I saw the idea on Reddit and I built it. So yeah, basically I have some experience with programming and stuff. And I think the way we're gonna do this, let's just structure it, is we're gonna start with like very basic stuff. So John did open up the Learn with Alfredo channel. So it's just like a quick poll. She's kind of telling me like where you're at, like with this stuff. Like you're a total noob, like you're completely new to programming. Python as well, or you're like a beginner, maybe you know some Python, maybe some programming stuff, but you don't feel like super confident. Intermediate, like you know some Python, you're comfortable enough to make your own programs, but you don't think you can make anything. And then advanced, you're just like the master, you like know everything. So just kind of go on the Learn with Alfredo channel, just kind of post whatever you think, like where you're at. And it's just gonna help me as well, because then I can kind of have an idea of like how to go about teaching you. Like if most people are intermediate or beginner, then it kind of doesn't make too much sense for me to go too much into basics. This way I'm not like just going like drilling basics and people are just like, oh my God, dude, like, so just gonna go with that. And just, I really see some things on here. So I see new beginner, I see some things. So just to let you know, if you're kind of like in intermediate beginner phase, or just let's say intermediate, and a lot of this stuff seems like brutal, like you're like, oh my God, dude, like, just go on, move on. I can't do that just because I do want to go ahead and make sure that everybody gets like a proper, I guess, understanding, right? I don't want to just make this another video basically. So like if you really want to, you could go on YouTube and just go learn Python from a video, but I want to make this more interactive than anything else. So I want to make it so that you guys could actually, thank you John for the poll, make it so you guys could actually I was gonna say like learn something from it, because you might be watching a video, and I see this all the time. People go on videos and they learn something, and then in the comment section, people are like how do I do this, or this isn't working, or this or that. So it's interactive might be good, just because you have your own questions. We could just go ahead and answer those. So okay, cool, nice, cool. Okay, yeah. So I just wanted to kind of get an overall feel. This way I know I could actually kind of slow down and go through different things. No, I'm gonna wake it. Go through different things here. So we're just gonna go start. Like the first thing I want to do is thinking like a programmer. I feel like this is one of those things where like if you can't think like a programmer, like everything just falls apart. And it's one of those things where it requires a different knowledge, different technique for actually learning or thinking like a programmer. It's one of those things that is kind of weird. So like one of the examples I like a lot, it's like I hear this before where it's like let's say we're in a classroom, right, of like 500 students, and then I'm sitting in the classroom. I'm somewhere in the classroom. It's like, how do you find me? And if you guys want to just go ahead and start talking or whatever, you can go ahead and do that. Just how do you find me? Like I'm sitting somewhere and your task is to find me. How do you do it? If you're advanced, don't answer this. Just answer if you're like a noob. I just want to see what you guys like think, or like a beginner. Or if no one answers, I guess eventually I could just go ahead and answer it myself. But I'll just go ahead and give you guys some time to think. Yeah, so let's say we're in a classroom of like 500 different students, right? And your task is to find Alfredo. Like I'm somewhere in there. How do you find me? Just like whatever comes to mind. The first thing that comes to mind. How do you find me? Right? Yeah, that's a good one. Like you just scream it out, right? And like honestly, any answer is pretty valid. Like what I would probably said is just like, I just gotta look around the room at random until I see you somewhere, you know? So that's what I would have said. But anything's like that. But when you like, and the reason I like this example so much is because like if someone just asks you that, like I don't know, let's say we're not even talking about programming, we're just talking about in general, like how do you find me? People usually say like, oh, like what do you mean? Like that's a, what do you mean how do I find you? You know, I look for you and I find you. It's one of those things. But then like if you were to implement a program that like looks for me, you can't think like that. It's not a matter of like looking around the room and like searching for me. You could do that, by the way. Like let's say we have a list of like people and then you randomly pick people out from the list. You could do that, but it's kind of inefficient because you might never actually find me that way. So like in like a computer language or programming, the way I would think about it is like you have a list of people, 500 different people, right? And then you kind of start from the beginning and you look at the first one. Is that Alfredo? No, it's not. You look at the second one. Is that Alfredo? No, it's not. And you literally keep doing that, right? And it might seem slow, especially if you're doing it in real life. Like you can looking at the first seat and looking at Alfredo, like doing that forever. It's gonna be slow, but obviously computers are a little faster than us, right? So we could actually go ahead and implement things like that. But yeah, that's just a thing that I like to think about. And later on, I know that's kind of like a regular example, or it's just not super concrete. What we will see is we're actually gonna go ahead and build a program. So after all this stuff, so after learning all this stuff here, at the very end, we have a program we're gonna build. I'm just gonna hide that so you won't see too much of it. But we are gonna build a program, like implementing all this stuff. And then you really get to see what I mean by thinking like a programmer. Because we gotta think about different things, like why are we doing this? Or why do we do this? Or we have this problem, how do we solve it with code, right? You gotta think of it. And if you're ever like new to programming, it might be like, what do you mean? What are you talking about? But you'll see so much, like, or at least I hope you'll see, once we actually start making the program, you'll get to see what I mean by like that different thought process. It's a little different. You gotta get used to that thought process. And once you do, it comes really natural. So like the program we're gonna make, I made it in like maybe like 10 minutes. It's like super quick, right? It's not a super crazy program, but it's likely because I have experience with like data structures and what to do if this happens and how to check this thing. So it becomes easier as you do it more. Cool. So now let's actually get into the cool stuff, or I guess the boring stuff. So I gotta go ahead and kind of say something real quick. So one thing that you'll notice, especially when learning this, it tends to be a thing. I've had friends who like take programming classes and then they come to me for help and they're like, dude, this is like the worst thing ever. Like I can't, what am I doing here? You know, it's just, they hate it. It's one of those things where you usually super hate it or you like it. I don't think I've ever seen anyone in between. Like, oh, you know, it's kind of cool and I'll keep doing it. If you usually don't like it, it's one of those things where you just won't stick with it. But yeah, like the beginning stuff might be boring. So I'm just gonna, I guess, encourage you to kind of stick along and just kind of, what should I say? Like, just deal with it. It might be boring, or unless if you like this stuff. Like for me, this is kind of fun. Like just going through the basic stuff. I actually went through like the basics again, just because I thought if anyone has any questions, I better know how to answer them. So I was going through the basic stuff again, and it was actually really fun for me. So, but I know people might find it like tedious and boring. So just a heads up. Just gotta stick with it for a while, and at the end, it gets a lot more fun when we actually build something. So the first thing is that again, we are going to be learning Python, right? So I don't know if you already have Python installed or not, but this is the Python website. It's pretty straightforward. There's it's uncommon to have any errors usually. There's a download section here with like different things. So for like different operating systems for Windows, Mac, Unix, Linux, all this stuff. So hopefully you have that installed. I was going to put something in the group like beforehand, but I forgot. With like, if you want to follow along, you should probably install it. But I have a feeling that a lot of people actually have it installed already. So we'll see how that goes. By the way, if I'm speaking too fast, just let me know. I've been told that a lot, that I speak really fast. So if I am, just go ahead and just say it in the, just say something, or put it in the Learn with Alfredo. I'll have it right next to me so I can see everything. And yeah, and if at any time, I don't think I've said this, but if at any time you have any questions, just ask. Like, just go for it. You know, I don't really mind people intervening. I mean, as long as it's within the topic, you know, like if we're talking about variables, don't like, how do I make an app, you know? So actually go ahead and just kind of make it within topic. If you have a question about something, just ask. So we'll go with that. So yeah, it's just downloading Python here. And then the cool part is, oh, I guess let's go in order here. So text editor. So once you have your Python downloaded, you need a way to actually make code, or actually write a program, right? There's different ways. Text editors is one of those things where it's like, it's super popular right now. Like Code, for example, or Visual Studio Code. I'm not used to this keyboard yet, so yeah. So here, Visual Studio Code, right? It's just a text. It's like a text editor. I think it even says somewhere it might be that. But that's all it is. Basically, think of like, if you're new to like this kind of stuff, think of like Notepad. So if you're like on a Windows user, right, you have Notepad. Notepad is used to write text. That's all it is technically, but it's a lot. It has a lot more features, and it's a lot more advanced. And the features are specific to like coding. So like highlighting syntax, for example. I don't want to show you too much of this, but like that, you see that there's like code there, and it's like highlighted. So there's like text in there, and it's just like maybe sometimes it'll tell you when you have an error in your code before you see it. That might be more of an IDE thing, but you'll see that. There's different things. It really doesn't matter when it comes to choosing what you want to actually learn with. There's a lot of different things. For this example, though, we're going to go ahead and be learning Visual Studio Code. We're not learning, using it, just because I think it's a lot of a more pleasant experience when it comes to actually showing you what I'm doing. So we're going with that. Other than that, that's pretty much all you need to know. I mean, there's a lot more here, right? After this, what I'll do is I'll go ahead and paste this in the Learn with Alfredo in the channel itself. That way you could go back here and like kind of go through different things if you want to see what they're like. They pretty much do the same thing, but they might have a feature here and there that you might think is better. Vim, for example, is one of those that it's kind of out there. I like it a lot. It's kind of out there in the terms of like, it's different from whatever else you might be using, like from Visual Studio, because instead of like clicking on things to like do different actions, you use commands to do it. So it's a lot more on hands with your keyboard instead of using your mouse, which I like a lot, but it definitely has a learning curve. So we'll do that. And then there's integrated development environments, which are one of those things. Sorry, give me a second. I think this is important. Cool. Yeah, so if something sounds low at any point, just let me know. Or if you can't hear my voice for whatever reason, just if anything like that, just go ahead and let me know. Again, just talk whenever you want to talk. I really don't mind, as long as it's within topic, or if you're having trouble seeing what I'm doing. So yeah, that's that. Integrated development environments. They're kind of like code editors. Like you could think of like a Visual Studio, but they're a lot more, what's the word? They're a lot more complete, if you might say. And they're usually specific. They're like a lot of development environments that I've seen are super specific to something. So Spider is one of those things, where if we go ahead and open that, this is like an environment, a development environment, but it's specific to scientific purposes. So it has a lot of like scientific tools. So whenever you want to build something in Python that's like scientific, this is probably where to go, because it has a lot of the tools. But you really don't need a development environment. You could actually just do anything with just like a code editor. That's completely fine, and it will work for anything that you need, really. This is just like one of those things that I thought I might mention, because they are popular whenever I've seen like teaching tutorials for Python or just anything like that. There is one that actually comes pre-installed. It's called Idle. It comes pre-installed with Python. It is in the development environment, but it's a lot more simple. It kind of looks like a notepad, as you can see. It's not super crazy. It looks like a notepad. But yeah, it's just this is basically the Python interpreter, and we'll talk about it later. But yeah, we'll keep going with that. So yeah, if you're going to go ahead and follow along, which you can definitely, maybe you just go ahead and, if you haven't already set up Python, go ahead and just download and then just go ahead and install it. It's going to be different for different operating systems. One thing to mention is that obviously I am using Windows right now. So what I'll do is I'll actually, once I start talking about more things, I might mention different things here and there for platform specific things. So like if I do something on Windows, I might mention something, how to do it on Linux and how to do it on Mac. That way Linux and Mac is pretty much the same thing as far as how to do these things, but I'll mention those things. And if I forget for whatever reason and someone knows, or you're following along and something's not working, just let me know. That way I could just go ahead and tell you what that is that changes or why it's not working. So we'll keep going here. Oh, where we're at. Oh yeah, so development environments. So yeah, you could choose any one of these if you wanted to, but for now we're going to stick with text editors because there are a lot, or I should probably say code editors. But that's all we need really for now. It's just going to go through stuff. And I don't think I've actually ever used an integrated development environment. Like I've never actually used anything like that. I've always just done with text edit. Like that's sufficient. Anything I've ever done, that's all I've ever needed. So yeah, it's just something to point out. Cool. So now let's get into the cool stuff, the actual learning. So this is going to be, again, like I said, if you're not new to programming, and if you've seen this kind of stuff before, you might be sitting there, you might be like, dude, come on, like, you know, like basic stuff, but just kind of hang on with me because other people are not at that level. So we kind of have to go through things. So let's talk about documentation. Like documentation is one of those things where it's really cool. So the way I like to think of documentations is like the people who build these things, these technologies, these languages, different things that you're using to actually build stuff, they're building it so that other people can use it, right? So they have to go ahead and make something in some way where they could tell you how to use that stuff. It's like a car manual. Whenever you buy a new car, it comes with the manual so you can know like all the functions of the car. And these things are long. My friend got a new car recently. I think they're like 300 pages plus long. They're like super thick books of like every single little detail you need to know about your car. So it's like that. It has anything you could ever think of when it comes to actually learning these things. And it's important to know this stuff. An example I could think of is this is one of my stories where I was like, okay, I need to learn how to use these documentation stuff. So when I first started programming, I went to this I had this challenge. It was like a beginner's challenge where you would go and then in the challenge itself, I think it was HackerRank. I don't know if you've seen that website. I might still be up somewhere. Yeah, HackerRank. I think it was this. So they had like an open platform thing where you could actually go ahead, and I don't know if it's paid or not. I remember it used to be free. I don't know if it still is. Oh, I think it's different now. Matching developers with your code. Before, if it's the same website, it used to be one of those things where it's like LeetCode. Have you ever seen LeetCode before? Where you have like an interactive shell, and then you go in there and you like, it gives you a problem, and then you answer the problem with your code, and it tells you you're wrong or you're right, and it tests different things. So it was one of those things. And then I went in there and I sat down, and they had the rules was, okay, you're given these problems, you have to solve them. I think it was like in a span of an hour or so that you have all these problems. Every single time you solve a problem, you get a balloon. So you get a balloon and someone comes by and they tie a balloon to your chair saying, okay, yeah, you passed it, you know, cool, good for you. So you did that. And then the rule was that you couldn't use the internet, so you couldn't use it. So, but you were given help, and the help was that you were given the documentation. And this was using Java. So this was Java. This was my first language, Java. So it was using Java. So you're given the documentation, but you can't look at anything online. So I get there and I see the first problem, and I was like, easy, I got this. The problem was something, I don't remember the problem exactly, but I remember it had to do with iteration, so like looping. And then there was a list, and it was like, okay, we have a list of like fruits, and then find how many times apple occurs in that list. So I sat there, I was like, easy, bro, I got this, you know, easy problem, I got it. And then I get there, and then I'm doing this stuff, and I compile, and I get a syntax error. And I'm, okay, you know, so your code doesn't always work the first time around. I'm gonna go ahead and keep going through it. So I get a syntax error, and then for the life of me, I could not figure out how to actually get rid of that syntax error. I don't know if it was because of the public static void main, like the main function, or if it was because of my for loop. I don't know where it was, but I spent the entire hour. I never got a balloon. So it was one of those things where I was like sitting around, I'm like, everyone's getting balloons, you know, everyone around me is getting balloons, and I'm just sitting here trying to solve this damn syntax problem, and I can't do it. And then If only I knew how to like go through the documentation, I could have figured it out for sure, because the documentation was right in front of me. But when you're starting out, and you probably like you have probably experienced this if you're new to like programming, and if you look at documentation, it can be pretty daunting. Like if you just look at this stuff, let's look at the language reference real quick, right? There's a lot of stuff here, and it's like, okay, well, where do I start? And then you find something, and you go through the documentation. It's a bunch of text, right? It's just a bunch of text everywhere. I'm used to my Linux key bindings. But yeah, this is a bunch of text everywhere, right? And then you just look at all this stuff, and it's like, okay, well, like, it's overwhelming. It's a lot of stuff, and you don't know where to start or what any of this does. So one of those things, Linux key bindings again, it's one of those things where it's important to like learn, just because you don't know when you might need it, and this is like the place to go. Like if you want an answer to something, everything is here. Obviously, the people who made it know about the language so much more than we do. So this is the place to go, because this is the people that actually made the language, and everything's here, you know? And that same goes for technologies. There's a project called Django, which is like a framework used for building websites, right? And like the Django documentation is like, it's like super good. It's like super concrete. It's in-depth. It has so much information. It's one of those documentations that is like, it's beautiful just because there's so much in here. And like pretty much anything you could think of, I've always found here. It's really great. But yeah, documentation is one of those points where you just gotta learn how to do. So I thought, instead of me just sitting here and kind of going through, showing you like the basics, you know, showing you lists and variables, things like that, it's a lot better for me to show you how you would do that yourself, in case you ever want to go ahead and come back here and do things. So the way I've structured this, Linux key bindings, the way I've structured this is that what we're going to do is we're going to skip some stuff. So this is the stuff in the documentation. This is part of the tutorial section. So this one, part of the tutorial section, that if we go back to here, there's, if you scroll down, right here, this is the tutorial section. Where is that? Right here, tutorial. So this is part of the tutorial section. And the tutorial section basically tells you everything you need to know about Python, right? Like the basic stuff, the tutorial section. So that's what it does. So what I've done is I've actually went ahead and I skipped some stuff, because this stuff is useful, and you should definitely go back through here. I even put it here. You should definitely go back and like look through these when you're comfortable with basic programming, because these are things that are important and you should go through. But I felt that they're not, as far as beginning, like with programming goes, it's not one of those things where it might just go over your head. It's just because they're kind of abstract concepts. Like classes are one of those things that you should learn, but they're one of those things that you have to understand basic stuff before you actually learn to do like object-oriented programming and like inheritance and things like that. So definitely go through these once you're comfortable enough. But for now, we're going to do 1 through 7, which is down here. So yeah, starting off with this, the Whetting Your Appetite, it's just basically telling you things that Python could do, which is a lot of automation. So I think that's the first thing it tells you. Yeah, some tasks you want to automate. So that's what Python is really good for. Python is really a general programming language, meaning that you could do pretty much anything with it. There's so many libraries and frameworks out there that you could do anything you want. There's like, I've seen some abstract concepts out there too. Obviously I show you the Django one, right? You could build websites with Django. It really is like the backend core of like building websites. So like routing things and HTML templates and background logic and logging in and things like that. Things you see from websites before. So yeah, it's very general. You can do so many things with it. Obviously, you've probably seen that recently Python is very popular with like machine learning and yeah, machine learning, just things like that. It's just very popular with that, just because for one, it's very popular. Like Django's been increasing. Python has been increasing in popularity. So that, and then just with the increase of like people learning machine language has been there. But yeah, it's a general programming language, and there's so many things you can do. I thought, like I showed you my YouTube channel before, at the end of it, if you guys want, I could go through some of these things, like how I actually built them, because it might be interesting. This one is really interesting, how that works. There's like, I have a video of hiding a picture inside another picture, so I could show you that. That's interesting. That's a little more advanced because it does require knowledge of like binary numbers and like, which are just a different way of like, of representing numbers. So usually we represent numbers like this, right? Like that's the number 10, that's the number 100, and binary is different. So you have something like that, you know, it's different. So it's a different way of thinking of things, but I could teach you that for sure, show you that. I have some some programs here like uploading a new video every time someone subscribes. I can show you that. That uses the YouTube API in the backend. So it uses YouTube to interact with it uses Python to interact with YouTube through its backend, through its API. So I'll show you that. And this actually is kind of similar. It uses the DoorDash API, which is really interesting. I reverse engineered the DoorDash API to get access to their data, and they made an app for me. So that's kind of cool. And that uses Python in the backend with Django. So I can show you so many stuff. So again, Python is just one of those things where it's a general programming language you can really use to do pretty much anything you want. It is a little slow compared to like C++ or C# or any C language really, but if you're just doing things, you won't notice it. Like it's faster than you can like your own, you know, that you could do things. Is definitely faster, but as far as like low-level programming languages go, it's not super fast. But if you're just using it for regular general stuff, you'll never notice it. Trust me, like it's just it'll do stuff, you know. So yeah, we'll get through that. Now let's talk about the Python interpreter. So in Windows, you can open the command line up like that, and then to open the interpreter, use Py. That's how you launch it once you install Python and things like that. So you use that and you'll do that. And then you could exit like that. Let me go ahead and make this bigger for you guys before. Okay. So that probably is about right. Right, so you could exit with, again, you open it like that with Py, and then you could exit by typing exit like that. This is actually a function. And I'll show you guys maybe, oh yeah, in the program we're going to be building, that actually comes up. So I'll show you that, but that's basically within the interpreter, you could do just about anything you could do within Python. That's really what it is. It's like, think of like the way you interact with the actual Python language. And then in Linux and Mac, the way you use that is using Python like that, and you'll do that. Here, it's not going to, it opens the Microsoft Store, I guess. I didn't expect it to do anything. So yeah, that's how you do that in Windows and Linux. Mac and Linux. One thing to note is that Mac and Linux do come pre-installed with Python, but that's usually Python version 2. So what you'll want to do if you want to follow along here is use Python 3 like that, and then hit enter on that. And for that, you open up your terminal or you open up your command line. You know, on Mac that's command space, and then just type in terminal, hit enter, and you have like this. On Linux, it depends whatever you're using, so it's always different for whatever system you're on. But yeah, that's how you do that. So we'll start with Python interpreter. We'll just open that up, and then we'll start with variables. I believe that's the very first thing we're going to talk about. Let me just go over to our list here. Yeah, so the way they call it, it's an informal introduction to Python. That's what the tutorial calls it. So we'll go ahead and do that. And again, the reason I want to open this up is because I want to actually show you, right? I want to actually go ahead and show you how you would go ahead and teach yourself if you were going to do it yourself, because you're going to be referring to this over and over again when you're programming. You're going to be referring to it. So they talk about using Python as a calculator here. Basically, it's just using different types of numbers, right? So, sorry, different types of variable types. So, and different types of variable types. So, to explain this to you, when you're programming, you have different variable types available to you, right? The most common are probably like numbers, which is literally a number, right? Like 2, 3, 4, 5, whatever you might think of. There's even like floating point, which is like decimal numbers, like this. Like 5.666, whatever, that's a decimal number. So like that, and these can be used to store as a variable, but in Python, in the interpreter, you could actually use them by itself. So they actually talk about up here like using Python as a calculator, which I do all the time. Like whenever I need to do something, I just open up the Python interpreter and like just go ahead and type in numbers. So it's very simple operations, right? Like let's do 2 plus 2. 2 plus 2 is 4. You hit enter and it gives you 4, right? Basic things like that. You could divide numbers by using slashes, just like you would pretty much in any computer thing, any like computer program. You use slashes to divide stuff, and that gives you the result of that. You could do multiplication, right, using stars, like that. The star is like a multiplication sign. You could do subtraction, right, just like that. So you could do like very basic stuff, and hopefully you guys can see this. If it seems too small at any point, just go ahead and give me a heads up and tell me, hey, like things are too small, I can't read it. So just say it out loud, or just go into the learn with Alfredo, but I think it should be good. I tested it beforehand to see. So yeah, that's how you go about that, right? Just basic arithmetic, basic things. And you could do things like this, where you could like 50 minus 5 times 6 minus, or divided by 4, right? The way usually this does, I believe, is you'll do this first. You'll do 5 times 6 first. That will, like in the back end, that's what happens. You do 5 times 6, and then you subtract 50 from that, and at the very end, you divide 4, right? It gives you an answer. So things like that. So that's like the very basic thing I was using as a calculator. But what's really cool is when you're actually programming, you want to know how to store these values. And you do that using variables. So variables is, think of like a label to I guess, have the name. Maybe I'm not explaining that right, but think of it like a label. So it's something to assign a name to something. So in Python, the way you do that, let's say we have a number, right? We use the equal sign. Now the equal sign in Python is an assignment operator, which means it's how you assign the value to something. In this case, we want to assign the value to number. So this is saying, once we do this, the number 2 is not going to be inside number. In memory, it's a little more complex than that, but just think of it like that. So the number 2 is inside number. We go ahead and enter on that. And then you see nothing happened, right? And the reason that nothing happened is because all we did was store the value. We store the number 2 inside number. So now if we go ahead and type number out and hit enter, you see the value 2 appears, right? Because now we made that relationship between number and 2. And then that could happen with different types of data types. So numbers are not the only data types. It's just one of the data types. Another thing is a string. So a string is one of those things where you can use to store text. So for example, let's say we know, I'll show you something. So my name is Alfredo, right? If we do this and hit enter on that, you see we get an error, right? Name Alfredo is not defined. The reason we do that is because remember before we assigned the value number 2 to number, right now if we do Alfredo, it's looking for a variable called Alfredo, but we never define it anywhere. So it tells us that it's not defined. The reason I want to show you this real quick is because whenever you're programming something, you might see errors. It's unlikely that you'll code something and it will work the first time, so just keep that in mind. So you'll see an error, and it's important to kind of know what these errors are. I found that a lot of people who are like new to programming kind of look at it and they see all this like stuff on the screen, and then like I don't know what's happening, but they don't bother reading it. So like if you read this, you'll know Alfredo is not defined, and the reason is because I just explained it to you, right? We never define this anywhere. We're just using it by itself. So in Python, the way you define strings, it's not like that. What you do is called string literals. So you use quotes like that, and then inside those quotes, you put something in it. So in this case, Alfredo. If we do that, you see we get back Alfredo. Now notice that we have single quotes and we use double quotes. In Python, you can use both. You can use double quotes or single quotes to put a string. Again, a string is just any text. So you can do that. You just put a string. It doesn't matter. I prefer using double quotes because it makes a lot more sense to me, especially when talking about like F strings, which we'll get to later. So I just like double quotes a lot more than single quotes. Single quotes to me are like more like characters. It's a different data type, and that's usually used in other languages. But anyways, yeah, that's that. And just like number, we could actually do the same thing. We could assign that variable. So now let's assign the name Alfredo that we did before. So let's do the variable, and then we assign it using the equal sign, and then we do the name like that. Hit enter on that. Again, nothing happened, but now notice that if we do Alfredo without quotes, we hit enter on that, we get to back Alfredo, right? And that's just because we made that association that Alfredo, the variable, is now this thing. It's now the string Alfredo. So that's another data type, right? Strings. We also have Booleans, and this is all stuff that you go through here. You'll see different things, right? I'm just kind of going through it myself, but as you can see here, we have strings, right? We have strings here. They even use a print operator. I'll show you that in a bit here. Again, this is all stuff that the reason I know this is because I went through the documentation just in case anyone had any questions, and I just kind of went through that. So we'll do that. And the next thing is Booleans. So Booleans are, think of like true or false values, where true means you do something and false means, or I guess the value of it is true and the value is false. And let me just do it for you so it might make more sense. One thing I want to point out real quick. So again, Boolean values are true or false, right? So let's make a variable here called true. And then let's assign that to a Boolean value. So a Boolean value for true would be like this. Like that, true. Keep in mind, or notice is that I use capital T here and lowercase t here. That's because in Python, Boolean variables are capitalized, meaning that true is not the same thing as true. This is just a variable name, and this is actually the value for true. If I go ahead and enter that, And I know it might be kind of confusing, but I'll show you in a bit like how these work, right? If we do that, and now we go ahead and type true and enter, it gives us the value true, right? True. I don't want to jump ahead yet, but let me show you if statements, right? Just because I want to show you how Boolean's value work. So if statements are one of those things where we'll talk about later. Yeah, we will. But they check their conditional statement. So it checks whether something is true. And if it is true, it does something. It's like, if today is Monday, I'm going to wear socks. I don't know why you wouldn't wear socks, but if today is Monday, I'm going to wear socks. One of those things, right? So if you look in the calendar and today is Monday, then you're wearing socks. It's one of those things. So if we do if true, right? Remember, true is not this, but it's rather the name of the variable we assigned to it. We could have named this anything we wanted, right? This is true. So we do if true, and then I'm going to show you here. Notice that we have this. Python calls this the second input operator or something like that, like the second input in the interpreter. When you see this, that means you could keep continuing putting input. In this case, we're going to press tab to kind of indent, and I'll show you why we're doing that later. But basically, it's saying if true, then do something. So if true, we're going to go ahead and do 2 plus 2, which is 4, right? So we hit enter on that. As you can see, I press enter twice because I can put more input if I want, but I just press enter. So if true, we did 4. Now let's say we want to go ahead and use false, right? So let's assign true, the same variable number, to false, like that. Keep in mind that I'm using the same variable number, and when you do this in the same variable name, and when you do this in Python, this means that the value true will now contain false. So even though before it had true, we're now overriding that value. So and I see this like a mistake people do sometimes, where they'll override something and they expect a certain value. They expect true to come out, but you actually changed it down here. So true is now false. So I press enter on that, and I'll go ahead and do true. As you see, we no longer get the name true. We get the name false now because we changed that. We assigned it a new value, and that's valid. You could do that. So now we do the same thing. By the way, in the interpreter, you could press up if you want to like repeat things that you've done. So if I just press up a few times here and I press true, hit enter on that. And then I'll go ahead and press tab. Let's do the same thing, 2 plus 2. And I press enter on that. You can kind of think of what's going to happen, right? Obviously, if you kind of been following along, you know that I said like if something is true, then something happens. If it's not true, that's not going to happen. And we know that true is now equal to false. So we press enter on that. Nothing happened because this only executes if it equals true. So I did that to show you how Boolean values work, right? So Boolean values store a statement of whether something is true or not. And because in the if statement, we execute that to just kind of do something if something is true. This didn't work because true is false. So hopefully that makes sense. I know that can be kind of a confusing topic, but hopefully that makes sense. And again, if anyone has any questions at any time, just hop on and ask, or just go ahead and ask and they'll learn with the further channel. So yeah, that's that. That's true and false. Let me make sure I'm not skipping ahead here. Well, I know I am for that, but... Okay, flow control, yeah. So before we do that, let me show you some more stuff. So again, in Python, you could pretty much assign anything to a value. So so far we have numbers, we have strings, we have Booleans. Like I said before, we have something called floating point, which is just a decimal. So if we do like decimal equals 1.1, like that, and then we go ahead and show decimal, like that, it shows 1.1 because we store that value, right? And then once you have these values, you can use operations with them. So before, if you remember, we had the value number, and we haven't changed anything, so number should still be in here. As you can see, numbers 2 because we put it way up here, right? Right here, number equals 2. So we have that, or we assign the value 2 to number. So that's still in here. And that applies to any Python program or any programming language, really. If it's still within the scope, meaning that you still have access to this variable some way, which we do because we started at the very beginning, then we can still use it whenever we want. So we can use it way super into our program somewhere else. So what we could do is do something like number plus decimal, like that, right? And then went ahead and actually went and computed that for us. It's just a number plus a decimal. We know number is 2 and we know decimal is 1.1, and we added them together, so we have 3.1. So you can do the same thing with variables like that. And you could even do it with strings. So this is kind of cool. I'll show you that real quick. So we have Alfredo, right? That has a string Alfredo. Let's do the string Tim. And let's make that equal Tim. Like that. And then if we actually add them together, which is kind of a strange thing to do, right? If you think about like adding things together, like how do you add letters together? Like it's one of the, like numbers make sense, but letters. So the way Python does that, and I'll show you. And we hit enter on that, it puts them together. It's called string concatenation. Basically, it just puts Alfredo and Tim together into one string like that. So that's what we have. That's what happened. Literally just put them together. If we wanted a space here, for example, we could add another string. So we could do like Alfredo plus a string with an empty space. So remember that I said that anything within quotes is a string. So I just went ahead and added an empty space within that string plus Tim. As you can see, now we have that string. So this is Alfredo, the variable in here. The string is an empty space, and that's right here, in this space right here. And then we have Tim, and that's right there. So it's just added an empty space. So you can do that with that. Just know that you can't do it for the most part with different types of stuff. So we know true, and I don't know how this will react, but we know true equals false. If we do like Alfredo plus true, look at this. It says you can only concatenate string to string, not Boolean. So it's telling you that you can, it's literally telling you the error. So this is why it's important to read these errors, because looking at these errors, you can see what's wrong with it. But this is only telling you that you can only add a string with a string. You cannot add a string with a Boolean value. You just can't do that. They have to be the same type. There's something called casting, which allows you to do that, but we'll get into that maybe some later. I do believe we might do it. Yeah, I think we do it in the program itself, so I'll show you that later. Let's move over to flow control. So this is flow control. Like I said, I briefly explained if statements to you. All if statements are, again, it's a way to check whether something is true or false, right? So, or I should say true, because the if statement only executes if something is true. So if, for example, we have a value here, x, right? And x is a number greater than 0, then we do this stuff here. Just like this is, right? And now that I have that, I should get it into like comparison stuff. So in let's do with variables. So let's say I have a variable called true again, right? And again, we already have something inside true, but we could actually go ahead and override that. So we're going to override that with a statement. Let's say we know Alfredo, or the number, equals 2, right? And 2 is greater than 0, right? So if we do something like this, that's a greater than operator. If we do that, as you can see, nothing happened, but this actually evaluates something. So number equals 2, and we know that 2 is greater than 0, and this is true. So inside true, we'll actually have the true. So we put true. As you can see, true, right? Because number 2 is greater than 0. So that's how that evaluates. There's different types of operators that you can use to different things. So if, let's say true, let's override it again. If true equals, I keep saying if because that's the way I think about it. But let's say number equals 2. Now this double equal sign is not this. It's not the assignment operator. This is actually a comparison operator. And what it does is that it checks whether something is true or false. So number, we're checking number, and we're checking if number equals 2. So literally equals, the equal sign, right? But remember, double sign. Some people might, sometimes you'll see something where you're supposed to use one and people use the other one and something breaks, and that's a really good indication of what it is because you're using the wrong one. So keep that in mind. This is comparison and this is an assignment operator. So we hit enter on that. You expect it to be true because like that, true, because number 2 is 2, right? We know that inside number 2 is stored. So that's true. 2 equals 2. So that's true. There's that. There's more operators. So I just want to go ahead and see if we have anything else. 4 statements. Okay. So I'm sure some more operators here. So we have that. Like we have this one, greater than, we also have less than, right? So if we do true number, we'll do the opposite, less than 0. We know this has to be false, right? Because 2 is greater than 0. It's not less than 0. So we hit that and then go ahead and type true. As you can see, true now has the value false because that's not true. 2 is not less than 0. So that's that. What else do we have? I'm going through these because these are not necessarily all in here. greater than, less than. Oh, we have not. So not is one of those things that negates things. It's not. It's not an operator. It's not an operator to check for equality or anything like that. It's an operator used to negate something. So for example, let's do not. We do number equals 2. This not tells us that whatever the answer of this is going to be opposite of it. So we know that this is true, right? But not makes it false. So it's the opposite of it. So we press that and then go ahead and do true. As you can see, it's false. Because even though number 2 is equal to number 2, we put not, so that means it makes it false. So that's that. And you can do that with any. You can negate, you just negate statements like that. You can also do it like this. Another convention is doing it like this. Like the opposite of stuff. This shebang is called, that's what it's called, or this bash, whatever you want to call it, but it's called a shebang. This exclamation point is just the opposite of it. So this is like saying number 2 is not equal to 2. So that's what that is. We know that number is 2 and this is 2, so they should be equal, but we're putting not equal to that, so that should be true. False. Number. Oh, I see what I did. So yeah, I messed myself up. So number, right? We know that number equals 2 and it should be equal to, but we put not, so we're negating it, so it's false. It's like saying this not statement. It's just a different way of writing it. So that's the way that works. And you can also join things together. I don't know if that comes up later, but if not, I'll go ahead and explain that to you. So we'll do that. Let's go here. We have for statements. So for statements are interesting. Let's say, for example, I want to go ahead. Let me show you the print statement because I haven't done that yet. So print in here, you've noticed that whenever we put number, right, it shows us 2. This is because this is the Python interpreter. But when we do that for like within an actual program, we can't do that. We can't just put number and it'll print something out. So we'll do that using print statement like this. Print is a function, and I'll explain functions a little bit later. But print is just a function that tells Python to do something. So in this case, print is like show me something on the screen. And this is we'll do number, and we'll hit enter that. As you can see, we get the same thing, number, right? So in the interpreter, it's just a common convention, or it's just the way it works, that whenever you type the variable name by itself, it prints it out. But in programs, that's not always the case. So what it does here is that this is actually how you do it within the program. And later on, when we switch over to actually putting a program inside a text editor, we'll be using print instead of that, and it'll make more sense to you. So that's the way that works. So let's say we have the name Alfredo, right, like we said before, and that has a string Alfredo. Now, if we want to go ahead and print this 5 times, we can literally do something like this. Print, if I can spell, like that. Hit enter on that, and it prints Alfredo, and then do it again, and it prints Alfredo. Again, I'm pressing the up key, the up arrow key to do that, to do it again, so I don't have to retype it. And we can keep doing this all we want to keep doing it. But if you're doing this in a program, you actually have to write this out. So you can't do the up arrow key. So you actually have to write it out. And it's tedious. I'm not like 5 times is fine. But let's say I'm doing it 100 times. I'm not going to sit there and copy and paste off for 500 times, like, or 100 times, whatever I said. That's just going to take forever. So we have loops in Python. And a loop, it's just what it sounds like. It's a loop. It loops something. It does it over and over again. And one of those loops is called a for loop, or in Python calls it for statements. But it's a for loop, right? The way that works is that you loop something over and over again, and then you do an action. So every single time this loop runs, we do this action. We print this. This runs, we do this. This runs, we do this. I don't want to get into lists too much right now, but I'll show you this anyways because it's in the introduction. A list is a list of stuff. So at the beginning, I was talking about finding Alfredo in a group or in a classroom of 500 students. If you were here for that, it's a list. It's a list of 500 students. So let's say we have a list called names. Remember that this is a variable, right? So whenever we do this, we assign it. This means that the list is not going to be inside names. So a list is defined like this. We use square brackets, and within those square brackets, everything in the list goes inside of there. A list could have different types of stuff. So in this case, because we're doing a list called names, it makes sense for the list to be a string of names. So we'll go ahead and do a string of Alfredo. And then we'll do one of Tim. And then we'll do one of Jimmy. check this out. So this is the list of names. In between every single list, I'm using a comma. And this comma just means it's a separator. So it's a way of telling the Python interpreter that this is a different list. It's a different name than this. And you do that for everything. You just split it with commas. And that's just kind of, you know, splits it up so that you know which are which. So you split that up. You go ahead and press enter on that. If I go ahead and type names, as you can see, we get this, right? We get a list of names, just like expected, which is, it gives us exactly. And again, we can do this too, right? We could do names like that. We can use the print operator, and it gives us the same thing. So that's what a list is. Now, the reason they're bringing up lists now is because you could use them for loops in an interesting way. So before I do that, let me actually go ahead and keep that in mind, keep the list name in mind, and let me show you the range operator. I do think we'll talk about it. Yeah, I'll talk about it later, but I think it makes more sense to show you range first before I show you the for loop with the list, because for someone that's starting out, it might make more sense to show you what I'm doing. So the range is, again, range is a function, right? Whenever you see these parentheses like that, open and close, is a function, meaning that it's again, you're telling the interpreter to do something, and functions might be kind of strange right now, but we'll go into them later, and you'll see what I mean by that. But basically, you're telling the Python to do something, and these functions take what are called parameters. So, and it's one here. I'll show you something. So again, if you don't know what these are, like these functions are, you can always look them up, right? So here in the documentation, if you click on this, it gives you really the documentation. Linux key bindings. It gives you the documentation here for like what range does. Right, it tells you all this information on here, and it gives you a lot of information. And I know this is a lot of information, but it's again, it's good to learn how to read this stuff. So I guess let me just show you with this one. So this is the range, right? And ignore the word class for now because we're not going over classes right now. But just think of it as like a function. As you can see here, these are what I was talking about with the parameters. They do different things, right? Start, you can read about it probably somewhere here. So right here, it tells you are determined by the formula. This is stuff that you really need to know. Here you go. So start. Start is a value. The start parameter is 0. So it's just start value. It just tells you what it is. And stop is a stop value. Step is a step value. It's telling you here. And we'll go into this in detail right now. But just know that these are documented here in documentation. And you can see different parts of it. And I don't know exactly where it might be. But it will be in here somewhere that it tells you. Let me see if I can find it real quick. I don't want to spend too much time on this, but if I can find it, I want to show you. Oh, right here. So I think step argument submitted. It's in here for sure. Okay, we're gonna skip it for now, but it's in here for sure. I promise you that. I'm just kind of skimming through it. But just know that the documentation, as far as like for something goes, it tells you anything you need to know, everything you need to know about the function itself. Because again, these are the people that actually wrote these functions, so they have to tell you how to use them, right? But again, the reason I opened this up is because I wanted to show you that there's parameters. So parameters in the function are just values that you pass to a function, and they tell you in those functions that tells you what to do. So it gives you like a starting value in this case. And now let me just show you here to kind of make it a little bit more understanding. So in this range function, let's pass a number 5. This is a 5 here. If we press enter here, it shows you a range from 0 to 5. Now, the reason that this printed this is because this is the function, right? And this function by default does not have a print statement, so it shows us this. But if we use it, for example, in a loop like this, like that. Now, let me explain to you a few things. So for is the type of loop. There's different types of loops. There's or I guess too many types of loops. There's a for loop and the while loop. The for loop is a good way to iterate over something if you know how long that thing is. So, for example, here we're going to do in. I'm going to just copy this real quick to show you and I explain it to you. Okay, so check this out. For, again, it's just a type of loop, right? That's the type of loop that it is. You don't have to know too much about what it does. Just know it's a type of loop. I, in this case, is a variable. Now, I know that for variables, we've been defining them using the assignment operator, right? So, like, a variable equals some number. In this case, you could think of the for loop as the I being a variable that's assigned to something. It starts off at 0, by the way. So that's how it is. It's just assigned a value. Now, in is telling us that it refers to this, the range of 5. And I think it makes more sense. I should say that I like Python in one way because it kind of, if you read it as English, it kind of makes more sense. So if we just read this, it says for I in range. So basically that's saying for every single element inside range, then we do I. Now range is a value from 0 to 5. As you saw, we printed here, right? So that's from 0 to 5. So range is a value from 0 to 5. So if we want, we could actually do this. We enter that, hit tab but not for to indent it. We have to do that. We'll do print, and we'll do I like that. Now, if we print that, we know that I, again, it's a variable name, so I is valid. So when we do this, it's not going to give us one of those things like it's undefined, because we're defining it up here. And we know that range is a number from 0 to 5. So we go ahead and print that, and hit enter that. As you can see, we get a number 0 to 5. Now, one thing I want to point out is that in range itself, 5 is exclusive, and that all that means is that it never actually reaches 5. So as you can see, we only got up to 4, but we have 5 values. 1, 2, 3, 4, 5. Now, the reason I wanted to do this first is because you get to see this exclusive and this inclusive and exclusive thing. Basically, inclusive, the first thing being inclusive, all that's telling you is that, and I should probably refer to the documentation here to not confuse it too much. We saw that in range, that was the start, 0 was the start value, right? So we're starting, just in case it didn't make sense, 0 is the start value, and then the next one is the stop value, so 5. So this is going from 0 to 5, but by default, if you just put the parameter here, it does it from 0 to whatever number it is. So I did by 5, and that's just giving from 0 to that. But you could have written it like this too. It's just from 0 to 5. Just want to point out that real quick, because I know that might be confusing. So yeah, what was I saying? Oh yeah, inclusive and exclusive. So with range, the first number here is, what's that noise? Outside. That first number here is inclusive, meaning it's actually part of the list, and exclusive, meaning it's not in the list, but it goes all the way up to that range, if that makes sense. So that's the same thing that works with lists. So in lists, this value here, the first value, the way you access that, by the way, they're called indexes. And let me show you the index real quick, because it might make more sense that way. So again, we know that names are like that, right? We have that value of names. If, for example, I wanted to go ahead and access a name here, one of these names, we use the brackets like this, the square brackets again. And these are not, it doesn't mean list. It's an index. It's a way you access a variable or a value within that list. So in this case, you use numbers. So you use like 1, 2, 3, 4 to access the index of a list. Now, if you're new to this stuff, you might think, okay, well, I want to access the first name. So the first name is actually Alfredo. So I'm going to go ahead and use 1 because that's the first element in the list. So if I press enter on that, you saw we have Tim, right? Now, that's not a mistake. Maybe I should point this out. If you're ever doing something and it's not working, it's unlikely that it's a programming language that's not working. It's probably you, that you're doing something wrong. In this case, it is. I've been in that scenario before where I'm doing something, I'm like, yo, something has to be broken here. Like, it can't be me. Like, there's a bug somewhere. It was me. So it's always like, it's unlikely that's wrong. There's a bug wrong with it. So yeah, let's go through here. So yeah, names, we went with 1, but it gives us his name Tim. Now the reason is pretty much the same as this. In lists, the name starts with the numbers, the index start with 0. So the first element in the list is actually the number 0, and then we have 1, and then we have 2. So that's why when we used 1 to index a list, we got Tim instead of Alfredo. So if instead we use names and we replace 1 with 0, we get the name Alfredo. You see that? Because now we know that the list starts at 0, not at 1. That's one of those things where it's kind of hard to get used to at the beginning, because you gotta constantly remember. There are some languages where the list starts at 1, but for the majority of languages, it starts at 0. So just keep that in mind, and kind of, I guess, learn to think that way. Whenever you see anything in the list, think of it starts with 0. It doesn't start with 1, because then you'll make mistakes like that, like using 1 instead. So yeah, that's for that. Let me keep going here. Oh yeah, let me show you the loops. So again, like I told you before, we could access like that, right? We could access things like that. Now in Python, what we could actually do instead of using range is use a list. So we know that there's actually 3 elements inside this list, right? And we know that 0, the last one is exclusive and this one's inclusive. But let's do a for loop right here. So let's do for name. So name, is again a variable. It's not a variable that we define anywhere. It's just a variable that we're defining within this for loop. That gives me something to show you. So now, actually, if we print I, remember before we use I out inside our loop here, right? If we use I here, it actually works in here because we're still within the scope of the thing here. But later on, what I'm going to show you is I'm going to show you a reason why it might not work later on when we're doing a program. I actually thought that wasn't going to work, but I guess we're still within scope, so that's interesting. Okay, so we'll keep going here. So we'll do the for loop, right? For name in names. Now, what I'm doing here is I'm going for name. Again, name is a variable that we're defining within right now. We're defining it here. And names is the names of our list. So this is the list that has all our variables. So in Python, the language or the interpreter is smart enough to know that when we say names, we actually mean these names. And what it'll do, it will actually split it up for us. So it will make it so that every single name within names has a value with these at the beginning. So to make myself more clear, what will happen is that during the first time the loop, remember this is a loop, right? So it runs and runs and runs over and over. During the first time the loop runs, what it'll do is it will assign the value, the first value, the value 0 from names to name. So it'll be like, okay, the first time it runs, the value Alfredo is inside names. The second time it runs, the value Tim will be inside name. And the last time it runs, the value Jimmy will be inside name. So what we can do, go ahead and enter on that. Go ahead and hit tab on that to indent it. And I'll show you indentation, but you want to do that later again. But if we do print, in this case, let's do name, like that, right? We know that name has a, again, every single time it runs, name gets assigned a value according to the list. So we press enter on that. Enter on that again. As you can see, now we have the name Alfredo, we have the name Tim and Jimmy. Now, this might not seem obvious at first because when we're pressing enter, it's just showing us other values. But what's actually happening in the back, it is looping. Like it's going through the first one and it's going back up to the top. And it gives you the value name with Alfredo, and it goes back to the top, and it gives you the value Tim with name, and it goes back to the top here, and then it does that over and over and over and over. So it is looping. It just doesn't seem obvious because for when it happens, it's really fast, and then also because it just shows you everything like right away. So just keep that in mind. Let's keep going through the flow here. What else we have? These are more loop stuff. Yeah, let me show you that. Why not? So again, these a name is it's a type, right? It's a type of thing. So sorry, not a name, a list. A list is a type of, it's a data structure, but it's a type of something. It's just keep that in mind. I don't want to confuse it too much with data structures, but it's a type of something, right? And that's inside the variable names. Now these lists or these variables or these data types, I should say, have functions to them, meaning you could perform actions, right? I remember I told you before that like print is a function, right? You can do things with it. Now the same thing applies to these types that have different functions to them. List has a function called length. It's short for length. So what it does, it gives you the length of the list. So if we go ahead and put names in here, it gives you the number 3. Now, before I was talking about how when you index something, right? This is like the index 0, this is index 1, and this is index 2, but we got the number 3. So I just want to point out that length is not the same thing as the index. So when you do length, you're literally getting back the length of the list. In this case, we have 3 items, right? So if, for example, let's override it, right? Before I so you can override variables, variables. So let me override names with John. We go ahead and do names now. We only get one list in it, right? So now if we do length, and then inside we put John. Oh, sorry, names. The list. We only get the value 1. We don't get 0. Because again, it's actually how many elements are inside the list. So in this case, we have one single element called John. And that's just a value of 1. So that's how that works. Now, the reason I want to show you that is because we could actually go ahead and, you don't have to, but it's a little more complicated, but we could do this. Check this out. So let's do a for loop again. In this case, we'll use something called index. Again, index is just a variable, right? It could be literally X, Y, Z, whatever you want to call it, but we'll do index and I'll show you why in a bit. So for index in range, remember range gives us a value of list that we could like, it's a value from 0 to whatever, depending on what we put in here. In this case, we'll do length and we'll do names, right? So this seems a little complicated, but let me explain it to you. So range, again, it's a function that gives us a from 0 to whatever we want to go ahead and iterate through, right? From that. And then length gives us a number back. So in this case, we know length, the length of names, we showed over here before is 1. So the length of the name is 1. So we're going to read this from the inside out. So we'll do that first. And then we know now that inside range, the value 1 will actually be inside range because this evaluates to 1. We showed it out up here. That equals 1. So in here, this is 1. So inside range is 1. So this is the value 1 here. So I want to do that. Now, again, the for loop, we'll use a colon like that. We'll indent here. And what we'll do is we'll print here. And now, remember how before I told you that you could actually go ahead and use brackets, right? To go ahead and access different parts of a list. So what we could do is we could do names, brackets, and now we can use index. Now, remember when we did range before, up here, we did range, and range gives a value 1, 0, 1, 2, 3, 4. Now, that's the same thing that's happening here, except we have one list by itself. And remember, the last one is exclusive, which means that 1 will never show. And the list, the iteration starts at 0. So we get 0, but we never actually get 1 because it's exclusive. So we get the value 0. So in this case, when we're going through the for loop, it prints names at index 0. That's why I call it index, because it's an index. We call it print names at index 0. So as you would expect, it only prints John. So we press enter on that. There you go, we have John, right? And we can do that with a longer list so you can see kind of a better example, right? Mike. Okay, we'll do that. We'll do the same thing here. I'm gonna just press up to do the same thing, right? Press up here. Oh, let me just actually indent here. We'll do index. Remember, we have to go ahead and do names at the index, like that. And then now we have more than one list, right? We have index 0, we have index 1, and we have index 2. But remember, like that, 0, 1, and 2. But this is the length, right? Now, if we were to go ahead and print length for names, we'll have a value of 3 because there's 3 of them. But remember, it starts at 0, it goes down to 3, right? It's 0 to 3, but 3 is exclusive, meaning it never actually shows in the list. So we have 2 at the bottom. So that means that we'll go from 0 to 2 when we're in the list. That's index 0, index 1, and index 2. So we'll go ahead and press enter on that. So you can see it prints all the names out. So it's just a different way of thinking about it. And I guess it's a good thing to show you that different things have different functions. And I can show you some more of those now. Why not? So for example, let's do a string. Let's do a Alfredo. Right. And I don't want to get too technical on this, but know that a lot of times certain data types have the same functions as other ones. So if I want, I can do length on name, which is Alfredo, and we get the value 7. Now this is in the list, but it tells you how many letters there are or how many characters there are inside a name. And this is there's 1, 2, 3, 4, 5, 6, 7. So that's what we get the value 7, right? And this is we use this for that. Note that it doesn't work for all of them. So yeah, I just want to show you that real quick, that you can use different functions with that, and like the more you use them, like the more it'll make sense. I think later on in the documentation there is a section talking more about data structures and lists, and you'll see some more functions up here, so we'll see that. Okay, let's keep going here. We did ranges. There's a sum function, which is kind of cool. You could do sums of a range of a number. Sum is just like addition, right? So for example, let's say we have a range of 4. Remember that 4 is exclusive, so we actually only get the value 0, 1, 2, 3, and not 4 because it's exclusive. And then sum just adds them all up, so we just get the value 6. And again, I'm just gonna go through this, but you can always come back to this documentation, and I will go ahead and post this whole thing later on in the Learn with Alfredo channel, so you can actually go back in here if you want, and you'll see the links that point back to all this stuff. We'll keep going here. List range. This just gives you a list. So the function list, if you put it inside the range, it gives you a list back. So again, we know that 4 is exclusive, so it gives us 0, 1, 2, 3, and not 4, and then mix it into a list. So it prints it out like that. Break and continue. Okay, cool. Break and continue. So in Python, let's actually, I think it might make more sense for you if I actually make you like a small little program here. So we have this this idea of break statements, and did they ever? I don't think they ever showed while loops, huh? Oh, they're showing them later. Okay, so we have this idea of break statements and pass statements. So a break statement, all that is a way of you telling the program to break within the innermost loop. So in Python, you can actually go ahead and, I should say in Python, in pretty much any language, you can go ahead and nest things together, which might seem kind of strange, but let me show you that. So let's make a list called numbers, right? Let's do numbers of 0, 1, 2, 1. So number from 0 to 5. Again, this is a list, right? So we print that out. It gives us numbers. Name is not defined. Where's that coming from? Okay. My bad. So check this out. I misspelled numbers, right? So because I'm looking for numbers, it's not showing up because I misspelled it. So if I actually use this, numbers, then we have it. So keep that in mind. If you ever make a typo like that, and something's not working, just go back and look through that stuff. Because as you can see, it told me that numbers is not defined because I never actually used it, right? So it's like, what is that? Like, you never told me anything like that. So let me just go ahead and kind of fix this for the purposes of spelling things correctly. Numbers, which is cool that we caught that, right? Because then you get to see kind of an example of when things go wrong, and you're like, how's it not defined? You that I put it in there. It's in there. I saw it. I typed it out, but you typed it wrong. So we have that. Now we also have names, right? We defined the names before. So what we'll do is we'll do a nest. Let's do this. So we'll do, and this might get kind of trippy, but just I'll explain it in a bit. So we'll do we'll do name in names like that. Enter, hit tab on that, just do the indentation. And then what we'll do is we'll actually go ahead and print in here. We'll print name. So again, like we did before, all this is going to do is going to go through all the name lists and print out name. That's what's going to happen for there. But like I said, we could actually nest things. So you press enter again and then tab one more time. We could actually do another for loop within this for loop, right? So, and it's weird, but it's cool, and you'll see why I'm doing this in a bit. So we'll do that. And then in this time, we'll do for number in numbers. So we're going through all the numbers inside numbers. We'll hit tab on that. Now, keep in mind that I want to go ahead and have whatever I want to do, I want to make it inside here. So I have to indent one more time so I can do it in here. So from here, I'm going to go ahead and print number. Let's go ahead and enter on that. Check this out. So the way this is happening, you got to kind of think of it step by step. So the first thing we're doing is we're going here, right? And remember, I told you these are loops. So there are things that are looping over and over again. So if we go in here, we go into name, for name in names. We'll go in here, we'll print name. That's the first thing we'll do. So we get John, because John is the first thing in our list, right? Like that. And then we'll come in here, we print name. We'll go into our second for loop. Now in our second for loop, we have numbers. For numbers to numbers, we print number. Now the first element in numbers is 0. So we print that out. But as you can see, you might expect it here to go back up to the top here, but that's not what happens. What's happening here is that within this inner loop will not stop until it's finished. So the innermost loop is always going until it's done completely. So what's going here is after we do that, we print 1. It goes back up because it's a loop. It's looping, and it prints. Prints 0, and it prints 1, 2, 3, 4, and 5. Right. So it goes through all the thing here, and then only once it's done, only once this is done, we go back up to the top, and then we'll go to the next element. So the next element is Alfredo, because we saw that right here. It's Alfredo, and then we come back in here, and again the innermost loop always repeats until it's done. So it comes in here, and it's looping, right? It goes 1, 0, 1, 2, 3, 4, 5. So we have that like that, and then this loop goes back up again to the top right here, and then the next item in the list prints, because it's the next item in the list. That's Mike, and then we'll go back in here, and the same thing, 0, 1, 2, 3, 4, 5, like that, and that's what we have this output here. So that's what that printed out. But for example, let's say you wanted to stop the loop once you found the name Alfredo, right? And the reason you might want to do that is because, let's say this is a small list, right? We just have the numbers 0 through 5, and we have names John, Alfredo, and Mike. That's a really small list. But if you have a huge list, let's say like a list of like 5 million elements, which you might not have enough memory for. But let's say you have 5 million elements, right, of like complex data types or just simple data types. If you do that and you keep going forever to find the name Alfredo, even once you've already found it, then you're gonna be waiting forever until the execution is done. You don't want to do that. You want to go ahead and stop once it's done. So I want to show you that. So I'm gonna go ahead and show you the break statement. So as you can see here, they talk about break. So the break statement always breaks the innermost loop. So for example, if we do a for loop here, for name in names, right, and then we print, okay, we print name like that. Oops, still gonna use the keyboard. So we'll print name like that. As you expected, right, before it'll go through the list and it'll print all the names out. But if we use a break statement here, which uses this, it uses break. This is telling us to break. So as you would expect, it'll go through the loop, it'll print the first name in the list, and then it breaks, meaning it'll stop. And it always stops the innermost loop. Since in this case, all we have is one loop, it's gonna break out of this loop. So as you can see, it only printed the first name and it never got to anything else because I'd say we broke it, but we did the break statement. So like we stopped the execution from happening right there, right? So now let's do something more interesting. So if we have names, I want to stop the execution once we hit Mike. So what I'll do is I'll print name, and then we'll use one of those if statements that we used before. We'll do if name. Remember, this is the double equal sign. Remember that double equal sign means equality, right? We're checking if something is equal. We're not assigning a value to anything. We're just checking if something is equal. So we'll do if names equals Alfredo. Sorry, we did Mike, right? If names equals Mike, then we do something else. In this case, we're going to break. So to explain this to you a bit, like before, right? We're just going through this list and we're printing out names. But here, we're checking if name equals Mike. Now this is valid. This is an equality sign. Remember before we checked whether like number was equal to 2, right? And that was true. In this case, we could do the same thing with strings. So we could check if name is equal to Mike, and that basically just means if the name is Mike. Now, keep in mind that this is case sensitive. So if we were to use lowercase m here instead of capital M, this will be false because Mike does not equal Mike with lowercase. So it has to be the same. So in this case, uppercase Mike equals uppercase Mike. So that should break, and we go ahead and enter on that. We saw that. So it broke right after Mike. Now, keep in mind, this is interesting, right? Because you might expect for this to happen, what you might expect here to happen is that Mike never prints out. But this is one of those things that is important to know, like, and I've seen this before. I think somebody contacted me a while ago on Discord. They had a problem. They couldn't figure the problem. The order in which you do things is important. So here we're printing out Mike. So because we're printing out, we're printing out all the names, right? So because we go ahead and go here and we print the name before we break, that means that we're actually printing out Mike, and before we actually even get to Mike, then we break. So it's like we're actually printing it. So if you, for example, wanted to stop so it wouldn't print Mike, you would actually go ahead and put the if statement above here and then Mike print below it. That way it never gets to it, right? We don't want it to get to that. So if we go back here, names, we'll do the if statement. Let me just type it out here. Same thing. So if name equals Mike, then we're going to go ahead and break, right? And then if it's not, I'll show you that in a bit. Name, then we'll print name. So as you can see, we never actually reached Mike now, right? Because we broke the loop before we even got to name. So keep that in mind, especially when you're using break statements. The order in which you do things is important, so you got to keep that in mind. Okay, so we have that. Let me keep going here. Different operators. We also have a while loop. A while loop is a way to go ahead and do something when the way I like to use while loops is you'll do something if you don't know how long something is. So in this example, for example, in the example of the lists, we did that because we knew a for loop, because we knew how long a list is. And for a range, we know how much a range gives us back, like the values it gives us back. But for a while loop, you might not know how long you're going to do something. So you could do while true, while something is true, then you do something. So we'll do print like that. And as you expect, look at this, the bar down here. You see this is moving? That's because it's continuously printing all forever. It's doing it forever. To stop that, you usually hit Control C, and that stops that. It's a keyboard interrupt. So yeah, that's not forever. Now, if you didn't want it to do that, you might assign a value to like, let's call it loop. Let's equal that to true. We'll do something like while loop. So while loop like that, and then we'll print the same thing here, like that. And then what we'll do here is we'll actually assign the new value to. Should I do that? Yeah, let's do that. So it'll stop right away, but you'll see. So we'll go ahead and loop like that. This is one of those things that I see people not using. Like they're using a while loop, but they used to, for whatever reason, somebody told them somewhere to use this while true. And then what will happen is that it'll go forever, and then they'll be like, why is my loop going forever? Well, because you're doing while true. So it means that while forever, it's just keep looping. But in this case, what we're doing is we're adding loop. Now, loop is it's known as a loop control variable. It can be named anything, but it's a loop control variable, meaning it's a way for you to actually go ahead and control your loop. So in this case, we're looping through here, and at the end, we're making loop equals false. So that means that once we're done with this loop, it will go back up to the top, and then loop will now be false, so it will never execute again. That's a loop control variable, and you use that to like whenever you want to stop it, or like we said before, you can use break as well. Break will break the loop. So we'll do that. So you can see it only printed it once, right? Because right after, loop was set to false and it never executed again. So that's what that is. It's another way of thinking about it. Okay, now let's get to functions. Like I said, if you're at this point where you're like it's a lot of information, it is. It's a lot of, I agree. It's a lot of information. But again, this is one of those things where you kind of have to go ahead and sit through here and then just kind of go through all the stuff. You just kind of, go through it. And I know you're going to be like, I'm tired of this, What we'll do right now, I guess, is a good time to kind of just take a break because I need water. I need some water. So we'll do that. If you want to go do something, we'll just take a break and then we'll just come back in a bit. If anyone has any questions at this point, feel free to ask. Let me just get my water real quick. Yeah, if you guys have any questions, just go ahead and feel free to ask whatever you want. It doesn't even have to be related to this. If you want just like a general question, go ahead. Remember, we also have the chat. So if you want to go ahead and ask something in the chat. If you're too shy to ask, just go ahead and do that. I should probably go ahead and set up like a time. So, I mean, unless you guys are ready to go, I don't know if you guys need a break or not. Just let me know. If you need a break, we could just keep going. I'm good with it. Cool. Okay, I guess let's just keep going, guys. Hopefully no one left to the restroom or something. Because then they'll be like, oh, what happened to the break? Okay, so we'll keep going here. So we have functions, right? Where are we at? We're in 4.6. We're going all the way to 7. So we're almost there. Like 3 more sections, so we'll be good. So defining functions. So functions, like I said before, are statements that you could pass to Python or to your interpreter, however you want to think about that, that actually go ahead and perform an action. So before we use the length statement or the length function to do, this should be still here. like that, right? And it gives us the length of how many names are available inside this list. So that's a function. This is the function. Whenever you see these what are these called? Parentheses. Whenever you see open and close parentheses, that's a function. That's how you define a function. Now, we could actually go ahead and make our own functions like you would imagine, right? Here they have one of the Fibonacci sequence. Let's not get into that because it might be too complex to think about. But let's do a simple function. Let's do something. By the way you define a function is you use def. Def is like definition or defining. Right here. The keyword def introduces a function definition, right? So that's how you use that. And then you give the function a name. So let's make a function that prints a name. Why not? So let's do this. Let's call it print name. Check this out. Notice how I used a lowercase here to separate my print and name. This is Python convention. I believe it's called pip8 or something like that. The actual convention they use. A lot of languages use something like this. Oops. A lot of languages use something like this. They'll do, like, to denote a space, they'll do camel case, which is like this. Print name. Like that. That's it defines a space. So whenever you see a capital letter, it's a space. Now, you could do that in Python. You could, if you wanted to, you could actually go ahead and use a capital letter to define wherever there's a space, but that's not convention. So it's always good to stick to the convention, especially because if there's somebody else that's also programming in Python and they use a convention, if they come in here and they see that, or actually if they come in here and they don't see that, they might start using this convention. And if they do that, then you're just going to have code that's all weird because the conventions are just like mixed, and it's just, there's different conventions as well. So it's just a mix of conventions. So I like to stick to it depending on the language I am using. So if I'm using Python, we use underscores to go ahead and define spaces. So let's go back to this. We'll do def print names like this. And what we'll do, we'll end it with a colon there. That's how you do it. And it's just like before, right? Before I told you I was going to talk about indentations. This is the time to talk about it. So in Python, whenever you want to go ahead and do something, and you'll see this whenever you use colon like that. All this is saying, the indentation here, as you can see, these are all indented in the same space. This is just telling you that within this statement, this function statement, this is the stuff that's inside of that statement. So this is really important in Python. In other languages, not so much, because some languages don't use indentation. They actually use like curly braces. Let me show you that real quick. I can actually just write something for you. Let's just open up Notepad. So some languages do something like this, but they'll be like, the convention is different. I'm going to show you kind of the same thing, right? So do something like print names int. It's just telling you that it's an integer. In some languages, you have to define different things, right? So we'll do something like that. And then they use this. They use curly braces like that. And within these curly braces is how you know that everything within inside the curly braces are part of the function. So if I do, this is Java, or whatever you want to do. Let's just mix stuff here, not confuse you. But we'll do something like this. We'll print a value in here. And now everything inside here, everything I do inside this statement is part of this function. Right? So that's kind of nice because you don't have to worry about indentations. But with Python, you kind of do have to worry about indentation. So what you have to do is actually go ahead and, where's the documentation? You actually have to go ahead and keep these spaces the same. So every single time the space is the same, it means that this belongs to this function. Same thing with this while loop. As you can see, we have this while loop and we have this colon here. And then everything within this while loop has the same indentation. Notice that the indentation is not the same as up here because now we're inside the while loop. So the while loop is part of the function, but everything inside the while loop is part of here because we'll have this indentation. If you mess up your indentation, you'll get errors, and it's a lot harder to kind of sometimes figure out where your errors are because it might tell you that you have an error with syntax, and you're like, where's my syntax error? And it's a lot harder. So just keep in mind to kind of make sure your indentations are correct. So that's that. So I do def print names, right? At what point do we switch? Give me a second. There's a point that I do want to go ahead and switch over to a code editor so we can see how that works. Oh, it's actually here. Cool. Good thing I caught that. So at this point, we'll switch over to a code editor. And the reason I want to do this is really to show you the spacing stuff, like the indentations. So we'll go ahead and make a new file here. I'm gonna just call this tutorial. Notice that I use .py. So whenever you make files here in, not just in this like program, but anywhere, a Python file is denoted by having a .py extension. That just means Python, and the name doesn't matter. In some languages it does, by the way. In some languages the name matters a lot when you talk about classes and stuff, but in Python it doesn't matter. You can name it anything you want. But it obviously, for good purposes or for just good code structure, it makes sense to make it related to something. So if you're making a program that, I don't know, calculates Fibonacci sequence, then you might want to go ahead and call it Fibonacci.py, just to make sure that it makes sense and not something like cars.py, because that's completely unrelated, you know. So it's just good thing to do that. So we'll get coding here. By the way, the way I hid that was using Control B. I just don't want to see this because my window's smaller. And I did zoom in the screen for you guys, so hopefully this is good enough. If not, just let me know. But we'll do a function. So again, the way you define functions in Python is using def, right? So use def. You'll see things come up here. This is part of an add-on that I installed in VS Code. If you want to do that, you go to over here to the extensions, and you go ahead and type Python right here. You just go ahead and type it in and you install this. It just makes it so that you can go ahead and see auto completion stuff, which is nicer if you're starting out, I guess. So we'll do def, and then we'll call this print names. Right? And then we define a function by having these things here. This is where the parameters go. So if you remember before when we were using the length function, right? Or sorry, the range function, we did this, and then we give it a parameter, right? To give us back a value. So like that. This is a parameter. So somewhere within Python's code base, somebody actually made a function called range. Somewhere else, they made a function called range. And then they made it so that you take a parameter inside. In this case, they took 5, right? So in our case, what we're going to do is we're actually, before that, let me show you without it so I can show you. So we'll do that, right? And again, we indent it to make sure that our indentations are fine. Ignore these dots. These are just for me. I like them because they show me like the spaces, right? They show me how many spaces there are, like blank spaces, but they're not actually part of the code. They're just dots to show me the blank spaces. So we have that. And then what we'll do is we'll print. Remember, print is used to print something, right? And now that we're actually using like the actual a program, we're making a program, we can't just type a variable like that and then expect that to print it out. That's only in the interpreter. So if we want to print something, we have to use print. Now let me print Alfredo here. Right? And now we have that. If we go ahead and save that file, in VS Code, you can go ahead and open up a terminal by using Control tilde. Tilde is that squiggly line that you see at the top of your keyboard. That line right there, that's a tilde sign. So you press Control and tilde, you'll go ahead and open that up. So we have that. And then this opens up this terminal here, this command line. And we could use this to run our program here. Clears the screen, so we can use it to clear. ls is a way to list our listings. This works for Windows, Mac, Linux. ls is a way to list stuff. So in this case, we see that we have a tutorial.py. That's just a program. It's called tutorial.py. And the way we run that, and this is important, because we're using VS Code, it automatically go ahead and gives us the correct directory, which in my case, this is the directory for it. But it's important to know that to run a program that you're working on, you have to be within the same directory. So if you make a folder, I'll show you that. So here I have a folder called discord.py, which is what I'm using, right? If you make this folder, for you to run this program within VS Code, you have to be inside this directory. So actually, let me just show you that just in case there's no confusion. So if I do, you can go up here, the open workspace, or open folder actually, you go there, which is Control K, Control O. So you can use that to open it, like that. And then I'm going to go ahead and click here, and I'm going to go ahead and open this directory, because this is the directory I want to be in. Now, that's important because when I run this program, I have to make sure that I'm inside the right directory. Otherwise, if I'm not, it's not going to find the file. This file has to be found. And the way you do that, in Windows, is use py, followed by the name of the file. In this case, tutorial.py, right? This is just denoting that it's the current directory. It did it by itself, but you can do it without it. In Windows and in Linux and Mac, what you'll do is you'll write the whole word Python followed by the program. Now again, at the beginning, if you were here, I told you that Python actually in Mac and Linux is pre-installed with version 2. So if you're doing that and you have version 2, make sure you use Python 3, or else this like this won't work, because this print statement with the parentheses is a convention used for Python 3. It doesn't work in Python 2. So if you get something that's not working, it's probably because you're using the wrong version of Python. So I use Python 3. In this case, I only have Python 3 installed, and then we'll go ahead and do tutorial like that, and we'll do that. Now, as you can see, the good thing is that when we ran that, we didn't have anything else. If you ever have an error, this is where you'll see it. And I don't know if it'll catch it at the beginning, but it might. Let me see. We'll do that. We'll skip a T, and we'll do that again, like that. Yeah. So something I want to point out right here, it didn't catch it. So compared to other programs, Python is an interpreted language, which basically means things don't get compiled the way they usually do it in a different language. And I don't get into that, might be too complex. But basically that means that you won't know if you have any errors until you actually run it. That's one of the things of Python. You just won't know. There's a thing called compile time and runtime. But at compile time, you won't know if you have errors because Python doesn't really check that. I think sometimes it might. I don't know if it does all the time. But it won't check that. But you'll know if you have an error at runtime. So just gonna keep that in mind. So let's add this T again here. And then right now I'll do it without the T so I can show you that how things don't work. And then as you saw, nothing happened, right? What we want to do now is we want to call that function. So remember, the way we call functions is we'll call the function name, right? And then we'll use parentheses. These parentheses are a way of telling you that you're calling the function. If you don't use this parentheses, it will call the function. It's like a reference to the function. But if you don't use, just know to use them if you want to call a function, right? We'll do that. Save that file. We'll go ahead and press up here to run it again. As you can see, we printed the name Alfredo. That's what the function did, right? We ran this function, and inside this function, we printed Alfredo. So that's what it does. Now, it might be even cool if we actually go ahead and make it so that instead of using Alfredo, we could pass any name to it and then print that. So that's where variables come in. So if we call a variable here, we declare a variable called name. This is like that time when we used the for loop, right? We didn't actually have to declare it like anywhere. We just state it. That's the name of it. These are the names that are going to be passed to this function. Now, instead of using Alfredo, because like I said, this is a variable name, we can just go ahead and replace that with name. And then when we pass a name, right, you can see I have this here. And it's actually telling me that the reason it's not happening, again, this is part of the Python add-on if you want to go ahead and install that. It's telling me that there is argument name in function, no valid parameter. So basically it's telling me that I don't have a parameter, but this function requires a parameter called name. So if without it, it's telling me there's an error, like this is not going to work. If I went ahead and run this, let me save that, run this file. As you can see, we have, right, we have an error and it says missing one required positional argument name. So we're missing the name here. We don't have anything, an argument, so we have to pass that in. So what we can do is we can pass that string in, like we did before, like that. And now we save it, that error goes away, and now we run it, and we get the name Alfredo, right? And now we could actually, this is a lot better because now we have the ability to change whatever we want. We could gem, save that, go ahead and press up, and run that. Now we get gem, right? So that went through like that. So that's how functions work. In the bit here, we're going to talk about different types of parameters. So let's keep going. So that's functions, right? You could make them as complex as you want. I don't think there's any restart statements yet. I don't know if this comes up later, but we'll do return statements real quick. So return statements are how you actually return data from the actual functions itself. So instead of printing out, let's say I wanted to go ahead and store this in a name, right, in a variable. Now, as soon as I'm done with this function, I no longer have access to the stuff in here. So if I go ahead and, for example, I pass that in, and I print the print statement down here. I'll go ahead and run that. As you can see, name is not defined, right? This is what I was trying to show you earlier when in the scope of this thing and interpret it, but apparently it worked. I have to look into why that's happening. But anyways, within here, we can't access name because name is not a variable that's accessible to us. It's only accessible within the function, because we put it inside here, the parameter is only accessible within here. But if for whatever reason we wanted to go ahead and store, like get access to this name, Jim, what we can do is use something called return, a return statement. So get rid of print here, and we'll return name. So all this is saying is that once the function is done running, give us back this value, give us back whatever value I put in here. In this case, I want to go ahead and give us back, tell the program to give us back the name, the variable name, or just name. It could be anything, right? Now keep in mind that even though we have this here, this is still not accessible down here, right? So even if we go ahead and do print name, and I'll go ahead and run that again. So you can see name is not defined. You might be thinking, why, if I'm returning it, right? You told me that it gives me the value back. It does, but you have to go ahead and again realize that there's this thing called a scope, and the scope is just a way of saying that whatever your variable has access to, that's where the only access you have. So in this case, variable is only, the name is only defined within the print names function. So you don't have access to that anywhere else except within the print names function. So what you want to do, if you really want to use that variable, once you pass in names, you have to go ahead and set the names here. And the way you can do that is using a variable, another variable. So let's put this let's call this return name, like that, and we'll equal that to print names. Now, I don't know if I return, let's call it ret, ret name. So we'll do that, right? That's the name it returns. That's a variable name that it returns. And now that we have that, once this function executes, it returns that variable name, and that variable name is just passed to ret name. So now we have access to the name again. If I wanted to, I could literally call this name. It doesn't make any difference. Just know that name here is not the same as name here. These are two different things. These are two different variables because they have two different scopes, right? So this is different. So now if we go ahead and print name, go ahead and run that. As you can see, we get the name Jim because we printed it, right? We returned the value from this function and then printed it out. So that's how that works. Those are the return variables. Those are return statements are really useful if you ever want to go ahead and get something back from the function, right? Let's say you do some calculations here and you want that value back to use in the rest of your program somewhere else. You return it, you get access to that value again, and then you go ahead and use it. Okay, so we have that. No questions so far. Cool. Again, if you have any questions at any time, just ask, guys. Okay, so we have that. That's functions. Okay, so with functions. No, you're good, man. What's up?
Just a curiosity. Is it a common issue?
I have seen that. Yeah, I have seen that. So that's why I said like the scope thing. It is a common thing. So thank you for pointing that out. It is a common thing. Like, and I think I did it in my contacts thing. I told you what it is. It's the contacts. We're gonna be making a contacts program at the end. But I did that at the end of it. And I specifically did that, I think, because I wanted to show you that. Just keep in mind that it's not the same thing, right? Again, the scope thing. So within the scope, we have different names, and this is a completely different thing. And then one thing to keep in mind is that it's not, and I don't want to get into this, but I think it's a good time to do it anyways. This variable name is not the same thing as this. They're actually have, even though the scope is different, it's like a copy of it. So once we pass this here, this name in memory, this thing is gone. It no longer exists. So then we have this name. But yeah, common thing. Cool. Any other questions? Just go ahead and ask, guys. Okay, so we have that. So default argument value. So like before, I showed you this, right? We passed in name. And then when we did that, you saw if I didn't put anything in here, if I left it empty, it gives us an error, right? Because it's expecting a value here. It's like it's missing one required argument, but it's not there. In Python, and other languages as well, there's a thing called what do they call it? Default argument. So a default argument, it's a way to define a default argument. So for example, let's say we have name. We could use this and we could give it a value. So let's say this is Alfredo. Like that, save that. As you can see, the error went away now. We no longer have an error here. That line went away. The reason behind this is because name now has a default value. So even though I didn't pass anything in here, the default is Alfredo. So when we do that without anything, we should expect Alfredo back. As you saw here, we got the name Alfredo back, right? That's the default argument. Now, even though it's a default argument, we could actually pass in the value to it. So we could do something like this. We could do name and override the value like this and tell it, hey, I don't want Alfredo, I want Jim. We do that, run that, and now as you can see, now we have Jim, right? But we have that, and I believe you could even do this, see, because there's only one argument. You could do this. You could just pass it like that, and I think it should still work. Yep, still works. See that? So it still works. So that's just a default name, right? And you could actually go ahead and mix these things. So you could have something like, let's do an H. So let's name this function something else because we want to make it more appropriate. Let's just call it print person, right? And then we're going to change this to print person. And then what we'll do is we'll also pass in an age. We'll pass a name first, and then at the end, we'll do age. And the way you do that is you, like the list, like before when we had a list, we went ahead and we used commas to separate values, right? We do the same thing here for parameters. We use commas to separate values. We'll also pass in an age. One thing I want to point out is that this should be, and it does tell me, look at that. This is not conventional to do this, and it might not even run like this. I just want to make sure if it does or doesn't. One thing is that we don't have all of them. So let's just say we pass an age in. Let's just say 20. Like that. Let's just see if this runs. Yeah. So check this out. The reason this is not working is because it's in Python. What you want to do is you actually want to go ahead and make it so that the arguments that do not have a default value come first. They come before anything else. So like that. So you can see that now we have that squiggly line that goes away. That's just a convention, right? You use this, you use the name, anything that doesn't require a default argument first, and then after that, then you use anything that requires a default argument. So I could literally have anything I want here, right? I could have age, height, right, like that, and then again, as long as it comes before the default arguments, we're good. We're all good to go. So now let's actually go ahead and print this stuff out, right? So one thing that you could do is that because you could actually go ahead and pass them in order. That actually works, I believe. So if you do 20, 5, let's do 5 feet just to make it more clear. 5 feet is one of those things you can't define like that. That's not, like, what is that? That's not a number. That's not anything. So what you want to do is you want to make it in a way that it does work. So the most obvious thing for me is using like that. The guy's kind of short, but we'll do that. Actually, let's make him really short. Let's make him 1 foot. Okay, we'll do that, and then we'll we'll give it a name, right? So in this case, let's call him Jim. And again, if I don't use the string like that, this doesn't mean anything. This is expecting a variable name, but there's no variable that we define named Jim. So we gotta give it an actual type. So we'll print name, and right now, as you can see, we don't have anything here. We don't have any way of showing this. Right now, all we're doing is we're returning name. So let's get rid of this print statement, and I'm not gonna return anything. I'm gonna just print it within there because our function is called print person. So let's just go ahead and print them here. We'll print age, and we'll do them separately so you can see. We'll print height, and then we'll print name. Now again, these things are coming from here, right? From that, from the actual variables from the function that we defined up here that we're actually passing in. So we're passing in 20 as the age, and then we're printing age. We're passing in 1 foot as the height, and we're printing height. We're passing in Jim as a name, and we're printing name. So save that, run that. As you can see, we get an answer back of 20, 1 foot, and Jim, right? Because that's what we've passed around. Now, this is a default parameter, right? So if we wanted to, we could just not pass like that. We could just not pass the last one and go ahead and do that. And as you can see, now we have 20 feet, 20, 1 foot, and Alfredo, because that's a default name for it. So that's the way that works. There's more complex ways of doing things. Or also keep in mind that this could be anything. These types could be anything. If we want, we could pass a whole list of stuff, right? We could pass a list of stuff. Well, I mean, let's just say we have names, and then we have a default parameter, right? Of like Alfredo and Jim. So that means that whenever we access this here, we access names. We could do that right here for you. Like that. We should see Alfredo, that's misspelled, like that at the end. So we go ahead and run that. As you can see, now we have that as well, right? So what I'm trying to say here is that you could pass anything you want to a function. You can pass any type of numbers, lists, even objects, which we probably won't get into today just because that's like a class thing. But you can pass anything you want into a list and then use it within that function. So keep going here. So that's default argument, like I explained. Again, you could pass lists if you want. You can pass anything you want. This is just an empty list as the default parameter. keyword arguments. We talked about some of that stuff here, like that, like these default one stuff. Different ways of calling it. So there's a variety of ways of using the functions. You could call them like we did right here, or you could call them differently. Like I said, we actually did it in order, right? So we could do it in order, or we could actually give it the name, and then like this, like we did before, right? You can pass like that, or just pass them in order. We have that. The pass statement, this is useful if you're ever working on something. Or at least that's pretty much the only way I've ever used it, with the exception of some things here and there. But let's say I'm like planning out a program, right? I'm planning out a program, and I want to go ahead and I know that I'm going to need a function for adding numbers up. So we'll do def add numbers, and we take two numbers. We take number 1, and then we take number 2, like that, right? And then the thing is that right now I'm just kind of planning my stuff out, and I don't necessarily want to do anything. If I just leave it like that, and I even if I erase these, as you can see, we're already getting red lines here. If I just leave it like that, right, and I'll go ahead and run that, it tells me that expected and indented block. So it tells me that, hey, you defined this function here, but you didn't put anything in it. You know, like, what am I supposed to do with this information? So what you could do is you could use pass. Pass literally is just like it sounds. It passes. Like, it doesn't do anything. It's just a placeholder for you to do nothing, basically. So if we do that now and run it, we're good, right? It went through the thing and they put a function here and it was fine because we actually gave it something. So that's really the only reason I've ever used it. Sometimes you might do something and like you don't want the function to do anything at a certain point, so you might just not give it pass. Just give it pass and do nothing. But that's the only reason I've ever used it. So we have that. Let's keep going here. Is my thing still going? Yep, we're still going strong. Good. Okay, so we have that. Some more function stuff. This is more of an advanced topic, I feel. But basically, you could go ahead and pass it's kind of like a list. It's like a list of keywords that you could use as arguments. So let me just explain this to you real quick if you want to see that. So in this case, if we pass keywords here, right? These keywords are actually statements like variables themselves that you could use. So is there right here. So it would be called like this. So for example, if you call it shopkeeper here, this is part of this keywords, these start keywords, like start arguments, args. Basically, you could pass things like this. You could just pass a function, call the function name, and give it a whole variable like that with a value. And then you could use those inside the function itself. So like shopkeeper, I don't see that in here, but just know you could use it. It's like a variable. So you can pass a whole variable and then use that variable within your function itself. Oh, right here, they're using a for loop. So they're using a for loop to print all the keyword arguments. But yeah, you can do that. Like that. That's, it might be useful for you if you want to pass something that's not in the function, but you might want to use it somewhere else. So I'll do that. This is another thing. You could use these things to split up. So like before, what we did is we went ahead and we gave it like the parameters that don't require any default, don't have any default values, and then the parameters that have default values. What you could actually do is you could actually go ahead and define specifically which ones are the ones that are default and not by using this. So anything before this is anything like the backslash. It's anything that's a positional argument that you don't really have to define anything. You just pass it in by position. And then anything before this tells you that it's the keyword arguments after it. Sorry, anything after this is keyword arguments, like that. So it's just a way to like kind of make your core more succinct. Like just define it better, so you can actually, I guess if you want to see it visually, you can do that. But it's not required. It's just one of those things that might make somebody looking at your code easier to read it and do that. Keyword arguments. This is what I was talking about before, right? You can use this to define any position arguments like that. And then this for the other ones. This is kind of stuff that I'm being selective over, just because, again, this is like an introductory course, so I don't want to go ahead and kind of give you all this stuff that's going to confuse you. We're sticking with like the basic stuff that you can still make things out of. So, and honestly, I've never even used this before. Like I read about this and I'm like, I never even seen that before anywhere else. But that's how it works. I was obviously, when I did it, I was trying it. I was like, that's kind of cool, but I never seen it. Argument list, list to unpack. Lambda expressions are really cool, but we might not get into that just because it's one of those things where is I guess I can explain it real quick because they are kind of cool. So a lambda function or expression, it's a way to have a function within a function, which are kind of weird, but it's like a smaller function. So for example here, this make incrementer function, what it does is that you start it, right? You define it, the make incrementer, and then you go ahead and give that to a value. Remember we talked about return statements, right? So whenever we return a value, we could get it back in the variable. So that's what they did here. They're returning a function, but when they call it make incrementer, they pass in an original value of n, like that. And then now for the next time, whenever you call it in another value, like we f0, we're passing it into the lambda function. Now this is how you define a lambda function. All this is saying is that this here is your argument. So x is the argument you're passing in, and then you're doing a function here. You're doing x plus n. So originally incrementer is 42. You pass in 42, that's 42, and then you call the function again. Now x equals 0, and then x equals 0 plus 42, which equals 42. And then you do it again. Next time you call it again, you pass in 1 as the value of x, and then x equals 1, and then equals 42. So you go ahead and increment 1 by x, so you get 43. So yeah, that's how that works. But I know looking at this, like just looking at this lambda function, is like, what is this doing? So let's not go too much into that. Document strings. This is for documentation. I encourage you to read this stuff if you ever want to go ahead and make a program that somebody else is reading, because if you do it that way. Okay, so someone's asking, I just saw it. Are you gonna take the class for another 10 minutes? So yeah, originally I was planning on going like 2 hours long with this, and I know it's getting long, but it's a lot of information. And after doing this, I realized, okay, we're not gonna finish this in 2 hours. There's no way. How many more topics can we cover? So right now we're going, again, even if you don't stay for the rest of it, at the end, what I'll be doing is I'll go ahead and I'll be sharing this with you so you can see all the topics. But after section 4, which section 4 I think is the longest, after section 4 we have to do 5 and I think some of 6 as well. Yeah, 6 is going to be super quick. So 5 and 6, which is data structures and modules. And after that, we'll be good. Like we can start making our program. So yeah. So yeah, if you don't stay for the whole thing, I know. I think somebody told me that like it's 11 p.m. where they are right now. And I get it, bro. Like if you can't stay for the whole session, you have to sleep. I get that. So we're just gonna keep going here. And again, if at any time you guys want to leave, I am recording the session, and hopefully that's still going. Yeah, that's still going. So I will be uploading this later, so you guys can actually see what we're doing. So yeah, just come back to it anytime. And as far as questions goes, no one's actually asking questions, so I figured whatever, you'll be fine. So still people are typing. Yeah, go ahead and leave your comments or whatever you want to know. We'll keep going here. Documentation strings. These are things I do encourage you to go through this if you ever want to go ahead and just kind of write software that other people are using, because then it makes it so that you could actually understand things. So basically there's just like comments, right? To like do that. Oh, I never showed you comments, did I? These are like really basic things. So for a comment in Python, the way you write comments, yeah. Someone said it's 1:25 where they live in the morning. I get it, bro. Go to sleep. I get it. Okay, so in Python, yeah, go ahead. Okay. Yeah, yeah. So they said, and I just thought about this. I don't know if my recording is actually capturing what people are saying. If it's not, basically what's happening. Actually, I don't think it is. I remember now. But anyways, we might have that. So we're doing, yeah, we're recording the session, like Jane said. We're recording the session anyways. But again, this is like one of those things where I'm just testing it out. It's like one of those first things. But I think later on, it might be a good idea just because of the timing and stuff and questions. I think if we ever do this again, we might split it up into different sections just because I do realize this is getting kind of long. So yeah, we'll do that. We'll keep going, guys. So, and again, in case I am not recording the thing that's coming out of my computer, which I don't think it is, I'll just repeat the questions so people know in the recordings what people asked. So we go into this. Yeah, documentation strings. These are just a way to go ahead and document things. Another way of documenting things is using comments. In Python, the way you do that is you use the hashtag, and then you go ahead and type a comment. Now, this is stuff, anything here with the hashtag, it's stuff that's not going to run. The program does not see this. This is just comments for you to like leave if you want to go ahead and understand something like this function prints a person, which is kind of weird to say. So that's all it is. It's just comments for you to kind of leave so that you know what's going on. But the program itself doesn't do anything with that. So that's a good way of kind of just keeping organized to know what you're doing, you know. So we'll do that. That's that. Functions, annotations. Yeah, this is the same thing with documentation. We'll kind of skip that. Not super important for us. Cool. And we're done with that. This is PEP 8 I was talking about before. This is like the convention that you use to like do underscores. It's like, it's a whole documentation. It's just how you actually write stuff. So this is important to look at too. It's just the conventions, as you can see here. var1, var2 have underscores. So yeah, we'll skip that, but just know that there's conventions for writing Python code. Let's move on. And I think that we're going to talk about, yeah, I recommend that. So if you're writing code again for somebody else, it's important, like especially if you're working, like let's say you're working with, the question by the way was, do you recommend letting comments for other people that may see your code or leaving comments? So yeah, that's important because again, if you're working, if you're doing by yourself, a lot of times I don't even write my own comments because I know what I'm doing. But in an actual position, like I've had internships before, if you don't actually write code and then somebody looks at your code and the more complex your code is and they don't know what's going on, it's frustrating. It's frustrating to sit there and take time out of your day when you have to do other stuff and just kind of go through the comment and like decipher what this thing means. So if you can leave comments, and again, that just comes from understanding your own code too. So if you don't understand your own code, you're probably doing something wrong because you're writing code that you don't understand. So you should probably know what you're doing and then comment it, even for yourself, just know what you did later if it's complex. So yeah, good question. Okay, so we'll go through that. Now we're going to do, I believe, data structures, like basic data structures. Yes, this is probably my favorite part of the session, data structures. So data structures, you might have heard this before. I know there's a lot of YouTube, what's it called, like YouTube ads that you see all the time. With data structures and like, do you want to learn data structure? I think AlgoExpert does that. Like, do you want to learn this or that? Data structure is one of those things where it could get really complex, but as far as basic data structures go, they're pretty simple. They're like, and there's just like things you have to know if you ever want to build something complete, I would say, because they're like, and they're not, some of these things we've actually been using before, like lists. Lists is a data structure. It's a way to like structure your data basically, right? So we're going to go through here and I'll show you some stuff. So here are different functions of a list. So before, like I said, yeah, the AlgoExpert one. Yeah, people are saying that's true. You see that all the time, right? Do you know how to reverse a binary tree? We'll do that. Let's make a list of names here. Like that. And then we'll do Alfredo, Tim. We'll do Jane here. She was in the chat, so we'll do that. Okay, we'll have that. And now this is a data structure. This is a simple data structure that just has a list, right? It's a way to structure your data. But these, like I said, remember before I said that there's a length function, right? You can use length, which is spelled like this, with names to go ahead and, thank you, man, appreciate it. I'm glad you guys are getting something out of it. So yeah, people are saying I'm explaining it well. Again, if you guys have any questions at all, just go ahead and tell me, because obviously I know this stuff, right? So I'm just kind of going through it based off what I think might be useful. But if something doesn't click with you, or if you need me to explain something to you in a different way because it's not making sense, just let me know and I got you. Okay, so we have that. So we have length, right? This is a way of function that for that, but there's a lot more functions. There's a function for appending. Now appending makes it so that you could append something to the list or add something to the list. So let's do this. Let's do names dot append like that, and then we'll append something else to it. Let's do Tom. So as you can see, Tom is not in this list, right? Tom is not in this list. It's Alfredo, Tim, and Jane. But what we're doing here is we're doing names that append Tom. So we're adding Tom at the end of this list. So append takes something and puts it at the end of the list. So we go ahead and print names. Let's do it before and after. Thinking of Python 2 there. Names, like that. And then over here we'll also do print. Like that. So what we'll do is we'll first see the names the way they are, and then we'll append Tom, and then we'll see names at the end of it. Yeah, So the links, all of the documentation that I'm using are in this document here, and I'll actually be sharing this in the Learning with Alfredo channel after I'm done with the session. So you have to go through here by yourself. So yeah, so we'll do that. Print names. So let's go ahead and run that real quick. Let me go ahead and full screen this here. Make this a little larger. Clear that. So we'll run it again. And as you can see, before, when we first ran it, we had names, right? And Alfredo, Tim, and Jane came up here. And then what we did is we appended Tom to it, and then we printed names again. And now names has Tom at the end of it. So that's what append does. It just adds an extra thing to the list. That, we'll keep going. We have insert. Insert is just a way of inserting things, and you could do that at a given position. So you could go ahead and insert an element at a position. So let's insert A at from 0 and insert the item X. So this is the index of where you want to insert something, and then what you want to insert. Remove, as it sounds, it removes something from the list, right? So you go ahead and use that where the value is equal to X. So again, this is really cool because the documentation is literally tell you exactly what everything does. So it's telling you that it removes something when the value equals to X. Let's just try that real quick, just for the sake of showing you how that works. Let's get rid of this and let's do remove. Actually, let me just leave that. Let's remove it first and then print the names out. Let's leave this convention. So the way you use this is you use the list.remove function. So list, our list is names, dot remove, like that, and then let's remove. Oh, I opened the interpreter by accident. Let's remove Tim from the list. Like that. Let's go ahead and run that. So you go. So as you can see, we have the original names here. We have Alfredo, Tim, Jane here, and then after that, we went ahead and we removed Tim. So now we have Alfredo and Jane. That's exactly what it does, right? It just removes things from the list. And there's so many more elements here. I'll leave these here for you guys to see, obviously, in the documentation. You go through this. If you ever want to do something, count returns the number of times X appears in the list. So you could do count Alfredo, and it'll give you 1 because it only appears once. If we had Alfredo twice, it will give you a value of 2 because Alfredo appears twice. Sort, it sorts things by different things. So if it's numbers, do you guys hear that music? Okay, cool. Nice, it's my neighbors. So good. Okay, so yeah, so we have that count. What was I saying? Oh yeah, sort sorts items by depending on what the actual element type is or item type is. So if we have a list of numbers, it'll sort them by numerically, right? So 0, 1, 2, 3, whatever the thing is. If it's strings, it'll do it alphabetically. So it'll make it so that Alfredo comes first, and then A, B, C, D, F, G, H, I, whatever comes next. Basically, it does it alphabetically. It does that, and there's also a reverse. So you can pass in the reverse item here, a parameter, and that makes it so that it's reversed. Simple enough. By the way, if you ever want to get into algorithms, it's kind of cool to kind of go through here and kind of just try to implement these yourself. So obviously these are already here because you could just use them, but you might be interested in looking up like what a bubble sort is, or some sort of other sort, a shell sort, which is more complicated. But you could do that and just kind of learn how these things are implemented. There's good ways of sorting things and there's bad ways of sorting things, but that I mean slower and faster. So you could sort things faster or slower, but get the same result at the end. So it's just, if you're into that algorithm stuff, you might want to look that up. Reverses the list. Copy returns a copy. This is a shallow copy. You don't have to know what this is, not for now anyways. It's just a copy of the list. Okay. An example. Here are examples, right? So we have Apple. It appears once, twice over here. It's kind of hard to see. Twice. So it gives you a value of 2. So this is just implementing the stuff we just talked about. You can go through that. List as stacks. We're not going to get into stacks or queues at all, but there's just ways of kind of thinking about how data is stored in different things. We'll skip that for now. List compressions are so cool. Like yesterday, I was talking to someone. They had a problem where they wanted to go ahead and like do something. They were getting the output for XRender. XRender is a program that's used to like on Linux to like mess with your monitors and like set different things. And they wanted to do that, and I gave them an answer with list compression because list compression makes things smaller. It's a lot more concise, but it's a little hard to wrap your head around. I don't know if I want to go into them. Let's go into, or like into one example just to kind of show you what list compressions are. So just kind of go through it. So websites for exercises I recommend. I don't know. I don't really use websites for exercises. I can't recommend anything. The question was, are there any websites for exercises that you would recommend? I hear LeetCode is good, but I can't say because I don't actually use it. Usually when I do my exercises, it's just based off the things I'm writing. I never said it, huh? At the very beginning, thank you for bringing that up because I forgot. I don't think I ever said it. The best way to learn a programming, by the way, is just to actually go ahead and actually make a program. So if you make a program, I think that's the best way to learn it. How to, like, the more in depth how to do something. But I know it's kind of unfair to say that, to say, and I know I'm going off tangent here, but just stick with me for a bit. I know it's kind of unfair to say that just make a program is the way to go learning, because if you're a complete beginner, you have absolutely no idea where to even start. So that's the point of this. But hopefully after this, after you get some of this stuff done, I would definitely recommend just going and thinking of a program with the stuff that we learned, and then just applying that. I think that might be a good exercise just in general. Sorry, I'm just reading here. Inside a list. Is it a list? Yeah. So Nazca asked a good question. So that's inside the Learn with Alfredo. If you're not following that, you can see that. So I will go over that in a bit. So this is part of data structures, and what we'll see is kind of once we actually start making the, if I understood that correctly, basically Nazca just wants to know if you want to get names by calling calling names into a function, how you would do that. And later on, I'm going to go into dictionaries. So in dictionaries, we'll talk about like how you would go about associating different types of data with different types of data. And it's actually part of our actual tutorial that we're going to do at the end, the program. So we'll go into that in a bit here. So yeah, list compressions is one of those things where you could really, you do a list like this and you could really make it a lot more concise. But I know that, like, even for me at the very beginning when I first saw list compressions, I was like, what is that? Like, it's kind of complex. But for X in range here, they're doing what we did before, right? We're going through X, we're going through a range of numbers here, and we're just using X. And then they're appending it to a list here, and they're doing it to the second power. So star is like to the second power. So X to the second power. That's what that is. And they're doing that. And here's a way of doing it without a loop like that. The way you read this is first you start with the loop portion. So for X in range of 10, you do that. For every single X in range of 10, you do this. You put it X to the second power, and then you put it into around lists, because the end result is a list. And this gives you a list that looks like this. And I know it's kind of confusing just to look at that, but that's a good example because it's kind of simple. But yeah, just know that. That's list compressions. I would definitely encourage you to go look at list compressions once you're done, or once you understand for loops like this. So if you understand this really well and you can do pretty much anything you want with it, go into list compressions because it's a cool way of looking at things. Okay. More list stuff. Nested list compressions. So let's talk about nested lists for a bit. So with lists, you could actually nest them together. So let's say we want a list. Let's just call it, let's just call it L for now, because I don't really have an example of when we would do this, or it's just numbers. It's just numbers like this. You would probably do this whenever you want to make like a tic-tac-toe game or something. I've seen people use lists inside lists. But basically, let's say we have numbers, right? We'll do 0, 1, 2, and then we'll separate that like that. Remember, when we have lists, we separate it with a comma like that. And then we'll do 3, 4, 5, and then we'll do it again. And then we'll do 6, 7, 8. Cool. So look at this. This is a list, right? We have a list outside, and then within that list, we have one list, we have two lists, and we have three lists. So we have a list within the list. Now, this is complicated maybe if you're just looking at it for the first time, but that's all it is. It's just a list. It's a way of doing lists inside lists, and you could do that with pretty much any object. You could do a list inside a list within another list. You can do as many times as you want. And then just to give you an example of how you would access that, let's do a print statement. Right? We know that we can use this, before we talked about it, to index items, right? We use the brackets to index items, and whatever number is inside that index is what we access. Now, again, remember that in programming in general, some languages don't do this, but for example, the first index is always index 0, and then it's 1, and then it's 2, right? We start with 0, not 1. So if, for example, we do number 0 like that, and go ahead and run that real quick. Numbers is not defined. I misspelled numbers again. Remember I did that last time as well. So just make sure that's fine. And it's good that we saw that, right? Because it told us it's not defined. So we know that we did something wrong there. We run that. And as you can see, we get 0, 1, 2. 0, 1, 2. Now it gives us a list. We're not getting an element back, but we're getting a list of items. Because at numbers, at index 0 of numbers, it's a list. It's an actual list item. It's not a number by itself. It's a list, right? Now, if we want to go ahead and, for example, access a number within this list, we first index the number. So we say, hey, we want to go ahead and access index 0 of this list here. And then let's say we want to access 0, we do 0 again. So that might be a little confusing to look at, but it's saying at index 0 of numbers, which is this one, access 0, which is this one, right? So we're doing that. So if we go do that, we should get the number 0 back, and we do. Number 0, right? And then we want to access, for example, this one, right? We start with 0 again. It still applies. So this is element 0, this is element 1, this is element 2. So we use that like that, and that should give us the value 2. There we go, and we get the value 2. So that's list within lists. Maybe a little complex to look at, but just keep in mind that lists start at 0, and then you could access every single item using that square brackets within the list. Yeah, I typed with an N. I did it earlier too. I misspelled something, and I was like, why isn't it working? So it's good to see things like that, because then you kind of get to see that why things are not working. You know, and I like that it came up, because then you get to see errors like this where you don't know what they might be if you're looking at it for the first time. But now you kind of associate, you know, oh, I've seen this before. This probably means that I mistyped something, or that I didn't define it anywhere. So it's good to know. So we'll do that. So can we somehow print a list without the brackets or commas? Yeah, we can definitely do that. Earlier we were talking about printing things within a loop. We could do that. There are some functions that I've seen before. I think prettyprint is one of them that does it. And there's probably some other ways of doing it as well. I don't remember. I think in the documentation I saw somewhere that there was a way of printing things without the commas and brackets. There's a function somewhere. I don't know what it was. But it does exist. I saw it in the documentation when I was doing it. But my go-to thing, if I didn't want to do it specifically like that, I would just do it within a loop or something. What's the longest way to print to console? What do you mean by that? So someone wants to know what the longest way to print to console is. Not sure what that means, but we're just going to let them answer that. We'll keep going here. So we did list, right? List within the list. Delete statement, like this is stuff that was before. We could use that to delete an index, just like we did with the remove statement. But instead of using the actual item or the name or the actual value of the item, we could just delete by index. So we could do delete 0, so that leaves the element at 0. So it deletes -1. So now we don't have -1 in the list anymore. So that's the way it goes. These are cool. Might be a little confusing right now, but these are ways of like printing a list from one place to another. So this is like saying print from 2 to 4. So as you can see, 2 I believe is exclusive in this case. So we go 0, 1, 2 right here. So we print from 3, from 1 all the way to the end of 4. 0, 1, 2, 3, 4, 0. I think it makes its own index. I don't really seen this too much. But within here, basically, you'll find the different things. I've used this every once in a while whenever I need to go and access specific items within the list. This is just an empty. You're not getting anything from here. But yeah, it's good to know this stuff, right? The use cases for it vary. It depends on where you're using. Oh, okay, so we probably won't go into that. But I think they want to know how to actually go ahead and print something, like what the print statement does. Keep in mind that Python, I believe, is open source. Like, yeah, it is open source. So if you really wanted to, and this is kind of off topic a bit, but if you wanted to, you could actually go to the documentation or to the Python GitHub page, wherever that is. It's in here somewhere. I don't know exactly. Probably won't spend too much looking for it, but it is open source from what I remember, wherever that is. And you can actually go ahead and find the code for it, and if you really want to see, you can see how all those functions are implemented, but beyond the scope of this, obviously. Yeah, someone said, sorry for making you stop. No problem, dude. Like, if you guys have any questions or anything at all, just go ahead and feel free to ask. So let's keep going here. Let's not get too off topic so we can finish this. Tuples and sequences. So tuples, is this a long section? I can't see the scroll bar. So we'll go through tuples real quick. So tuples are another data structure that you might use a lot. It's a lot like a list. So they look like this though. It's like with parentheses. That's what a tuple is. A tuple is a list like that. There are a few things, like you might wonder, like what's different between a tuple and a list, because they're pretty much the same thing, right? You do the same thing. You should use square brackets. Parentheses. If we go down here, I believe it does tell you the difference, but I think tuples are immutable. I do remember, yeah, right here. So tuples are immutable. So immutable means you can't make changes to it. So you can't, for example, for lists, remember we, actually, I don't think I'll show you that. So for a list, for example, if we do names, let's just do numbers. Like that, right? And then let's say, for example, we want to go ahead and access, change the number. Let's say we want to change 1 to 0. What we can do is we can do this. We can do numbers, add element 0 equals a different number. So we'll make that 0. So add element 0 equals 0. Keep in mind that this is not actually saving it anywhere. So I don't think this is actually making it, or it might make a difference. Let's see. Some data types you can't do this, but I think list is one of those exceptions. Let's go ahead and show that real quick. Yeah, so this one is. So check this out. So lists are mutable, right? Mutable meaning you could actually change the values within the list. You're allowed to do that. You can change the values. So in this case, we changed the index at 0 from 1. We set that to 0. So we set that at, it's like a variable name, right? So add index 0 equals 0. So we set that. So when we printed numbers, you can actually go ahead and see that now we have 0, 2, 4, 5, 2, 4, 3, 4, 5. So we have that. Whereas with, for example, for what we were talking about before, we had tuples. Tuples look like this. Tuples are not mutable. We can't do that. We can't, you can access it the same way like that. So if I do tuple numbers at 0 and we print numbers like that, so you can see we have an error, right? It says tuple object does not support item assignment. That's because it's not mutable, which means you can't change it. For a tuple, you can't change. So the reason I would see you using a tuple is in the case where you have a data, some sort of data you don't want to change. So to kind of protect it, I guess, to make sure it doesn't change, that's probably when I would use a tuple. But for the most part, list works unless you don't want data to change for any reason. So those are tuples. So Jane wants to know if I'll go over big O notation after data structures. Probably not, just because I feel like that's more something that you have to outside of the scope of this. Big O notation basically is just a way to kind of define how something runs. So it's like the runtime of something. So it kind of tells you like how the complexity, so how complex something is, and the big O notation just tells you how fast it runs or how slow it runs or how complex that calculation is. But we probably won't go into that too much here, or at all actually. So since these are basic data structures. So that, yeah, so lists are mutable and tuples are not mutable, so keep that in mind. Sets is one of those things where you use whenever you want to have something that never repeats. So let's do this. You can do this. A set is defined like this. Right? And let me just go ahead and print numbers here. Like that. Let me go ahead and print that. As you can see, we get a set back, right? Just like you would expect, like a list or a tuple or anything else, we get a list back. But you cannot have things that repeat it inside a set. So I believe if I add a 1 here at the end, and then print that, as you can see, we added a 1 after the 5, but it doesn't show you a 1 because a set cannot have repeating elements like that. So we go 1, 2, 3, 4, 5, and that 1 that's supposed to be there, it's not there. Sets can't repeat. So that's when you would use a set. Whenever you want a data, something that won't repeat. Keep in mind that for a set, the way you make an empty set. So for like a list, for example, you can make an empty list like this, like that. It's just an empty list with nothing in it. If we go ahead and run that, you see we have that. We have nothing in it. So a tuple is the same, kind of similar. A tuple has to be like that, but you have to go ahead and add a comma because a tuple expects more than one element. So you have to go ahead and do something like that. Just give me, or can I just, sorry, that's for one element. So a tuple is also like that as well, if I remember correctly. Like that, yeah. So a tuple gives you empty. But for a tuple, if you want one single element, you can't do that. That's invalid. You can't do that. You see that? It got rid of, it got rid of the thing by itself. So for a tuple, if you want to have a tuple of one element, you have to add a trailing comma like that. That tells you that's like that. So now you go ahead and print that. It gives you a tuple of one element. And then for a set, you would expect that, but you can't do that. If you do that, you'll actually see that you do get something here. But the reason behind that is because that's actually a dictionary. It's a different type of data structure. A set, you make an empty set like this. That's how you make an empty data set. So you see we have set. That's how you make an empty data set. You cannot use, and it even tells you here, you cannot use that. That's used for dictionaries. Oh, it's just right here. Creates an empty dictionary, like I said. So everything you want to know is in the documentation. So we'll keep going through that here. Dictionaries are awesome. Dictionaries kind of refers to that question that somebody was asking before, or if you want to go ahead and make references to different things, you use that using dictionaries. Let me go ahead and use dictionaries here. Before we get into dictionaries, let's take a break. I gotta go to the restroom real quick. So we'll do that. Maybe like a, I don't know. If you want to stick around, just go to the restroom, drink some water. I need some water because I've been talking this whole time. But we'll be right back. And then while you're waiting, you could probably just look through this real quick if you want to look at what a dictionary is before I get here. Maybe it might be kind of a good practice to kind of go through the thing yourself, kind of read some of this, and then see if you understand it once I get back and explain it. So we'll do that. Anyone have any questions so far? Make sure my stream hasn't crashed or anything. Make sure the recording's still going. That looks fine. And that looks fine over there. Okay. So we keep going here. Just tie my shoe real quick. Cool. So dictionaries are really useful. They're like super useful. I probably use dictionaries like everywhere where they can, just because they make things convenient. A dictionary is defined like this, like I said before. We'll call this dic, and then we'll do that. A dictionary is like that, and then what you can do is dictionaries have a key to value pairing. So let's say we have a key with the name Alfredo. Or let me show you this real quick. Instead of putting this out, let's just say like this. So we have a key, and then we have a value. This is how dictionary works. Notice that we have this here, it's a colon. The colon is what we use to separate a key from a value. So we're telling you that this key contains this value. So in a dictionary, if we go ahead and print like this, we can use dic, and then we can use this. This is, remember how we used that before to go ahead and capture elements in the list, right? We could use that to like put the index of an element and then get that index back, whatever the value is. We could do the same thing with dictionaries, but with dictionaries, we could actually use the value for it. So we could use key, and as you would expect, that goes into that dictionary, looks for where that key exists, and where that key is, it gives us the value for that key. So like that, and so you can see we have value now. It gives us that. Now we could have multiple keys element pairs here. So we could do key 2. Let's make that value 2, right? And then we could do like key 3. And same thing, right? We'll do that colon, and then we'll give it a value 3. There we go, like that. So we have that thing, pair like that. And then you could even, you might want to split this up differently. I am using something called Black. Black is a formatter for Python. So if at any point I press save and you see like things change, it's because Black is doing that. So that's where that's coming from. Cool. Yeah, so that's that. So what we'll do is we'll go ahead and do that. So like I said, we can do that. Now let's actually go ahead and print key 2 and key 3. All right, we'll go ahead and run that. You can see we have value 2, and value 3, like you would expect. It gets that value and it does it. Now, the reason this is kind of cool is because, like lists, you could actually go ahead and nest dictionaries. So you could actually go ahead and have a dictionary within a dictionary. And you're probably thinking, why would you want to do that? Well, let's say we do something like this. Let's say we have people, right, like that. And then we have a value of Alfredo as a key. And then we make a value now, sorry, a key. So we have a key, and then we make a value here. We make a value of a dictionary. So now anything inside this will be here. So we'll do something like age, right? Notice how I am using strings. I'm using strings to define this stuff, right? Because that's how you do it. You can actually use, well, use strings to do that. You could actually use numbers, whatever you want. But this is the string because it makes sense for me to have people with their names. So that's the way I'm structuring this. And I guess this kind of comes back to like what I said before, like thinking like a programmer. You want to go ahead and kind of keep things in mind, like how you want to structure things. In this case, I'm structuring by names. So we have an age, and we have an age of 23, like that. And then inside here, we'll use a comma, and it's going to be pretty crazy, right? Where's a comma, and then we'll add another name here. We'll do another thing. We'll do height. Notice that I am capitalizing these letters, so if I want to use them again, I want to go ahead and make sure that when I use the key, I do it with the capital A and capital H. And now that I think about it, I don't like it too much, so I'm gonna just go ahead with lowercase. It just makes more sense. And then we'll do a string this time, right? So instead of an H, we'll use an integer. We'll actually use a string of 1 foot again, because that's how tall I am. Okay, we'll do that, and we'll save that. So as you can see, now we have a key, right? What's that? Anyways, we have a key with all this information inside of it, right? Now let's go ahead and access that information. So if I'm gonna go ahead and access people, people, that, and I want to access the Alfredo key, and I want the age of Alfredo, I'll do this. Just like we did, right? Whenever we had a nested list, we got the index of the first list, and then from that index, we got the element of that list. So that's what we're doing. Same thing, but now we're using keys to access those values. That should be fine. We'll run that. And as you can see, we got 23, right? Because Alfredo is 23. So we did that. And now if we want to get height, we'll do the same thing. Bam, like that. We'll go ahead and run that. And we get 1 foot. We get back. So we can do that. And we can do that for multiple people. Like we don't just have to have one of them here, right? We could do a comma here. And then go ahead and add another person here. Let's go ahead and do that just a little bit. We go ahead and add another person here. Tim. And then for the sake of typing, I'm just copy this here. Like that. Save that. And then the black went ahead and formatted fine. We'll say he's 13 years old and he's 10 feet. I got super tall for 13 years old. So we have that, right? So now we're going to go ahead and access Tim. And then his height. We'll do that. And key error Tim. Where did I go wrong here? Oh, I see. Add an extra space. You see right here? Added an extra space with Tim. So these are string literals, meaning you have to, if you're going to go ahead and access the key, you have to access it the way it is. So for this example, Tim has an extra space here, the way I accessed it. So it's like, what are you talking about? There's no key named Tim, even though I thought, okay, Tim is there, but Tim doesn't have a space. So let's get rid of that space, like that, right? And this is interesting to see because like I got this error and I wasn't expecting it. And you kind of think, it's like my thought process. I'm talking out loud so you can see my thought process. So like, oh, why isn't it working? Look around my code. Oh, Tim has a space. That's not supposed to be there. And if you look at the key error, it specifically has a space behind it too, as you can see that right there. So that tells me, oh, hey, that's not the way it's supposed to be. So we'll go ahead and run it again. So as you can see, we get some feedback, right? Because we got Tim and height. So that's the way you access dictionaries. Dictionaries, again, are super useful and they're used so much. Like in Django, they're used for like how you access the database, things like that. In different libraries, they're super useful. Like as far as data structures goes, there's the things I use the most. I use lists and I use dictionaries. Those are the ones I use very often because they're so useful. Let me just catch up here, make sure I'm not missing anything. Cool. Cool, guys. I know this is getting long, but we're almost there. So we have dictionaries, looping techniques. Okay, let's just go over dictionaries for looping. Let me see what else there is here. We'll just skip reverse. Reverse, again, is just a way to reverse the list, right? And you can always click on these and find more information about what these functions are actually doing. More conditions. Yeah, this is just using OR. OR is one of those things you can use to, remember earlier we talked about Boolean values. We did like true equals some conditional statement, like number, like 2 equals 2, right? We use some conditional. You can nest these things together and you can say, I want true to equal true. I'm gonna use parentheses to make it a little more clear. 2 to equal true, and then OR 3 to equal 3. So if one of these evaluates to true, then the value will be true. That's what OR does. I want this to be true, or I want this to be true. If you wanted both of them to evaluate to true, you use AND. So I want AND to be true, I want 2 to be true, and I want this to be true. If, for example, 3 does not equal 1, then this is false because not both of them are true. That's just the way you use AND or OR statements. So that's just a thing to think about. Let me just go through here real quick. Okay, yeah, we're pretty much it. Let me just go ahead and talk to you about looping techniques for dictionaries real quick. So like we saw before, for dictionaries, we were able to access a dictionary within the loop, right? If we went like for name inside names, and then inside the loop we could print names. We could print all the names over and over. We could do something similar with dictionaries, but dictionaries, we have a key to value pair, right? We have a key and we have a value. So we need a way to access both of those. We can't just say, by the way, if you try to access a dictionary like a loop, and I'll show you that real quick, it'll just give you the key back. So if we do for dic, this D in dic, like that, and then we'll just print D. If you try to do the same thing here to loop through a dictionary like that, and print that, you get the keys back, right? But you might actually want the values for it. So the way you do that is you use a function called items. So it's part of the dictionary. So you use the items like that. Items. If I can spell like that. Items. And what this does is it's something that people refer to like a list decompression, or in Java it has a different name, or JavaScript. But basically what it does is that it makes it so that it gives you a tuple. It gives you a tuple. Remember, tuples are like parentheses like this, and they have a value in it. It gives you a tuple of 2 values. The first value being a key, and the other value being a pair. So that's how you use that. So if we go with that thing here, we could do print D0, and then a comma here. Remember, I'm just accessing the values, right? Remember, a D is a tuple. which this is giving us tuples. So we have tuples, and then you can access a tuple like you do a list. This is the first index, which is the key, and the second index, which is the actual value. So if we run that, you see we get this. We get key, value, key, value, key, value, right? We get it like that. You would expect it. A way of doing this that might be a little more concrete is that instead of using D, you can name these something like key, and then like this, key and value, like that. To not confuse you, let me show you what I'm doing. So basically, like I said, an items, dict items gives you back an item, right? A tuple of both a value and a key. So, or a key and a value. So that's like doing this. So if I have a tuple like that, and that's like a key, right? A key and a value like that. Now, what we can do with these is we can actually go ahead and unpack these values. It's called value unpacking. You unpack it by setting it equal to two things. So instead of one, because we have two things, we have a key and we have value. So I can do this, key, value, like that. And what's happening here is I'm getting the value key and I'm getting value. So I'm getting key as a key and value as a value respectively. So that's what I'm getting here, like that. So that's the same that's happening here. I'm going for D and items, give me the key and value. As you can see, we have some error here, and that's because we no longer have a D. That doesn't exist. So what we'll do here is we'll do key, value. Just like that. And now we have key and value. And as you would expect, if we run that, it gives us a key and value pair, like that, right? And then I could even show you something here. If the key was, I don't know, some name, and then let's just do some value, right? And if I print this out, you'll see that it works the same way. Keep in mind again that, like we said before, somebody asked a question, this key and value is not the same thing as this key and value. Within this loop, the scope is different. So this key and value only applies to here. These are different. Even though they have the same names, they're different. So as you can see, we have name, some value. That was the key in for that. And then we have key value for all the other ones. So that's how that works. So can we do, so somebody asked a cool question. I think the answer for that is yes, you can. So someone's saying, can you do X comma Y for some list as well? And I do believe if you only have, I'm like 100% positive, 99.9% positive that you can. So we'll do that real quick for you. Let me just go ahead and get rid of these print statements by commenting them out. And if you know, like we talked about before, if I comment this out, this won't work, right? Because we have an indentation like before, and this is going to tell us, hey, you started something here, you're indenting something, but there's nothing there. So we're going to pass it for now. Keep in mind that it makes a lot more sense just to comment this whole thing out, because then you're just kind of looping through for no reason. But yeah, so we'll do that here. And then let's say we have a list, right? Some list. Notice that I used an underscore because remember we talked about Python conventions before. We use underscores to denote spaces. That's just a convention for it. So we'll do that. Some list, we'll do 0 and 1. And then we'll do xy equals some list, like that. And that should give us the value xy in there. So let's just prove that by printing xy. And then go ahead and run that. And yep, we get it 0, 1. So we can do that too. So that's the question to that. The answer to that is yeah, we can do that. And obviously you can do that as many times as you want. So you could do like 2, like that. Keep in mind, check this out. I want to point something out real quick now that I did this. So I'm glad you brought that up because now I can see things. So check this out. Now, if we do this and we do this, we're going to get an error. It's even underlining it. It's telling us here. The reason behind this is because, again, actually this is called value unpacking, right? We're unpacking values. In this case, we're giving 2 values. We're giving x, y. We're trying to unpack the list. But we have 3 values. So if we do that, we should get an error at runtime. As you can see here, too many values to unpack, expected 2. So we're expecting to unpack 2 values because we're giving 2 variables here, but we have 3 of them. So we want to do that. We want to do something like z, right? And then that. And we won't print it out because I didn't put it here. But if I do that, just to print it so we can see it, we get 0, 1, 2. So unpacking. So yeah, in order to unpack something, you have to have the same number of value, the same number of things you're unpacking to your variable assignment. So Good thing. I didn't think about that. Yeah. Yeah, you could use anything. If you're talking about data types, you can use any kind of data types for them. They'll still work. So yeah, Python does not use camel case. Yeah. Oh, they were replying to somebody else. Cool. You guys are helping each other out. Nice. Yeah, so like I said before, Python does not use camel case. So before I talked about like how spaces, right? And spaces, we would do something like this, like sum list, right? Python, that's fine. You could use that if you want, but that's not the convention. So like I was talking about before, I don't know if you were here before, but like I was talking about before, it's always good to use a convention, because if you're working on this with somebody else and they're using convention and they don't see that you're using camel casing instead, they'll come in here and your code is just going to look messy. It's going to look like, obviously 2 people worked on it, but it's going to look like, it's just not pleasant. I don't know how to explain it, but once you start looking at really long code, it's just not pleasant to like have to like think about different things. So I always like keeping convention. So we have that. Okay, moving on. And yeah, that's it. So that's it for that. And there is one more part about modules. Modules is going to be super quick. I'm just going to talk about modules. I wouldn't even open up the documentation, because the documentation goes into a lot more detail. But let's say, for example, you write a program, right? Maybe I will actually do it. I wasn't thinking of doing it, but maybe we will. Okay, let's do this. So let's, this program, like we said before, we have a file called tutorial.py, right? So let's go ahead and make a function like before, simple function. Let's call it dev print name. We're going to print a name. We're not going to pass a parameter at all. We're just going to print something for the sake of simplicity, and we'll print Alfredo, right? We have that file. Now let's say we want to make a new file, right? I'm going to go over here. I'm going to go ahead and add a new file. This is a new file button. I'm going to call it new file.py. Okay, so we have this. We have tutorial.py, right? This is, and we want to use this. Let's say we want to use this function. This is good to like keep your things compartmentalized. So to kind of go ahead and split things up, so you don't have to go ahead and keep writing the same code over and over. So what you want to do, by the way, that's a good point. If you're ever writing code, and like a beginner, if you're ever writing code, and you find yourself repeating yourself, that's a really, really good indication that you're doing things wrong. But that I mean that you could be, if you're repeating yourself, like you're repeating code, like if I want to print, like we talked about loops before, but if I want to go ahead and print Alfredo, right? And I do this like that, where I do it over and over and over again, that's a good indication that you could be doing things, maybe wrong is the wrong thing to say, but that's a really good indication that you could be doing things better. So if you ever find yourself repeating your code, like pasting stuff, make a function like this, and let's just call that function instead of repeating yourself over and over, because it's messy and it makes your code longer than it should be, and it's just like you're just repeating yourself for no reason. So just make a function. Okay, so we have that. We'll leave that the way it is. Just don't do this, because this is not good practice. Actually, I'm erasing it just because I don't want you to do that. So we have that. We have new file.py. So let's say I want to go ahead and use that. What I'll do here is I'll import the file. So you use that using import statements. So something like the import. I'm not sure if, what was it? Tutorial. Let's see. And then once we import something, I'm pretty sure that's the way you would do that. But I don't know if we need to go ahead and give it a path, because I don't know how VS Studio or VS Code is doing stuff. But if not, I'll show you in a bit anyways. So we'll do that. And then we'll have tutorial. And then let's say we want to go ahead and use this function print name, right? So we'll use this function in here. So the way we do that is we'll do a tutorial. That's where it's coming from. And as you can see, it even did it for me. It says print name, right? That's the function that's coming from the other file, because we're importing tutorial. That's this file. We're importing tutorial, and we're using print.name. And now we're calling that function, right? So if we do that, and then just go ahead and run that real quick. We're running, in this case, we're going to run new file, right? Because we want to run this function, not this one. We're running this one. We're calling it. We hit enter on that. And as you can see, it printed Alfredo, right? So what happened here is that we imported tutorial, meaning we imported this file here, and then, or this module, they're called modules in Python. We imported this module here, and then tutorial, we call it tutorial from tutorial, call this. We use that with a dot. So, oops. We use that with a dot. So it's dot and then the function name. So anything that we use tutorial dot something belongs to tutorial. It's in that tutorial file. Now, if for whatever reason this is not going to work for you, it's because you probably didn't use the proper path. and depending on how you have your environment set up, it might be different. But something else you could do is do this from dot import tutorial. All this is saying dot is a current directory. Did I misspell something? Oh, okay. Yeah, so this is because I'm in the top level here, so it's probably not even necessary. But if, for example, let's say we had a folder, right? We had a folder, let's say it's solutions. I have something in solutions. So there's a folder solutions. We could do from solutions, import that. So let's say I had solutions in there. That means that from solutions, import tutorial. So like, let's say tutorial wasn't here. Sure, move it. Like that, and now it goes away because solutions is in here. It's inside tutorials. So that's the path that we're giving from solutions. Solutions is the folder, import tutorial, and then we run that, we should be good. Yep, it ran fine. You see that? Because we went ahead and it from here. So keep that in mind. If something's not working right and you're using it with here, keep in mind the path. Your path might be wrong if it's not working properly. So we're doing from solutions, import tutorial. So that's that. Cool, guys. And I think that's as far as we can go with modules, just because anything else is pretty complex. But I just wanted to know that you could go ahead and import modules, and Python does have modules that it comes with. So these are files, right? These are pre-built files that we have, but you can always import more of them. A popular one that I probably use often is time. So we could do import time. So time is just another file somewhere else in the Python standard library, like it comes with it, and then you can use time to do something. So let's just do time. Has different functions. They have a sleep function, and then time.sleep just stops the program for a certain amount of time. So that's 10 milliseconds. So it stops it from 10 milliseconds, and I can prove that to you if I go print. Or it's a seconds. I think it might be seconds. I don't remember if it's milliseconds or seconds. I think it's seconds. It's not telling you right now, but I almost think it's seconds. And again, if you don't know this, you could always look at the documentation, right? Yeah, so no one said it's seconds. So it does say the default thing is seconds. But if you don't know this, you could always go to the documentation and see exactly what it's saying. So keep that in mind, documentation. It's really useful. So we have that, right? We'll do time.sleep 10, and then we'll do a print statement here, and we'll do done. You'll notice that if I run this right now, what's going to happen is that because we imported time, and time.sleep has a function to stall the program for a given amount of seconds, we're going to go ahead and it's not going to print right away. We have to wait 10 seconds, and then it's going to print done. So we go ahead and hit that. You see nothing's happening, and after the 10 seconds are done, we should print done. I should probably make it shorter, huh? But we shall see. Just keep it going. This is helpful. There you go. It says done. This is helpful if you ever want to stop your program to do something. In my program that I showed you on my channel, my YouTube channel that I showed you guys earlier, go over here. This file here, the uploading a video and new video every single time someone subscribes, that's on the time. That's using sleep to sleep for I think 5 minutes or 10 minutes. It sleeps for 10 minutes before it checks again because I don't want to be spamming the YouTube API. So that's an example use case you might want to use that for. Okay, so we have that, and now let's get into actually making a program. I know this is taking a long time. We started at 10, it's now about to be 1. So if you're still here, I appreciate it. It's awesome that you guys are still here. Any questions at this time before we actually start making something? Go ahead and feel free to ask. Just say it out loud or put it in the Learn with Alfredo channel. I'm going to take a water break, but just talk to me if you need to. Ooh, good question. So, no one asked something. And then, so this is in the documentation. I chose not to go over it because of time. It's just going to show you what we're going to be doing. But, again, I told you that Python comes with pre-installed or different modules, right? The convention the Python uses is that, for example, let's say you want to go ahead and import this package called math, right? And this lets you do math operations. There's different operations you can do with it. Like powers. I think power is one of them. I don't know what you would use this for powers, but let's do print. 2, I think it's pow. Yeah. 2, let's do to the second power. I think that's how I use that. Yep, so it gives you 4. So that's from the math, right? Library. But I didn't even use that. I don't think math is part of the math library. Some other things are.
I haven't used the math module so much, but if you really want to, you could go ahead and go through it because I didn't even use math here, but you could go through that. So that's not one of them, but there's different functions of them. But basically, the way Python uses these import statements is that by convention, the very first thing it looks for is in its own package resource, or the packages you have installed as well. So for example, if I make a thing here, right? Right now we imported time. So if I make time.py, right? And I'm not even gonna, I don't know if I have to do anything with it, but if I make time.py and I go back here and I import time like this, what's going to happen is that this file will not be imported. It's not this one. What's going to be imported instead, to begin with, it's the actual time module that Python comes with. That's how it looks like. Yeah, so that's what it looks like, right? So you have that, and I believe that works. So if I do like time.sleep. If you ever see me like be quiet, it's just because I'm kind of reading over there. So if we do that, right, you see it's not doing anything. It's sleeping for 3 seconds, and it's done sleeping. So it did that, but this was never called. So like nothing here is obviously empty, but it doesn't matter because it never gets called by beginning. So if you ever have a thing like this where you have it, then I believe that's when you actually have to use the path. So and it might be just because I don't know if it's different, but I know I've done it before like this. It might just be one of those cases where if anyone knows why this is happening, why I can't import it from the relative path, just let me know. But what I would do, honestly, even like that, I think that's with every module. Even like that, what I would do is there's a structure. So that if you go back to that PEP 8 thing, there's a structure to how you actually go ahead and want to structure your program to like make things so that it's structured in such a way. And usually you would have things inside a folder anyways. And I would not, I don't know why I would do this, but I wouldn't name something the same name that is a Python, it's a module that's already inserted. I wouldn't do that. I just wouldn't do that just because, again, you want to keep your things separate. So I would call it something else. And that would be specific. So the more specific you can do that, you can be with your namings, the better. So, you know, like if this is time for something else, I'll name it time underscore something to make it specific. But yeah, just know that by default, the file, whenever you import a package, is always from the things you've installed or the Python standard library first. That's the thing it looks at first. Okay, so we have that. And then let's actually start making the program now. So I'm glad there's people still here. Is this recording still going? Yep, we're still going. We're 3 hours into the recording. Wow, okay. So we're 3 hours into the recording. Well, what we're going to be making is, let's just going to go through this. We'll be making a program to store contacts. So nothing super complex, right? But let me show you it. So I'm going to go ahead and clear this. I'm going to go ahead and open Python, the program. It's inside my solutions folder, and I called it contacts. So this is the program we're going to be making. So not super like think of it like a phone contact, you know. Whenever you go on your phones, you have contacts. You could add contacts, you could search for contacts, you could print your contacts, like show, you know, scroll through your contacts, delete contacts, or just quit, right? That's all it is. First thing I want to show you is that this program does have options. So you enter a number for an option. If I enter anything else that's not that, it tells me it's invalid, right? And then it says press any enter to return to the main menu. So you press enter. That's just say press enter, not any enter. I think originally I had it to press any key, so then I changed it to press enter. But anyways, you press enter on that, and it goes back to the main menu. And then I press like some letters. That doesn't work. It's not a valid option, right? Or now, if I go ahead and print out contacts, it does this, and it shows me that the contacts right, and there's nothing underneath it. So the way I'm printing contacts right now is that underneath this here, you'll see contacts come up. So you'll see different names for contacts, right? We'll press enter on that. Let's add a contact. So it asks you for a name, so we'll do Alfredo, and then it asks you for a phone number. There you go. That's my phone number. Feel free to call me. Yeah, so we have that, and then press enter to go to the main menu. We'll go ahead and press 3 to print contacts, and as you can see now we have a contact, right? And then we could add another contact like that, and we print out contacts, and then we have another contact, right? We can keep adding contacts all we want. So that's how we have that right now. Now we have other functions, right? Like print out contacts, delete contacts, other contacts, search for a contact. So for search for a contact, and we press 3. Oh, that's the wrong one. Search is 2. So we press 2. Now it gives you the option to either choose a contact or look for a contact using a name or using the phone number. So if I use phone numbers, you'll see, if you notice, that I use the same number for both Alfredo and Tim. So when I do that, I get both contacts out. It gives me both Alfredo and Tim as a contact, right? We'll go back to the main menu. Now we'll go ahead and add a search a contact by name. So we can do that as well. And it just gives me Alfredo, right? Now, same thing applies with the delete function. I specifically added a duplicate contact because of this. So if I press 4, right, and enter a name and phone number, if I do a name, it'll ask me to delete it. And if I use a number like this, it tells me, hey, there's 2 contacts with that name. Which one do you want to delete? So then we go ahead and choose a number 0 or 1. Let's go ahead and use Tim. Let's get rid of the Tim. We do that. And then it tells you, are you sure you want to delete? I figured we might as well put this because you might press something and you're like, oh, what did I do? You know, like any proper application has that, where you want to go ahead and confirm your choices. So we have that. And this, you could input it like this. Yes. You could do this. Yes. Or you could do this. Yes. And they'll all work. So we'll go ahead and do that. We'll do Y. And contact was deleted with that. And now we go ahead and print out contacts. We see that Tim is no longer there. So that's what we're going to be making in a nutshell. Not super complex. And of course, 5 just quits, stops the program. Yeah, if you guys have any questions, go ahead and type. I see some people typing, so that's cool. Ask any questions you want. So yeah, that's what we're going to be building. And it should not take too long. Time again. Okay, well, we should be good. I mean, I'll just go with it anyways. I mean, I specifically clear my schedule up for this reason, so you guys could actually go ahead and, like, you know, ask any questions you want. And I'm free pretty much all day today, so we'll keep going. So yeah, again, thank you guys for sticking around. If you're still here, appreciate that. Hopefully, you guys are getting a lot of learning a lot out of the session. So that's what I hope. We'll go ahead and just go ahead and make this smaller here for a bit, and then we'll go ahead and make this smaller. I'm gonna get rid of this file now. No, I'll just leave it. Why not? Yeah, awesome. This is amazing. I'm so glad you guys are enjoying it. So we'll do that. We'll go ahead and add a new file here. We'll call this contacts.py. Contacts.py. That. And we'll go ahead and start making the program. I'm actually go ahead and open the program up on my over here, just in case I need to look at it again. I did pre-make it before. That way I have something to refer to, you know. The reason I made it before is because I made this program specifically to go over the stuff we've been looking at right now. Like the stuff we've been looking at, the lists, the dictionaries, the functions, the loops, all that stuff that we've been going through, those basic stuff, we're going to use them in the program. So that's why I made it like that, because so that I can kind of go ahead and systematically pick out the things I want to make it and how I want to go ahead and make these functions. So the very first thing is first, right? At the very beginning of the lesson, we talked about how thinking like a programmer. So if you weren't here yet, or if you weren't here at that time, we were talking about how whenever you're programming something, you have to kind of think like a programmer. And that means that you have to think of like very basic levels. So you got to think of like, okay, what do I need to make this happen? The example was like finding me in a class of 500 people. To find me in a class of 500 people, you would probably start looking at the first seat and then to the next one and so on until you found me sitting down in my seat. Somebody says just scream out Alfredo, you know, and you know, if I respond, you'll find me. If I don't, you won't find me. But you know, I'll respond. I'm not mean. I'll respond. But yeah, we have that. So we're gonna think of like how we want to structure this program. Now, I did kind of walk you through what the program does, right? Like different functions that the program was doing. So all we have to do really is kind of think about how we want to do it now, right? This is and this is what you're doing with programming, like, or software engineering. A lot of times you have a concept in mind, or you're giving a problem, and you have to figure out how to make that problem into smaller sections so that you go ahead and implement those sections, implement the small section. And then once you have that section, implement the next section, right? And if at any point you don't know what you're doing, you're kind of lost, or like, how do I do this? You look up the documentation. You go online and you look up documentation and you see, okay, how do I do this? Because I don't remember. Or you Google it, right? There's a lot of answers on Google that you can find. And like learn how to find specific portions, like very small portions to implement your program. And yeah, I mean, you just look it up, you know. Like I think I mentioned at the beginning, sometimes your answer won't be on Google, so that's why it's important to know documentation. But yeah, we'll just start off with the basic stuff. So very first thing, we wanna the way thought process. So I'm gonna speak out loud with my thought process, so you can actually think about how I'm gonna go ahead and make this program, right? So the very first thing, we need a way. Yeah, so Theo asked if the program will store the contacts if I quit. So as of now, the program does not store contacts if you quit. Everything is stored in memory. You'll see that in my agenda here at the very end. We'll come back to this at the end. But at the very end, I added some things that you could do to make the program better. And the reason I did this is because this way you could go ahead and kind of learn. Like see the process, right? And then kind of think about, okay, well, now that I build this, I have more things that I could do. For example, I could go ahead and say this. I put that in here, store contacts in a file so that you won't lose them when you quit, when you restart the program. And I put JSON here would be a good example of way of doing this. And I give you a link to the documentation here, so you can look at that if you want to do it that way. So yeah, the reason I did that, and I specifically didn't go through every single little detail, I did that, yeah, like I say you can store it in a JSON file. So I did that specifically because I want you guys to obviously follow up with it. So once you learn the program and you kind of think about like how to build the program going along, you could actually come back in here and say, oh, what is this program missing? So I went through here and I just added some more things that you could do to make the program better. And then you can just go ahead and kind of do that yourself, you know? So yeah, that's one of the things. But for now, the contacts are just stored in memory, meaning when you quit, the contacts are no longer there. Yeah, someone mentioned SQLite 3. Database, yep, yeah. So there's so many ways you could go ahead and store this information. Even if you wanted to, you could even store it in a text file. It's not the prettiest thing, but you could do that if you wanted to. There's so many ways you could think about doing things right. You could get as complex as you want with it. So we'll continue here. So we have contacts, right? So the very first thing, like I said, is my thought process is, okay, I'm going to be storing contacts. So I need a way to store the contacts. Like, how do you store them, right? Based on what I showed you, I only need a way to store a name and the phone number. That's all I need of my implementation, right? So later on, if you want, that's actually in the file, you could actually add more things. You could add addresses, you could add pictures, you could add emails, right? You could do so many more things. So you can do that stuff. But for now, I want to go ahead and store my contacts in a way where I have a name and I have a phone number. So for that, I want to use the dictionary because it's what we thought, right? We have a key. The key is our name and the phone number is our value. It's the thing that comes to mind. So let me just see here. I'll make sure that I have all the variables names the same in case I do share this function as well. So we'll start with that. So first thing, I'm gonna go ahead and do contacts like that. Now, something I want to point out to you is this is also convention. You haven't seen me use this before, but contacts is capitalized. And the reason that it's capitalized is because, let's take notes of comments, right? It's capital, and you excuse me if I do misspell anything. Capitalized because, or I'm explaining it. So we'll do this. Show you this. So global variables in Python, meaning variables are going to be using over and over again throughout your whole program. Like you could access them anywhere. It's at the very top, at the beginning of your program. The convention of this is that they're capitalized. That's just the convention. If I wanted to, I could not capitalize it. I could just do lowercase contacts, and it'll work just fine. But again, convention is important because if somebody else looks at your code, it's good to have a convention. And because it's capitalized, they immediately know, oh, it's capitalized. It's a global variable. It's used somewhere else in the program. So that's why we do that, right? So we do that, and then we're going to store that. Now, what I want to start with, let me show you how we're going to be storing it, right? Because I explained it to you, but let me show you. So again, we have a dictionary, right? And the dictionary, like we said before, has a key value pair. So if I'm going to go ahead and do this, we'll do Alfredo, right? I'll look at this. We'll have the key, that's a key, and then we'll have a value. In this case, I'm storing the value as a string, right? That's how we do phone numbers in the United States, by the way. So if you're not from the US and that looks weird to you, that's just the way we do phone numbers here. Sometimes people do this. Right? Same thing. Like that. That's the area code and this is the actual phone number. So that's how we do that. That's how we're going to look like. And then obviously we're going to have more items. We're going to have more people in here and more things. So that's why we're using that. So that's how I'm storing it. So I'm keeping that in mind. I'm storing my elements in a dictionary because I want to be able to access them like that. So that's why I make that decision, right? And again, I'm showing you this because not only do I want to show you my thought process, But more specifically, I want to show you why I do things, not just I'm doing this because that's that, but why I do it. That's important as to why. So we do that. And then now that I have that, I'm actually go ahead and skip ahead here a little bit, and I'm gonna start with the menu, because the menu is kind of like the most basic thing. And from the menu, we could go ahead and structure a program. So once I have my menu, I know that, like I showed you before, right? So like I showed you before, we have our menu. Once I have my menu, I know I want to go ahead and add a contact. I want to search for a contact. I want to do this. So once we have this, like the basic explanation of what the basic outline of what we're doing, we could go ahead and start adding stuff. So we're going to do that. So for that, let's define a function called def menu, like that. And it doesn't take any parameters. It's just a function by itself. And then let's go ahead and I haven't shown you how to take input yet. So this is a good way of doing it. So what we'll do is to take input in Python, we'll use the input. It's pretty simple. You use the input thing. The input, I shouldn't say thing, the input function. So we'll call this option. And again, before I just start doing my own thing, let me make sure I stick to my original plan. That way we stick to their stuff. Cool. Cool. Yeah, so we'll do option. A variable name again. This is just a variable name. And what we'll do is we'll ask the user to enter an option, right? So the way we'll do that is we'll go ahead and use the input function, like I said before. Input. And then excuse my shitty typing. I'm getting used to this keyboard still. And then we'll do like that. We'll do enter option. So this is what you see down here. This is why you may add a space in that. This is what you see down here, right? The enter option that we have from the original program, like that. So that's going to enter the option. But before that, what we want to do is we want to go ahead and get this stuff here. We want to go ahead and make it so that we have a list of stuff that the user could list to use. The easiest way to do that is just to go ahead and do print statements, right? So we'll do print, like that. And then we'll do the first option. I'm going to just copy and paste it from here, because why not? We'll do add a contact. The second one's going to be that. Make sure I remember these are strings, right? So if we do this without the strings, that's bad, because the Python's gonna be like, what is this? What is search? What is for? Well, it knows for is a thing, but it's not in the right syntax. It doesn't know what A is, it doesn't know what contact is, it doesn't know what any of this. So we want to make sure we enclose that in string literals. That way we tell Python, hey, this is a string. That's what it is. So don't freak out on us, you know? Do the same thing here, S3. We'll delete contacts, that's 4. And then we'll allow option to quit at the end. All right, so when we execute this program, I'm just going to copy this. When we execute this program, right, what's going to happen is that we're going to go ahead and do nothing right now. Nothing's going to happen because we haven't called anything. We haven't called menu, right? So menu is a function right now. But if we go ahead and quit this here, clear the screen, if we go ahead and just call contacts.py, right? Py contacts.py, nothing happens because we haven't done anything with it. We just have that. You'll notice that this is underlined, by the way. This is just because this is no quick fixes for the thing. It's just maybe you have some different kind of naming convention. So just don't worry about that right now. But yeah, anyways, we'll do that. And then we have contacts, nothing happens because we define stuff, but we never actually used any of it. So what we want to do is at the end, we're going to have to go ahead and run this. And we do that by just calling the function, right? This is the menu function. So the menu function, it's going to be like our main function. That's usually the way things are defined. We're not going to main functions right now because I think they're like out of the scope, because you might kind of think about like classes and stuff. But just think about that's like where our program starts. Our program's starting in a menu. So that's what we're calling menu here at the end. And after all this happens, we're executing menu, right? So we'll do that. And as you can see now, we have this, right? We have this. We go ahead and enter options. But as you know, like nothing's happening, it's just quitting, because after we get the option, it's just nothing else happens, it just stops. So we have that though, but we have an option menu now, right? Now, we don't want this to happen. I don't want it so that, again, thought process, right? I don't want it so that it quits after I'm done. I want it so that it keeps asking me different things that I want to do. So what we could do that, if you remember earlier, we talked about under loop controls, when we're talking about loop controls, flow control, sorry. We're talking about flow controls. We can use a while loop, because a while loop makes it so that we can loop something however long we want, right? We don't have to know the length of it or anything. We just got to know we just got to loop, because if we loop, we'll do this, we'll come here, we'll print this out, we'll enter an option, and after we're done, we'll go back to the beginning and we'll do it again, all over again. We keep asking the user what things they want to do, right? So what I want to do here is I want to implement a while loop. So we do that using while, the while statement, and then I'm doing true. Remember that true, it's a Boolean value, right? Like we said before. And this means that the value will be looping forever. It'll keep looping until it's no longer true. But because we're setting it true, it's always true. So it's always in the loop. Well, we'll go ahead and use that. And remember, anything that we have inside when we use our, what do they call it? The colons. Whenever you use colons like that, you have to make sure you indent it. If you don't indent it properly, that means that this is not part of the while loop. But we want this to be part of the while loop. So we're inside the while loop. So while true, do this. Run the menu, right? That's what we're doing. So if we do that now, well, like that, you can see we can enter something, and it comes back. We enter the option, and then print it again, and ask for an option again. 2, that works, and then asking for another option. So that's what that's doing. But obviously, right now the options don't do anything, right? Because we haven't made them do anything. It's just like that. So quit that with Control-C. That's how you quit an infinite loop. And then what we'll do now is let's start implementing these functions, because we want to go ahead and do stuff. So what should we do first? Let's do the easiest one. Let's do quit, right? So to quit, after we have the function, what we want to do, and we'll get, like, the function will build up as the more we do stuff, you know, the program will build up. So if you're at this point and you're thinking, oh, we should add that, or we should do that, just gonna hang with me for a bit, because then you'll see, like, what we're slowly thinking about things. Like, even myself, you know, like after you have experience with programming, you see this stuff, you're like, oh, I should add that, I should do that, I should do that. But it's just, we're sticking it slow for now. I was just gonna building things to hear my mental process. So we'll do that. And then what we'll do is, in Python, you can use if statements. There is something called a switch statement, which is a lot nicer. Python does not have a switch statement, but there's ways to implement it. But the way I would probably do this with like dictionaries and Lambda functions. So we're going to stay away from that just because it's a little more complicated. So we'll use if statements here. So we'll do if our option, right, equals 5. Now, notice that I'm using 5 as a string, and I'm not using 5 like that, because input actually returns a string. So whenever we input something, a value here, like 5, 4, 3, whenever we give it a value, we're actually getting back a string. So we have to use it as a string, at least for now. So we'll do that. Okay, we'll do string. So if option equals 5, does anyone know what I did wrong here? If you're screaming it out, good for you. So remember earlier before I was talking about how, yep, someone said it in the comment section. So I caught it myself. I didn't see that at the very beginning when I did it. But yeah, so remember that we need to go ahead and use double equals, right? Because I told you that assignment operator like this is different than looking for whether a value is true or false. So a comparison operator, they're different. So to compare whether option equals 5, we actually have to use a double equal sign. That tells us, hey, check if option is equal to the string 5. So we'll do that. And then the most simple way that I could think of exiting a program is like we did with the interpreter, right? Earlier we were talking about using the interpreter, which is over here. And the way we quitted the interpreter, or we quit the interpreter, was using exit like that. And that exits the interpreter. That applies to a Python program as well. Remember, within the interpreter, we're using things that are from Python. So we can do if option equals 5, we call the exit method like that, and that does that. And if we wanted to, we can actually go ahead and try that real quick, right? We run that program again. We'll enter 5. My output is out here. We'll enter 5 here. And as you can see, we stopped the program, right? We're read it back with this thing again. So that's probably the easiest way I could think of doing it. You can also, if you wanted to, you can go ahead and make it a little more complex and make a loop control variable like we talked about before, and make this loop control variable equal to false, setting it somewhere else, and we could do that. But for now, that's good enough. We'll do that. So now let's go ahead and move on to a different function. So we have that implemented. 5, it quits. Awesome. Now let's do add a contact, because I think in order to work with any of these, we have to have some context going first. So let's do that. So we'll add another option over here, and we'll do if option equals 1. Keep in mind, and again, I forgot this. Keep in mind that there also are things called else if statements. So if I wanted to go ahead and do this else if statements, if I want to go ahead and do if I wanted to do something else than that, I could do else if. In Python, it's elif. You can do elif and it'll do something else. But for right now, we're just going to sticking with if statements here. So we have that, and we're going to go ahead and put something in here. You can see it's already screaming at me because I don't have anything inside my if statement, right? So what we'll do here is we want to go ahead and compartmentalize our program as neatly as possible. And instead of doing everything here, let's make a function that does something so that whenever we press option 1 and enter that, it goes ahead and it runs a function instead of doing all the code for everything here. It's just a lot prettier that way. So we'll go ahead and make a function. I believe I called it add concept. Pretty simple enough. Let me just make sure. Yep, add concept. So what we'll do, remember how earlier I was talking about pass statements and how I usually would use them to like leave things blank, you know, like to make sure that, okay, I have an idea, I'm gonna use them, but I don't quite know yet how I'm gonna use it. So I'm gonna go ahead and use pass here, because this way the Visual Studio here starts screaming at me, telling me that there's something wrong here, because I don't have anything in. So I'm just passing it for now. But on top, we're gonna go ahead and build a function. We'll do def add contact like that. And then what we want to do is we want to actually make sure, and it really depends on how you want to structure your program, right? The way I'm thinking of structuring the program is by passing these things to the program itself. You could, if you want, not pass any parameters and then just go ahead and like I said, not pass any parameters to it, and then go ahead and here like do all the calculations, like ask for another input, things like that. But for me, it makes a lot more sense to pass that stuff to context, because I want contact to add a contact. That's the function of the function of my function, my method. I want it to add a contact. I don't want it to ask for a contact. I don't want it to ask a user if they want to do something. I want it to add a contact. So that's why I'm doing that. So I'm gonna go ahead and let me go ahead and read this real quick. Give me a second. Make sure I'm answering you guys' questions real quick. Yeah, so Noska just said if the switch statement exists in C++, it does. But they want to know if it exists in Python. So yeah, in Python, it does not exist. It doesn't exist. You have to make it yourself using dictionaries and Lambda functions, or just dictionaries will do by itself, and references to functions within dictionaries. If you guys want, I could actually go through that at the very end. It's not complicated. Let me just catch up here real quick. Give me a second. So I'm looking through this, and I don't know if I see a difference yet. Maybe I'm just skimming it really fast, and I don't see what the difference is between those two code blocks. Oh, yeah. Yeah, so I see what it is now. So yeah, so like I was saying before, you could, if you want, just do if and else statement block. I think what they're trying to get at here, yeah. So let me explain this in like this. So let's say we have an option, right? Like now we have 1, right? And if we know the value is not 1, then we could do an else statement, right? We do a statement that does something else. But if for whatever reason you don't know what your output's going to be, if you don't know if it's going to be 1 or something else, you might want to stick to if statements alone by itself. This way you're not eliminating the possibility of something happening where you didn't happen, if that makes sense. So for example, if I go ahead and use 4, right? And I use an if statement here, like this, instead. So if I use 4 and I come to here and it checks, hey, it's option 1. No, so it goes to the next one and does option 5 and keeps going to the rest, right? But if I do, for example, if option is 4 right here, and I do the option 4, it'll stop at 4 and it'll never go through the rest of them because I checked it for 4. And if only executes if this is not real, if it's not true. So for something like this, I might stick to if statements just because I don't know what the user might do. They might change stuff, or how I'm going to change the code later. So that's probably why I'll go with if statements. So yeah, something to point out. And let's go back to 1 and if 5, like that. Cool. So we have that. And then we have add contact, right? So what I do here is I want my function add contact to add a contact. So I'm gonna go ahead and pass in the name. Let me go back to my code here. I'm gonna pass in a few variables here. I'm gonna pass in contact name first of all, because I want that to be part of it. And I'm also gonna pass in a phone number because I want the phone number, right? If I'm gonna add a contact, I need two things. I need the name of the person whose contact that is, and I need their phone number. So we're gonna do contact name and contact. No, I named it contact phone number. Realize that I'm using, my names are pretty descriptive. Contact phone. The reason behind that is because I like making things descriptive. If they're not descriptive, it's fine. I mean, as long as you know what you're doing. But if somebody else looks at your code, it's easy to see that add contact says a contact name and it takes a contact phone number. Whereas if I did something like this, then you're like, okay, contact takes in an X and a Y. What is X and Y? I don't know what X and Y is. But if I do this, oh, contact name and contact phone number, cool, right? So we'll do that. And then what we'll do here is we're actually gonna go ahead and just add it to the dictionary. I did do some other stuff, I think. Yeah, so I did some other stuff, but for the basic stuff, we're just gonna go ahead and add it to the dictionary. We're gonna add a contact. So in a dictionary, we go ahead and call a dictionary, right? Because we know that's where we're storing our values. We're storing it inside our dictionary. What we wanna do is give it a key. So in order to do that, what we do is we do this. Just like when we use a dictionary to pull values, we could do the same thing to put in values. So I'm gonna give it a contact name, like that, and I'm setting a value of contact phone number, like that. That's what I'm doing. I'm just setting the value, right? Now, because contact is an empty dictionary right now and nothing exists, that means that when I put this in, it's gonna make that key. It makes that key and it assigns that value to that number. So we have that. So that's it. We added the contact, right? We'll work on this a little bit more later, and we'll go ahead and like develop it a little bit more. But that for now, we added the contact. Again, we're going with basic stuff, right? We're thinking basic. Okay, in order to do this, we have to do this. And then once we got that stuff, we could keep adding stuff to it, you know? So think of basic things here. Yeah. Cool. All right, so we have that. Now let's actually go ahead and do the next thing that I think is pretty easy, which is print all contacts. So we have a contacts, right? We can keep adding contacts to this as many times as we want, as long as we call it. But we actually haven't used this function yet. I noticed that. So let's use that. So if option equals 1, we add a contact like that. And we need a way to actually get the user name and the phone number, because we don't like we don't know what that is right now, right? So the way we do that is we could actually use the input statement again if we wanted to, like that, and use it down here. Probably call it something more descriptive, like contact name, right? And let's make this different too. Let's tell it, hey, enter the contact name, what did I put before? I don't remember exactly the words I used, but we're going to go off with whatever I think is natural. So we'll go enter contact name. And then we'll copy this here, and we'll do the same thing. But instead of contact name, we want to go ahead and do contact phone number. And then enter contact phone number. Okay, so we have that. What is it screaming at me for? Okay, so it's just variable names. Not too important right now. But yeah, this is a camel case. I have noticed this. I think it depends on certain parts of the program where you're using these conventions, but I also think maybe because it's not used. Anyways, we'll keep going here. So we have add contact, right? Add contact is a function that we have here. And as you know, add contact takes two parameters because we defined it that way. It takes a contact name and a contact phone number. So in order to pass that in, we're gonna go ahead and pass contact name and contact phone number. Now again, keep in mind, right, that contact name and contact phone number are separate, right? They're not the same thing as this. This is not contact name and it's not contact phone number. There's just the values we're passing it in. Now, because they have the same name, it's just because I chose it to be that way, right? Because for me, it's a lot easier to think, oh, okay, what am I getting? I'm getting a contact name and I'm getting a contact phone number. And then once I pass those values in, they create a copy of those values and use them there, but they're not the same. So just keep that in mind. We talked about it before, but it's important to kind of think about scope of things. So we have that. Contact name equals input contact phone number equals that. We pass that into that, and if that goes well, then we should add that. Now, in order to verify that things are going well, let's actually go ahead and implement the next function, which is to print all contacts. So we'll do another if statement here, right underneath this one. Here, we'll do if option is equal to 3. That's one for printing all contacts. then we'll go ahead and do something here. Now, again, I want to keep this simple, right? So this is nice because this is in here and it's just kind of concrete, simple example here. And we didn't have to do a lot of logic here because later on we will be adding things to add contact and it's gonna get more complex. And it doesn't make sense to do that here. So we're gonna do the same thing. We're gonna go ahead and implement another function to make sure to compartmentalize our functions so that things are clean and nice now. They're easier to read. So like we did before, we added add contact. Now let's go ahead and print all contacts. Let's add a function that says that. Make sure I have that same name. Like right now, if you see, I'm just going off base what I think the name should be. I did use print contacts. What the name should be because I'm going descriptive. Right? I want to make sure they're descriptive and they make sense to you. So def, we'll do a print. I see that I split this up into different functions. I'm gonna go ahead and do it this way, and then I'll show you why I split it up later. I split them up into different functions because it makes a lot more sense. But for now, we'll do print all contacts. Yeah. And then what we'll do is we don't want to pass any parameters to it. We just wanted to print out contacts. So we already know that contacts is here, right? We have a value. It's a global variable, meaning we have access to it throughout our whole program. We could actually just access that. And like I said before, like the section before, I believe it was, we actually went ahead and we talked about how to go ahead and loop through a list, right? And how to loop through a dictionary. So we could do the same thing here. We could do something like for, and we could go ahead and use the get the items function to get a tuple of a key and a value. So in our case, we know the key is the name of the person. So we'll do a name. And we know the value is the phone number. Like that. And what I'm going to do now here is for that inside of our contacts, right? That items, that gives us the items of the list, right? In a tuple, like I said before, does that. And for that, I'm just going to print it. I'm going to do print. I'm going to go ahead and do name like that. And this is a good example. So let's talk about f strings. So I was supposed to talk about f strings when we were talking about inputs and stuff, but I skipped it because I wanted to talk to you here. So f strings are just a way of, and there's more than that. You don't have to use f strings, but I find them really useful. So I think it's a good way to use it. An f string is just like a regular string, but with an f in front of it. It's called an f string, or a formatted string. So for example, let's say I'm gonna go ahead and print name. Right? I could do this. I could do name, and then I could do phone number. Like that. That's just going to print name and phone number. But I want to go ahead and kind of make this a little bit nicer. I want to make it so that when I print it, I have a colon in between both of them, like that. So I could do this with a regular string, like this. I could do name plus this plus phone number. And maybe add some spacing here to make it nicer, like that, right? This will make it so that when I print it out, it prints out the name, and then a space, and then a colon in between them, and then another space, and then at the end, it'll print the phone number like that. So we'll have, basically, we'll have a value that looks like this. And let me add it to the comments, why not? So we can actually see. So a comment, it'll look like this, and then a number, right? That's what it's gonna look like. That's what that's gonna do. That's cool and all, but I like f strings because they make things a lot more like nicer. This is nicer for me to look at. The way you do the same thing with an f string is like this. You'll do f like that, and you'll follow that off with quotes, and then you use curly braces like this to put variables. So variables you want. In this, I want to do name, and then I want to do that semicolon, right? Like that. Notice that we don't have to do any of this. We just put it in there inside, as long as it's within the f string. And then I'm gonna go ahead and do another variable and put phone number. Like that. And that's the exact same result. It's just that I like the way it looks a lot more nicer, you know, without having to do this double appending and stuff like that. It's just name, colon, and phone number. So I have that. I'm gonna go ahead and get rid of this because they're exactly the same. Maybe I'll leave this here. That way you can see other ways of doing it, right? Let's just do that in there. And that's what that does. Let's actually try this. Let's go ahead and... So it looks like I have an error here somewhere. Unexpected indentation block. So for option 5, if we go down, look at this. It even tells you the line, right? Line 34. So if we go down to line 34, which you can see down here, we have names. At line 34, I have if option equals 5 and then exit. So as you can see, the reason this is happening is not here. is because on line 31, I never told it what to do. So this is one of those times where I was talking about that before at the beginning, that indentation can be one of those things that's really important, because you might do this, right? And if you do this, you might think the error is here, but it's not there. It's just because you messed up with your indentation, and it's thinking that this is part of it, and it just doesn't make sense. So what we want to do is go ahead and call that function, which we called it print all context, like that. And now we save it, and we're good. So someone asked me, are you going to make a YouTube tutorial on this program? So after I'm done with this, I am going to go ahead and upload it. And likely, if anything, I'm going to go ahead and upload it to YouTube so everybody can see it there. Yeah, thank you. So you got to go? No problem, man. I'm glad you enjoyed it. Yeah, so we have that. Or woman. I don't know your gender, but yeah. So we have that. It prints all contexts. So now we'll go ahead and run a program real quick. Right, we have two functions that we added. We go ahead and add a contact now. Let's add a contact. And it says enter the contact name. We'll call it Alfredo. And then enter the phone number. Like that. And then there we go. We have it. And now if we go ahead and verify that worked by printing all contacts, we do that. And as you can see right here, it printed out Alfredo. See that? It printed out the name. So then we know that worked. One thing to know is that this is getting really messy. Like if you see this right here, like it happened so fast that I didn't even notice, but it's getting messy because it happened right here. I don't want that to happen. Like you just keep printing a bunch of stuff every single time, because if we keep doing that, right? And I add Tim. Oops. Enter a contact 1. Okay, answer option 1. Well, this Tim. Phone number. Right, and then look at how messy this is getting. Right, we have here, and now we print all contacts with 3. We have all the contacts here, but it's just getting really messy. So this is, we talked about modules before. This is a good time to introduce a module. There's different ways of doing this, but I think this is the most straightforward way for this simple program that we're going to do. Thank you, man. Hope you enjoyed it. Yeah, so people have to start going. And I know people are kind of been here for a very long time. We have like, we've had a few people at the beginning. Now we have like, people are leaving, so there's like one person here. So that's really cool. I mean, regardless, I'm still gonna go ahead and continue doing this, so I can go ahead and record it and paste it at the end. But if anyone jumps on, it's awesome. Yeah, hopefully I continue it too. Like if this goes well and people like it, I could start talking more like different topics. People requested programming, like web development. I think I saw app development, so many things. I could definitely throw so many things into this mix. Cool. So we'll keep going, you guys. We should see here, because I think Theo's about to leave. I just want to go ahead and catch his last words. Awesome, man. Cool. All right. We keep going here. So we have that option equals 5. We'll have option equal 3. We have all the contacts. Now, like I said before, this is getting kind of hectic, right? I don't like how this is like all jumbled up in here. It's kind of getting hard to read. So I think it's a good time to introduce modules. One thing I want to go ahead and introduce is the system module. So we could do that at the very top. We could import a module, and this is part of the standard Python programming. Goodbye, man. This is part of the standard Python libraries, so it comes with it. So we'll go ahead and import that. And we can go ahead and import the OS module. The OS module, it's operating system. It allows you to interact with the operating system of whatever you're using. In this case, the reason I want to do that is because I'm going to go ahead and interact with Windows in this case to go ahead and clear the screen. Because if I clear the screen every time, whenever the loop starts again, that makes it so that I don't have to see a bunch of text all the time, you know, like flying up and down. It's just filling my screen. So we're going to do that. So I'm going to go ahead and import from OS, import system. So from the operating system module, I'm going to import the system function here. And what I'm going to do is I'm going to go down to here. And at the beginning, right here, should I do it here? Did I do it here or inside my loop? It really doesn't matter how you want to do it. Let's do it in here. So I'm going to go ahead and do it in here. I'm going to go to system. And then system takes a command for the actual operating system. In Windows, the command we can use to clear the screen is CLS. And in Linux and Mac, we can do that with using the clear command. So if you're on Linux or Mac, you'll do that. You'll do like that. But on Windows, we use CLS for clearing. So that's the way that works. And now if we run this again, you'll notice that, let me go make this a little bigger. You'll notice that it's this, right? And then I went ahead and run the program. Let me add a contact, Alfredo. And as you can see, you'll see something interesting here happen in a bit. If I press enter, you see that it did it, right? We press enter, that's fine. But now what happens if I print out contacts? As you can see, nothing, it's like nothing's happening. It's not working. It's not that it's not working. It's because we use a clear, right? So with the clear command, what we're doing is we're actually going ahead and after we print something, like we saw down here, we print all contacts, and then because we're in this while loop, it goes back to the top again, and the top of the menu is CLS, which means it clears the screen. And because it clears the screen, that means that, like, you know, we're clearing it every single time we're printing it. So that's why that's happening. So an easy way to overcome that is to add a little thing over here. And we use input. Remember, input is used to take input from a user, right? Like that. If we use input, we could do something like this, and we could say press. You press enter to return to the main menu, like that. So we do that. That makes it so that whenever you come here, add input, it stops it. It like halts the program, so that once you press enter, you don't have to put anything. Once you press enter, it'll continue the program. So it's like a halt. This way, when we print context, we get to see it, and then once we're done seeing it, we can press enter, and then we'll let me remove this space. We can press enter, and then we can actually go ahead and continue our loop. So let's do that real quick. Let me show you that. Let me rerun this again. Clear the screen for you. Like that. We'll go ahead and add a contact. Right? Like that. And that's our number. Like that. And then as you see now, this comes up. Press enter to return to the main menu. So we press enter, and we're back. Now we press 3. There you go. It shows it, and then press enter to return to the main menu. We press enter, and we're back. So that's cool. Now we don't have a bunch of text everywhere. We can see things clearly, and we stop executing the loop when we halt the loop when we need to see stuff. So that's what we do that. Yeah, I see at this point we have one person in here. So if at any point, man, you have any questions, just feel free to ask anything you want. No, don't worry about it. Just ask anything you want. So we have that. Print all contacts. Enter. Now let's go ahead and keep implementing different parts of the function. So we have add contact, we have search for a contact. Let's see what we should do. Let's actually work on print functions a little bit more. So I think what we should do is, because right now the way we print functions, right? Print contacts. If we print contacts, it looks like this. But I think we can make this look a little bit nicer. So let's do that. So that's actually why I decided to go ahead and split my print all contacts and print contacts. So if I go to here, I added a function called print contacts. So if we go up here to the top, let's add a function here called def print contacts, like that. And what I did here is I went ahead and I took a contact. I took contacts. Now I'm gonna explain this a little bit I'm gonna explain it in a bit right now. But contacts, if I could spell, contacts is a list. So in this case, contacts is expecting a list. So we're going to go ahead and put a list in here to print all contacts. So we obviously need a way to do that, because right now we have no ways of getting a list. We have a dictionary, but we don't have a list. So we have to get that somehow. So, but for now, let me go through the things. So assuming that we have a contacts, a list of contacts, what we're going to do is we're going to go ahead and do a print statement here. And we're going to go ahead and use an F string again, because I like F strings. Although looking at it, we don't really have to. Let's not use an F string because it's not necessary for this case. I don't know why I used that. And then what I'll do is I'll do this. I'll add 3 lines like this, and I'll do contacts like that. That's like a header that I'm gonna use. This could be simplified in so many different ways. So if you want to see that, we could also do this. We could do something like this. It's overkill. Well, if we want to, we could do this. 3. I might prefer to do this. Let's just do all 3 ways, so whoever's watching can see what I'm doing. Like this, and then we'll do. Now I know this is a little more complicated than the other one, but I'll explain it in a bit. This is a way of, as you see here, we have. Let me get rid of this so you can see better. We have this, right? We have a hyphen, just like this, or a dash, whatever you want to call it. I think it's called hyphen. And then you're multiplying that by 3. Now, when you do that with a string in Python, that makes it so that 3 of these appear. So that's this. It makes 3 of these, and then you append a string like this, contacts with the space here, contacts, and then space at the end. That makes this part of the string right here, like that. And then at the end, we're just adding another 3 of these dashes. That's another way of doing it. A prettier way of doing the same thing might be something like this. Something like this, where you do an F string, and then in here, you do single quotes this time, because if you do it this way, it's like I'm using single quotes to denote that this is a string instead of string. So that's why earlier at the very beginning I said I like double quotes, because when I use F strings I can use single strings in here like that. And then we do 3, right, like that. And then in here we can do contacts. And then I'm just going through this to kind of show you different ways of writing things, right? But if you like one or the other, you can just stick with that, right? 3, like that. That's the same thing. These are all the same things. So I'm going to just comment those out. The way I did it, by the way, in Visual Studio is you can highlight something and then press Control and then the backslash like that, and they'll comment something. So if I do that, it'll comment or uncomment something. So that's how I did that. And yeah, let me just go ahead and uncomment this. We have print contacts. And what I'm going to do here is, now that I have that, I'm going to go ahead and do the loop. Again, remember, we don't have a contact list yet. But if we did have a contact list, the way we'll print that is by actually go ahead and doing printing the contacts. One more thing I want to add here is I want to add a \n. Now, \n is one of those things that happens in like pretty much any language. It's just a way of denoting a new line. So \n means that when I print something here, when I print something, before printing it out, we'll have a new line. So it'll be like an empty line, and then it'll be contacts. The way I'm doing that is just kind of separate my output from the rest of the program, just to make it a little bit nicer. And by default, print actually prints a new line at the end. So at the end, there'll be a new line regardless. So we're putting it at the beginning there. We have that. I'm going to go ahead and do a for loop. Remember, with lists, we could go ahead and loop through an entire list using a for loop. So we could do for contact in contacts, like that. And then what I want to do here is I'm going to go ahead and print every single contact. But before I do that, I want to make it so that my contacts are printed nicely. And I realized at some point that I was going to go ahead and keep doing this over and over again. So because of that, I put it into a function, because this is something I do more than once. So again, whenever you're using things, and you'll see when we use it again, I'll point it out again. But whenever you're doing things and you find yourself repeating yourself, that's a really good time to make a function. I guess for now, for the purpose of teaching, I'll do it how I wouldn't do it, or how I would do it normally, and then realize, hey, I'm using this again, I should make a function for it. So let me show you. So let's print here. The way I did this here. Okay, cool. So I see why I did that. So this is a list, right? Contacts is a list, but more specifically, contacts is a list of contacts. This is the way I formatted it, of which all contacts is a. So a contact is a tuple. So I'm defining a contact as a tuple. So right now, technically, I have a list of contacts. So once I have that implemented and it goes in here, it's going to look something like this. And the reason I did this is because, again, I want to teach you, right? I want to teach you the stuff that we've been learning for a while, like implement it for the last 4 hours now. So we do that to kind of show you that we can nest things inside things. So we're going to list tuples inside a list, nest tuples inside a list. So we'll have something like Alfredo, and then we have a phone number. That's how a contact is defined. This is a contact right here inside of it, and the outside is a list. So that's what this list of contacts looks like that. So that's what that looks like. And obviously we have more than one, right? For the sake of doing it, let's add that here. Just like that. Okay, so that's what that looks like. So because I have a list of contacts, what I could do is, since I know contact is an item within contacts, and that's that, what I could actually do is go ahead and do what we did before, right? We know that we go ahead and get a contact using indexes. That's one way of getting it. But we also know that we get contacts by using items, right? And destructuring the elements, or just using, like we did before, right? We did like a key value equals some sort of a tuple. So because we know contact is a tuple within contacts, what we could do is do something like this. We could do name and then phone number equals the contact, right? Just like we did before when we had a value and another value, we did that. Name, phone number equals contact. Now the reason it's underlined is because I haven't used them yet, but right here we're going to use them. We're going to use an F string like this. I'm going to go ahead and do name like that and number, phone number, just like that. So now when we print it out, we're going to print it in such a way where we have the name like that and that. Now you might be wondering, okay, well, what's the point of that? We didn't really do much of it other than just kind of rewrite what we did before. But now we have a nice header here that we could use to kind of make it so that it's prettier and we could see like things just easier to see. So that's why I decided to make that choice. And at the very end, I'm going to just go ahead and print a new line. And the way I'm going to do that is just by using print. And I told you by default, print just goes ahead and prints a line. It prints an empty line at the end of something. So if we do this, we do print, that's just printing nothing, but there is a new line in there. So it's just making a new line. So that's why I did that. Yeah, the live will be on the YouTube. Yeah, man, thank you for sticking around. Appreciate that. Yeah, so also I will put all the information about it in the Learn with Alfredo channel at the end. So that's going to be there. And then after that, I will go ahead and probably host it on YouTube because that's the place I can think of hosting it. Yeah, so it's going to be on YouTube. Okay, so we continue here. We have contacts. We print an empty line here. Now, if we go ahead and restart a program here, again, we have to restart it when we make a change. So if we go ahead and add a contact, let's do Alfredo. Phone number. Like that. We'll enter, and now we print contacts like that. You see that it's the same, and the reason it's the same is because we never actually implemented the print contacts function, right? So that's important. Whenever you print a function, and I see this happen pretty often, but this is really like a really beginner thing that happens. It's like you'll do this and you'll implement it, and then you're like, but it's not working. But I did the code. Well, you haven't actually used the program or the function yet. So if we go down to print contacts, that's what it's called, right? Before we had a thing called print all contacts, right? So keep in mind that even though I'm going to change this right now, we can't use it yet, right? Because watch. So we call it print contacts, right? But this is red because we required an argument, right? We said that print contacts takes a list, but we haven't given it a list yet of to get. So where do we get that list? Well, for that, I decided to make a different function. Let me go down here to remember exactly how I did it. Stick to my plan. Yep. So what I did is I made a function. I call the function get all contacts. And the reason I did that is because I wanted to make this reusable again, right? So if you notice in the original program when we first did it, I made it so that, and let me show you that, why not? So if we open the one that I completed already, right? And then I go ahead and add a contact real quick. Right, and then do another one. But one's fine. If I went ahead and I print out contacts, right? Like that. Argument contacts. Oh, wrong contact. Remember, we're using the one in my solutions folder. Like that. Add a contact. This doesn't really matter because I actually didn't implement anything to check numbers, but that's, by the way, that's one of the things that I put at the end. At the very end, what you can do later on is kind of implement like things to check whether numbers are actual numbers or names are names, you know, things like that. We do that. If we go ahead and print all contacts, you'll see that it prints one contact, right? And the reason I decided to make a function that prints all contacts is for number 3. But if I ever want to print one single contact, I could actually reuse this function because all I'm doing is printing a contact there, right? Even if there's one single element inside this list, we could just reuse this function to go ahead and print one single contact. Now that's important because we're reusing code, right? The more we can reuse, the better. Like, it's a lot cleaner and nicer. And this way you don't have to repeat yourself of writing the same code to print one single contact or writing something simpler to print one single contact, when you can just use this and it's a lot simpler because you already have the logic for it. So keep going here. Okay, we have that, and now when I get to make a function now, like the function that I made was called get all contacts. This is going to be useful to get all the contacts from our our dictionary of contacts and then use those to print. So we can call def get. And again, I'm talking a lot because I want you guys to understand why it is that I'm making these decisions. Like, I'm not just doing it, you know, like the more you can think about it and think about, okay, I want to go ahead and make this clean and compartmentalized. And it comes with experience, but that's really why I'm talking a lot, so you can see that stuff. Okay, so we have get all contacts. Now, get all contacts, if I'm not mistaken, it's just a function to get all the contacts. Pretty self-explanatory by the name, which is why it's good to have descriptive names, right? So yeah, while I'm doing that is making a contacts and then putting it all into a list, because I want to get that to go ahead and print into all contacts. So first of all, let's make an empty list called contacts. Now, to be completely honest, this is kind of redundant to do, and I probably wouldn't do this in an actual program, but I wanted to show you this because then we're going to start using return values. So like we talked about before, the point of this program is to go ahead and teach you things that we've been talking about this in the past session, and return values is one of those, so you get to see how that works here. So we'll do contacts here, and then for a context takes a parameter, I believe. No, it does not. Okay, we're just going to use the context where all the contacts are stored in the dictionary. So we can do that like we did before, right? We did that before somewhere down here. Since where we did that right here, contacts at items. And as you can see, this is why I said that it's important to think of things you're doing different more than once, because this whole thing is going to be replaced by the stuff we're doing right now, because I'm repeating myself at this point. I know, hey, I've done this before. I did it somewhere else. This is where I did it. So I know that I'm repeating myself, which is why I'm making a contact for it, a function for it. Let's rewrite it again so I can show you why it is I'm doing that, but we'll keep doing here. We'll do for name like before, and name and phone numbers. Remember, it's a tuple, so we can go ahead and structure it. Phone number, or unpack it, how Python calls it, in contacts, like that. Add items. This gives us a tuple of items we can use, like that. And then what we're going to do for all of those is we're going to go ahead and just append it to our empty contact list, right? So we'll do something like contacts.append, like that. And we're going to append a name and a phone number. So we'll do this in the form of a tuple. And you can do this without this, but I want to show you something real quick. So we'll do name and phone number, just like that. Notice that right now I'm using a tuple like this because I wanted to show you that you could actually go ahead and you don't have to have a variable name, right? Whenever you go ahead and append something, it doesn't have to be super specific. You can go ahead and add a tuple here. I'm making a tuple. I'm making a new tuple here as I'm appending something to it with these two values. So that's why I wanted to show you that. So we have contacts like that, append a name and a phone number, and then at the end, we're going to go ahead and return all the contacts. So return contacts like that. So as we have that. Earlier I was talking about list compression, so I guess for the sake of that, let me go ahead and show you how you would do this with list compressions, because it's kind of cool. You'll probably do something like this. You'll have a list, you'll return a value. You can do this in one line, so it's really nice. So you'll return like this, and I would make a tuple like that with name and also phone number like that. And then I'll do something like this, a for loop for name and phone number in contacts items. And that's it. And that will give us the same result. As you can see, we did it in one line, which is awesome. Like that. Let me just go make sure that, yep, that's good. So we did that with one line, which is awesome, right? I'm gonna put this here, alternative. Using list compression. So that's called list compression. We can do that with one liner. We can just get the whole thing done, which is a lot more concise, which is really nice. But also, I know that just looking at that, you're like, what is that, bro? Like, you know, what am I looking at? So that's just one thing to do. So we have that. And that returns the same thing. So now that we have that right there, what we're going to do is get all contacts. We have a way to get all contacts. So what we can do is pass that information of getting all contacts to our print all contacts in a list, which is what we're getting back, right? We're returning a list, as you can see here. We're returning a list of all the items. That's what we're getting from this function. List compression. comprehension, really? Oh, I've always known it as list compression. So anyways, we'll do that. We'll just leave it there. If it is list comprehension, let me know. I think it's called list compression. But anyways, we have that. Where we're at? Yeah, so we have that. We have a list of contacts, right? We get all our contacts back. So what we can do is here, instead of using this print contacts now, which is obsolete, we no longer need it. I'm actually going to go ahead and get rid of it completely. Or leave it in there, just for the sake of following along with the video. If you want to see what that was before, I'll leave that in there. And what I'm going to do here is I'm going to go ahead and print contacts that we had before. But we want to make sure that we get a list. Now, we could do something like this. We could do this. We could do a list of contacts equals get all contacts, like that. And then pass that in here, list of contacts. And that's perfectly fine. Let's go ahead and comment that out so you can see that's perfectly fine. There's nothing wrong with that. Or you could do something like this because it's a really small function, so it doesn't get too complicated. You could do print all contacts, and then within here, get all contacts, like that. See that? So it's the same thing. But instead of making an extra variable, we're just putting print all contacts, and we're getting a list. So this gives us a list, and we're passing that to print all contacts. So now if we run that, quit this. Python contacts, Python, like that, and then we go ahead and add a contact, right? And then the phone number, that, and then print. And as you can see, we printed the contact, right? Now we have this nice header here that's separated from the rest of our thing here, and separated from the end as well. This way, it's kind of like its own thing, and we can see that, right? If we do that again, we can go ahead and add another contact. That, something like that, and then we go ahead and print all contacts. So we do that. As you can see, separated nicely, and we have a nice way to see it. You could even change this if you want, right? You could do like name, Alfredo, phone number equals that. You could format this however you want. So that's cool. But we have that. Cool. List comprehension. Okay. Okay. Good to know. All right, we'll keep going here. I probably should change that just in case. Where did I put that? Compression. So I was pretty sure it was called list compression. Where did I get that from? Let me just make sure, just we're at it, because thank you for bringing that up, by the way, because in that case, just make sure. Oh yeah, similar to list comprehensions. Wow. Good to know. It's interesting. This whole time I thought it was list compressions. Okay, well, we can do that. List comprehension. Cool. We have that. And then once we have that, we have a way of printing all our stuff. Now we have a way of going, now let's actually work on something else, right? We have pretty much these functions that are functional. And again, we started small. So look at the small portions of the program that we're making. And now we have that. We can move on to different parts of the functions, right? Different parts of the program. So we have eye contact that's good for now. We have search contact, which we have not done yet. We could do that right now. There's also delete a contact. I think delete a contact is probably simpler, so we'll go with that. So we'll go with the basic implementation for delete a contact. So we'll do that. That's option 4. So we'll add that in order here, just to make sure that's fine. Yeah, I thought it was list compressions. I don't know where that. Maybe I just read it too fast or something. So we'll do option 4, like that. So option 4 is going to make it so we delete something, right? So the way I probably named that like delete contact, something like that. Let me just make sure that's what I did. Yep, delete contact. Delete contact is a pretty long function because it has a lot of stuff in it, but we're going with basic implementation right now. So we'll do, we'll pass for now, and then we'll go up and we'll create that function. I'll put it right here. Delete. So delete contact takes a delete query. That's what I call it. Now you might be thinking, why is it a delete query, right? Why didn't you pass in something called like a name or a phone number, right, to delete something? And the reason that I did delete query is because I want to go ahead and pass in both. I want to pass in anything. I want to make it so that you could delete a contact using a name, or you can delete a contact using name or number. So that's why I call it delete query. You can call it anything else. That's just what came to mind for me, delete query. So we're going to go ahead and use the name delete query to actually go ahead and delete a name from our list, right? Or our dictionary. Because remember, our dictionary is what stores all our contacts, right? So what we want to do is we want to do it so by name or value. Now, you can do that with certain functions of like dictionaries. You could pass in like I think it's called delete or remove or pop. One of the, I think it's probably pop. With pop, you could actually go ahead and remove something by name, but I want to make it so that it's both. By name meaning the actual key value. So the way I decided to implement this, let me see. Contacts. Okay. Yeah, deleter pop. Okay. So I guess deleter pop can be used for doing something by key. So the way I decided to do this was a delete query. So whenever you want to delete something, you first have to find it within the dictionary, right? Because especially if you're going to do it with a name or a number, so you want to make sure that's there. So if we want to go either way, we want to make sure that we can do that. So I made a different function for that. For now, let's just pass and show you that. I'm going to search for it. So what I did is I made a function called search contact. Like this. So for search contact, what I'm going to do is I'm going to go ahead and use it to search for a contact basically. So whatever contact we're asking the program to delete, that's what we're going to go about doing there. I have it right here. Yeah, so the way I'm doing that is I'm making use of default parameters because we talked about those when we were learning stuff. So I named it the same thing. So I went with search query, in this case still delete query. That's the query we're going to search. That's the thing we're going to search for. And for the sake of it, I added a parameter, a default parameter. By default, it's blank. Now, I do want to point out that inputs, if you just press enter without anything, the default it gives you back, it's just an empty string anyways. So this really wouldn't make a difference as far as functionality for the program goes. But I added in there because I wanted to go ahead and make sure I added I had default parameters in there so you can see how those work. So that's why that's in there. Just keep in mind that it's unnecessary. So we have that. And then what I'm going to do is I'm going to go ahead and do contacts. Again, an empty list. Now, even though the function is called delete contact or search contact, it should probably be called search contacts. Let's make that change right now. So it should be called search contacts because it gives you back a list of contacts. So if there's only one item in there or like one search query that it finds, it'll give you a list back of one single item. But if there's different contacts that have the same phone number, like you saw in the example we did when I first ran the program to show you what it's like, when we did that, it gives you back a number, a contact list of the same query, the same queries, and this gives me the phone number. So if I found a contact, two contacts or more that had the same number, it gives you all those contacts back. So yeah, let me get some water because my mouth is dry, my throat. I've been talking for what, like 4 hours now? An hour or something? 4 hours and 17 minutes talking, so my mouth is getting yeah, 4 hours. Okay, cool. So we keep going here. This is the last part of it, so we're getting through. I'm sticking with it, and we're getting through the whole thing. I expected it to be 2 hours, and then I realized that there's no way I'm going to fit in 2 hours with all the information. Anyways, we'll keep going here. So search contact is a search query, and a query again, it can be a phone number or a name. So we have a list of contacts, and what we're going to do right now is kind of go through that and kind of find those elements inside the dictionary that we want to get back. So we're going to go ahead and go for name and phone number inside of our contacts. And then again, we're going to return an item, a tuple, right? We're going to make sure we get that back so we can access it this way. And then I'm going to go ahead and do an if. So the if statement is going to be used to search if something matches our query. So we want to do an if because we want to make sure that, again, we want to match either the name or that's a keyword, match the name or the phone number. So we could do it like this. We could do for if search query is equal, or you could do that, but we'll do this in name. In is just another way of kind of thinking about, they both work. It's like an equal sign, but in sometimes is used for lists as well. So that's why I put that in there, so you can see the differences between in or equal to. So if it's equal, if the query is in the name, or the search query is in phone number, then we're going to go ahead and append that contact. So contacts.append, we're going to make another tuple here of name and phone number, right? One thing to know about in is that it can also be used to find strings within strings. So this might not be the best scenario, the best thing to do if you want to have a concrete match. So for example, if I went ahead and I search for, let's do it down here, so I have a comment for it. If I went ahead and I, Alfredo, right? And then one of the items inside our actual dictionary has a name like this, that will match. And the reason that will match is because Alfredo is in dictionary, like it's part of the string. So that will match, right? Like that. So if it's that, then I must just put true. So if that's the case, then it'll be true, and then that will evaluate to true, and they'll show you that. That's fine for me because I want to make it so that maybe you don't know the whole name of the person, and you want to put like half of the string in there, just like parts of it, and then give you back like a result, you know. So that's why I did that. But if you wanted a concrete search so that doesn't happen, you will use double equal signs instead to search for equality instead. Yeah, thanks. 4 hours is a long time. Yeah, we're going through it though. We're good. We're good. Okay, we have that. So we'll do that, and we'll append that to the list. And at the end, what I want to do is I want to return all the things I found. So I'm gonna go ahead and return contacts like that. And again, if you wanted to, you could actually go ahead and do this with list comprehension, as well. You could do this with list comprehension by just doing the same thing as before, but at the end using an if statement to make sure it's good. And I could probably do that to kind of show you what that would look like. So we'll do something like return like this, and we'll return this number like that, and we'll do that for all of our this thing here. Yeah, what's up? Yeah, maybe at the end after I'm done with this, I might be around for a few more. You could just go ahead and post it in the program in general or something, and if I'm there, I'll see it. I'll hop on by afterwards. I'll see it. Cool. No, this is actually the first. Yeah, because my thing is not recording. Someone just hopped in and they asked if this is a thing that we do daily or something. This is the first time we've done this. If you look into the on the side, we have different channels. It's called Learn with Alfredo. It's like an introductory a course to like Python and programming. We've been going on for 4 hours now, so it's like a live stream of just me teaching Python. So yeah, just go into the on the channel. It's called Learn with Alfredo, and there's more information in there. Yeah, thank you. Okay, cool. So we'll keep going here. So again, for list comprehension, we'll do with name, phone number, for name and phone number in contacts items. Now at the end, we want to make sure that it only happens if this is true. So with list comprehension, we can do so by just appending the if statement at the end here, like that. So that's the same thing as saying that, and that should evaluate to true. And when that happens, then we'll go ahead and append. A lot longer of a line, but same outcome. So we'll keep going here. Return contacts. So that gives us, once we search right, that should be all the query. We search for our stuff, and then it gives us all the stuff we found within our dictionary. Now that we have that, we're working on delete a contact, right? So we pass in a query. What we're going to do now is we're going to make use of that function that we just wrote to search to find all our items. So if we go back here to that function we were working on before, delete contact. If you remember when we did the deletion thing, I added a prompt to ask the user if they want to go ahead and delete something, right? As a prompt to confirm, because it just makes a lot more sense. Other than that, like them accidentally deleting delete, and then you delete the contact and it's gone. It's like, oh, I didn't mean to do that. So we're gonna go ahead and do that. So for that, I added a true variable, a Boolean variable. So I call it delete. Deletion confirm, I call it. Like that. And then I set that to true at the beginning. So by default, it will be deleted. And then later on, we're going to check whether or not we should do that for the user or not. And I also added a contact to delete. Now, contact to delete is just a contact that's going to be deleted. The reason I have none right here is because later on I'm going to do some stuff with it. So none just means it's like a placeholder. It means that this variable is of type none. It has no. It's not. Don't say that it's not a type, because it is a type. It's a type none. But basically, I use it as a placeholder. So none is a type. So we'll keep going here. Contacts, and then this will make use of our contacts, right? Of our search function. We want to go ahead and get a list of all the contacts that we want to go ahead and delete, and I'll put them in a variable called contacts, and then just go ahead and pass a delete query to it. So we do the search contacts with our delete query, and our delete query is this here, right? Our delete query is actually the search query. So when we pass, when we call search contacts, the query we want to delete is a search query. So that's awesome. It's a really nice, just how you use those right there, because it's just kind of just matches, it just works nicely. So we have that. And then what I'm doing later on, it's actually looping. I want to see if, kind of pause here a little bit and go through it to see if I can explain why I'm doing this, rather than just going through it real quick. Okay, let's go off, before I jump into that, let's go off, like, again, it's just the basic stuff, right? So once we've, like I said before, start small. Like when you're building a program, you start small with the stuff you want to go. And then after you got that stuff, then go ahead and start adding things to it. So let's just do a delete contact portion. So we'll do a contact delete. We'll search for contacts. So this is all the contacts. If this works fine, this will give us back all the contacts that we're going to go ahead and delete. So we have that. So what we can do here, for example, is use a for loop to go through all this stuff, and then just delete the different contacts. So basically, we'll come back to the rest of the stuff, but basic stuff, we'll do something like for contact. That for contacts and contacts. And one thing to keep in mind is that we want to go ahead and delete this from our master list, right? Our list of contacts, which is this, it's a dictionary. So if we use delete, we cannot do so within within the list, because this is a copy of the contacts we actually want to go ahead and delete. We want to go ahead and delete the contacts from our dictionary of contacts. So what we can do here, and before the prompt user, oh, there it is. Okay. So the way I did this is based on contact to delete. So that's what contact to delete is for. So what we're going to do is we're going to go ahead and find the contact to delete based on their search query. And once we have that, we got to go ahead and delete it. But the way I did that is I used the index of the thing to later delete it, which is a little complicated, but let me just show you. So I did this. So let's start with the first scenario. Let's say we have one contact, right? That we have to delete. If we have one contact we want to delete, then that means that we only have one item in the list, because that's what our search function returned back to us. So if we do that, we want to go ahead and do something like this. So contacts has a function that's used to delete, which is delete. and you can pass in a key to delete. So because we know contacts is a list of contacts, right? You could actually go ahead and do contacts at element 0, right? That gives us the contact tuple that's inside that list. And then add element 0 of that gives us the name of it. Remember, this is when we were doing the list inside of list. When we had a list inside of a list, we did that, and we could actually go ahead and access the first element and access the first element of that. Same thing here with the tuple. So that gives us that. That's the contact to delete. That's in the case where we have one, right? And later on, we're going to go ahead and make this a lot prettier, but that's in the case where we have one contact. So let's go ahead and run that to see how that works. So contact, I misspelled that. What am I doing wrong here? Let me see. Whoever sees my error, point it out. Contacts. Yeah, I don't see what's up here. Unless, did I get it? I did get it all right. Yeah, that should be fine. Search contacts with a list. So we could go, this is kind of nice because we kind of go through debugging here. It's going to see why it is not working. And I didn't expect this to happen, but we can see why it is that this isn't working right. So we know that contacts gives us back, or contacts in this contact, because search gives us back a list. We should have a list here. We should have a list of tuples essentially, with like this, where each tuple has a name, right? Assuming there is something found, obviously. And then what I'm trying to do here is I'm trying to go with contacts. Yeah, I don't know why it's not working either. I gotta see what's up. So we have a contacts list here, contacts, and then we have a list. So oh, I see my error. Hold on. Yep, that fixed it. Okay, and that was just a matter of, no. Okay, let's go back because I don't know what I'm doing. Okay, I don't know why this is happening, but we should have a contacts. We should have a list of contacts, and then with that list of contacts, we have tuples. So what I want to do is I'm going to go ahead and use contacts, and with contacts, I want to get the first element, and my intention was to get the first element and the first key. So I did this. So that's why I did that, but for whatever reason, invalid syntax. I'm pretty sure that's a syntax for deleting, right? Delete, D-E-L. I don't know if contacts, if I do that, I know what you're saying, but I don't think contacts, the delete function, I think it does it by a key. So if I just do contacts like that, I'm deleting a whole tuple, and it doesn't know how to find that. But I know if you use delete contacts, it makes it so that you delete by key, which is what I want. I want the key. Oh, I see what I'm doing wrong. Yep. Wait. Am I? Delete contact 0. Yeah, it seems to be fine. Delete contact 0. But I don't have access to this thing. I think I caught this. I was doing this before too. So, contacts, yeah. Yeah, I think that's what's going on. Okay, so good thing this happened because we get to see some debugging in action, right? The reason this wasn't working, I think, is because contacts, remember, contacts is a list of tuples, right? So if I want to go ahead and get the first element of contacts like this, we can't do that because right now, contacts, and I don't know if it's jumping ahead of me because I've never seen VS Code working like this before, but I think contacts is actually contact 0 here and 0 here. Wait. My initial thing was that saying that contacts is a string, so we can't index something by a string. But now that I'm thinking about it, it should be fine. I mean, I can always go back in my code and see why I did this for certain things, but I'm just really interested that it's not working for me, and I really think it's because I'm indexing. Let's tell the compiler. Let's see, or let's tell Python tell us why it's wrong. That should be a way to figure it out. So delete contact. Did we ever call that yet? That's for option 4, right? 4 is delete contact. Yep, 4 is delete contact. We'll go ahead and call delete contact. And while we're here, we actually have to go ahead and pass in the query, right? So let's go ahead and do an input. So we'll do option, let's call it delete query. Just to be concise with names here. And we'll do input, like that. And then now we have that, we'll go ahead and ask the user to give us a name or a number to delete. So enter a name or like that. And then we're here, we'll pass that delete query. Okay, it's a string that we pass in. Now let's see what happens. So invalid syntax, it just tells us right away it's a syntax error. But I'm pretty sure that's a syntax for deleting something, which is why I'm really stumped here. Contacts. We're in doubt, you can always go to the documentation, which I know I could, but I just want to see. Oh, I think I see. So contact actually takes in a key so it should be something like this. Yep, error goes away. So just to explain that real quick, the syntax for this, the contacts thing, is you have to pass in a key, right? So it's like saying this. It's like saying delete like that, because it does it by keys. So if I pass it like that, before I didn't have these outside things. So because I didn't have that, it's one of those things where like, well, that syntax is not correct. It literally was telling me it's a syntax error because that's not there. So that's kind of cool because you get to see that, right? And if I would have looked at documentation, I'm sure I would have found it a lot quicker. But yeah, so we have that. So that's the way I did that. We'll keep going here, delete contact 00. And if that works, that should go ahead and delete the first index in a list, which is one single contact. And then the first index of that is a key. So that should give the first index of the thing, and then that. That's assuming there's one item, right? Even if there is no one item, it'll always delete the first element. So we'll just see that right now. We'll go ahead and clear the screen. We'll go ahead and do py contacts apply, like that. We'll go ahead and add on contact real quick. Okay, enter option. Now we're going ahead and print our contacts. So we have that there, right? Now let's go ahead and delete a contact. So that's 4. Enter a name and number to delete. Go ahead and Alfredo. Press enter. And as you can see, this time we had no confirmation, which is what I want to do, because if I were to do that on accident and you're actually deploying this somewhere, you want to make sure there's a confirmation, because if I don't want to do that, then it's gone. Anyways, if I print down, as you can see, no more contacts. So that works. We deleted the contact. So that's the way that worked. Now let's make it so that we could go ahead and catch if there's a case. Well, first let's go simple. Let's go ahead and implement a way to ask the user if they want to delete something. That way we don't actually go ahead and do it, without them asking. So we'll go ahead and do that. We'll keep going here. For this is a function that I'm going to go ahead and use again later on, so I know to put it in a function, right? Make it a function, because I'm gonna keep doing this over and over again. But if you didn't know, again, once you see yourself repeating code like that, just put it into a function. So we'll go ahead and put it into a function, because I'm telling you I'm going to use it again, and I'll point it out again when I use it, so you can see. So we'll go ahead and make a function. Now what I want to do is I want to make sure to ask, I'm going to do a prompt basically. I'm going to prompt the user, hey, do you want to delete this contact? Yes or no. If they say yes, we'll delete the contact. If they say no, we won't delete it, right? That's what we want to do. So for this, what did I call this function? I called it prompt for verification. So really explicit name there. Prompt for verification. like that. It takes a parameter called prompt, which is, I believe, yeah, so prompt can be the verification thing. So, you know, whenever you ask something, right, you want to know what the prompt is. So what am I agreeing to? Am I just saying yes or no? Or is there something you're prompting me for? In this case, I'm prompting you to, if you want to delete a contact. So that's why I'm doing that there. So what we'll do here is we'll go ahead and I have a variable called verified. That's what tells us if they've verified a response, yes or no. So verified, I set that to false initially. And then we have a prompt user. Now prompt user, you'll see what it's used right now. But if you remember a while ago, not a while ago, about 2 hours ago, we talked about using loop control variables, and those are ways to go ahead and control your loops, right? So down here, for example, we have this infinite while loop. Now, if we for some reason want to change this so it won't execute anymore, we can't do that because it's set to true. But if instead we make this a loop control variable and we give it a variable that we could change, then we go ahead and make it stop executing something by changing the value of that. So that's what we do, loop control variables, right? So we'll do that. So inside prompt for verification, we'll do true, and then we'll do a while loop. So we'll do while prompt for verification, or while prompt user, sorry. While prompt user, we'll ask them for an option, which is like, do you want to delete or no, right? So we'll call that option. Like that. And then we'll go ahead and put input. We're going to ask it, right? We can go ahead and get input from them. What I did here is I'm gonna go ahead and make use of this prompt, right? Because instead of coming in here and having to make a new function every single time that I want to ask a new question, I'm gonna go ahead and pass that thing in and then ask them the prompt here. For that, I'm gonna use f strings again, and I'm gonna go ahead and use this and put prompt, just like that. Now that we have prompt in there, we're gonna go ahead and that's the prompt, and then at the end, I'm gonna just ask them yes or no. Like that. And then like that. Now, I am going to do something else right there, and I'll show you a little bit later why I did it. But for now, just know that this could be so much better. And after I'm done with the logic, I'll show you how we can make it better. So we'll do that. Okay, so now we'll do a simple if statement again, right? We'll do if statements because we don't have access to switch that easy. So we'll do if option. If option equals yes, or option equals y. So the reason I did this is because I wanted people to have both options. I want people to have the option to do yes and y, because it's a lot simpler, right? Have you ever used command line programs before? You y enter, it's much easier than typing out yes, and it's just quicker. So that's why we're doing that. Now this is the thing I meant that we can make it better. So notice that I use lowercase yes, right? So if the user comes in here and they go ahead and type capital yes, this fails. This doesn't work. So same thing over here, right? If they type capital Y, it won't work because it's an exact match. So it's not going to work. So what I could do is pass this. I could do this. Right? I could do that as well. And that'll work. It'll catch both of them. But you're repeating yourself, right? Even though the names are different, this is one of those times where you think, okay, maybe I could do this better. Because if I'm repeating myself, yeah, F strings are really useful. Yeah, if I'm repeating myself, someone just said F strings are useful. So yeah, if I'm repeating myself here over and over again, I know, okay, well, I'm pretty much doing the same thing here. All I'm doing is changing yes and y. So like, it's just redundant to do this. It's something wrong is going here. So the way you would go about doing that is using this, or at least the way I would do it is like this. So lower is a function of strings. Of the type string, you can use it for lowering case of something. And let me show you what that does real quick. Let's open up that Python interpreter again. Here, let me go ahead and open Py. My screen is down here at the bottom, so just look here over here at the bottom. What we'll do here is we'll actually go ahead. Actually, let me just exit this, just to make it a little bit nicer. So at the top here, we have it, right? What we'll do here is we'll do a string, literal, let's call it name, equals Alfredo, like that. And then as you can see, everything here is lowercase with the exception of the A, right? So now if we do name.lower, as you can see now everything is lowercase, not just that. But even if this whole thing was uppercase like this, it makes the whole thing lowercase, like that, right? And then we do a name dot lower, like that. And as you can see now, it's lowercase. So that's what that does. So instead of checking for both uppercase and lowercase scenarios, which is redundant to do because you could do it in one step, we could actually just go ahead and just lower the whole option. So once we have that option, lower it. This way, option is always lowercase. So no matter if they do lowercase or uppercase, it's always, we can always just check one of them and it'll work. So that's why we do that, right? It's better than repeating yourself just to catch different cases. So we'll do that, and then we'll do the if option equals no. And I'm using if statements to catch the scenario where you would put no or yes. I just don't want to deal with that right now. So we'll do option if option equals no. Yeah, there's also a function for upper. It's literally called upper. So if we do this, so I'm going to add to this an option for uppercase, and there is. So right now it's like that, right? That's the way it is. And we do upper. As you can see now, it's uppercase. So they're both ways. You can lowercase or you can do uppercase. So I guess if you really wanted to, that's a good point. If you wanted to, you could just uppercase everything and then just make sure that these are uppercased and then do the same thing, achieve the same thing if you wanted to, just with uppercase characters. So we have that. So now let's do it if option equals no or option equals n. Then we want to make it so that here, we want to go ahead and start implementing things here. So if that's true, then we'll go ahead and change this verified. So I want them verified to be true. This means that the user selected true. That's what that means. Verified equals true. Now, if the option is no, that means they didn't want to do it. So verified equals false. Like that. And then one more thing I want to do is that in the case where nothing happens, like where they do something that's not an actual case, we could catch that. We could do that with else statement or something. If we're going to do it with else, we could do it with if, but if we want to use else statements, we probably want to do elif, right? Like that to do that case. And then at the end, what you could do if you want to do this way is just use else, like that, just like that. And then like else is like that statement that's at the very end of everything. So it's like, okay, if the first one doesn't work, right? If the answer is not yes or y, then check this. If the option is not no or n, then we could do else. Else is anything else that doesn't apply to any of these conditions. So we can do that. So we can do an else. And then for this, let's just do a simple print statement here that's just invalid. Like that. Invalid option. Now, right now, we still haven't messed with our loop control variable. Right, as of now, it's true and it's always true. That means that this is always going to run forever and ever. We don't want that. We only want that to happen if the option is not valid. If it's not valid, go back to the top again and ask them again. Do you want to do this? And yes or no, you know? And if it's not, do it again. Now, because of that, what we want to do here is actually go ahead and implement that. So where we should implement that here is inside our yes or no statements here, where a user presses yes or a user says no. And we can do that here. We can just do prompt user equals false. This way, when we do this, right, if the user selects yes, then it won't ask you again because prompt user is false, so it'll never loop again. And then same thing for this one. We can just copy this here. There's probably a more elegant way of doing this, like catching a scenario where something else happens, and let's just do that. But for now, that works fine. We have prompt user false and prompt user false, and then we go ahead and that should stop the execution. And if it's not, we'll do that. So that's what that does. Now, that's cool and all, but we still have to return it, right? Because if we don't, we have no way of knowing what the user did. So we want to go ahead and return the verify, whether a user said yes or a user said no. So we'll do a return verified. And that just gives us a value back of whether it's true or false. So that's what that does. And now that we have that, we could go ahead back into our delete here and actually go ahead and implement that, right? We have a prompt now. Let's actually go ahead and use that prompt. So right here, before we delete the contact, let's go ahead and add an if statement. So if, and this is going to be a different way of using things. So if you remember that we could use a condition, right? We could do something like if 2 equals 2, like that, right? And then do this if that's true. What we could also do is because our prompt user for verification method gives us back a gives us back a true or false value, we could actually replace that here with the prompt, which is might be kind of weird to do, but because we're returning a true or false value, whether that when this runs through, it'll return a value here of true or false. So we could do if prompt user for verification, and then remember verification takes a string, right? We didn't define it as a string, but we know it's a string because it's a prompt, because it's in here. So what we want to do is we're going to go ahead and take a prompt. So we'll put it right in here. I lost my place right here. We'll go ahead and do, are you sure that you want to delete that? Now, that's cool and all, but we should probably, let's do this. Let's see, delete. So that works fine. Like if I show and do this contact, and then it'll give you back a prompt, right? And it'll verify it's true or false. And if this is true, then it'll delete it, like the function we did. But we should probably in here put a way to show you which contact it is, because you want to go ahead and verify, right? This is the contact you're deleting. Are you sure you want to delete it? So let's just go ahead and print that out. Now, before, if you remember, the way we did that, we printed a contact out is we did so inside our loop here for print contacts, right? We did this here for print contacts. We did this here. Now we could go ahead and take this code here and then do it again. But that's how you know that you could do it better, because you're repeating yourself again. So as to not repeat yourself, what you want to do is put this into a function so you can reuse it. So right up here, we're going to go ahead and make a function here called, I believe I called it print contact or format. It's called format contact. Like that, format contact, and then you pass in a contact because you want to format it like that. And then within here, a contact, remember a contact, the way we've been defining a contact through our whole program is using tuples, right? So a tuple, that's our contact with, it contains our name and it contains our phone number. So to do that, we're going to go ahead and unpack the values. So we'll do name, phone number, like that, and then what we'll do is we'll return it with an F string. Like that. Now, one thing I want to point out, let me do this first and not point it out right now. So we're going to do this. We'll give it a name, right? The name variable passes in. We'll give it a colon to separate the two. And then we'll give it another variable here in curly braces of phone number. Now, the reason, oh, look at this. I forgot this. We want to go ahead and unpack our contact. So we'll do that. So the reason I didn't print a contact here instead of like, the reason I'm returning a formatted string instead of just go ahead and printing the contact here is because I want to use it in two places, right? So really the only thing I'm doing, the logic I want to do is format this thing. I don't want to necessarily print it. Printing is easy. You just do print statement and then you print whatever you're printing. But the formatting is the thing that I'm repeating over and over. This is the logic I need to repeat to print a contact again. So because of that, I'm going to go ahead and go down here to where we did the contact and actually go ahead and replace this with our function that we called, because now we have an actual function we can reuse. Right? So I told you I was going to come back to this, and this is the reason I'm coming back to it, because I'm reusing that code. So I can go ahead and put it into a function and do it right here. So print, format, contact, give it a contact, right? And now we know that a contact is a name and a phone number. And because we're unpacking it inside here under format contact, we don't need to do this anymore. We could get rid of this and just pass in the contact, which is a lot nicer, right? It's a lot nicer to pass in the contact than to pass in a name and that, because it's already in there. It's just like, it's a nice formatted data structure that we can pass straight into it. It comes out really nice. So we have that format contact. Now again, we want to go ahead and do the same thing for delete. So we want to go ahead and print that out. So then we can do the same thing. We'll format a contact like that. And obviously we already have contacts, right? So because we have contact, we can just pass that in. Now we want to go ahead and delete a contact at the first element here for now anyways. This is the scenario where we have one contact again. So we're formatting a contact and the contact is at 0, the 0th element. This is the first element when we have one single element, right? And it should be contacts, not capitalized, like that. So that's the first element. And then we'll just go ahead and do that and delete it. And then we could get rid of this later. You'll see, it'll be a lot nicer. But anyways, let's go ahead and test that code right now. All right. So we'll quit this, run it again. Did I save it? Make sure I saved it. Nice. Go ahead and do that. Add a contact. Phone number. Like that. Cool. Print the contacts. Now we have a contact Alfredo. Now let's go ahead and delete the contact. So we'll delete contacts. Name or number. Let's do a name. Are you sure you want to do this contact? So what we should do here, because this is kind of weird, right? It doesn't make sense to ask you if you want to do the contact without seeing it first. So let's actually take care of that. So what we should do is, are you sure you want to do this contact? That gives you a yes or no value. So maybe what we can do, let me see how I did it before. Did I put it before or after? There's a few ways you can go about it, obviously, right? It just depends on how you want to go ahead and format it. Just looking through real quick. Okay, so the way I did it initially was with the contacts. So because in the case where I have duplicate contacts, and then I show that with some more logic, but we can just do that now by ourselves, right? If we don't want to go ahead and go through that. What we can do here is that we know we only have one variable, just as an example. What we could do literally is just come up here, and we'll make it nicer later. Is just do this. We'll print the contact we want to delete, and then ask and then prompt if we want to go ahead and delete it. And if they say yes, then we'll delete it. Like this, we'll go ahead and add a contact. Like that, and we'll go ahead and add a phone number. Enter on that. And then go ahead and show all the contacts. We have Alfredo there. Go ahead and delete the contact with the option number 4. And then let's do Alfredo. Now in this case, it's nice because we actually get to see, right? We get to see this is the contact you're deleting. And then, are you sure that you want to delete this contact? And we press yes, or yes, or yes, right? Any of them work, like that. We did that. And then maybe we could even add something else at the end if you wanted to, like done or contact deleted. Press enter on that. If we press all contacts, now it's gone. So we don't have it anymore. So that's cool. We deleted the contact. All right, let me get a water. I'm gonna go for a water break and a restroom break. So we'll come back in a bit here. I should not be too long. We're almost 5 hours in. Oh my god, it's super long. Be back. Cool. Yeah, so we're almost done here. Almost done. This is, if anything, this is pretty comprehensive, I hope. So hopefully, like, people that do watch this eventually, or have been watching it, are getting a lot of it. Yeah. Yeah. Thank you, man. Yeah. Amazing. So, I forgot what I was going to say. I guess I'm kind of brain dead now. I forgot what I was going to say before. But yeah, oh yeah, I mean, I'm already doing it, so I might as well finish it. You know, we're almost there anyways. And hopefully, people that see this later on, even like the people that weren't here for the stream, the people that see it later on will get some value out of it. You know, it's just going through, like, seeing it and like hopefully it's a good introductory course. Okay, so we have that. Let me get some more water because I feel it in my throat. Apparently there's a Call of Duty tournament going on right now that I was like excited to watch, and I'm missing it. I don't know what's happening right now. So oh yeah, so just programming told me that my subscription bot. Oh, you subscribed? I'm guessing. Nice. I'm guessing you subscribed. It's not up right now. So a little background. I guess we could just talk for a bit to kind of get my mind back. I was so last week I had to leave my place because I couldn't be here, so I rented an Airbnb. And what was the question again? Oh, yeah, Airbnb. And then the way that's working right now, the script is that I actually have a home server. It's like a computer that I use that it's just all 24/7 now. So it's running from that. So my script, the subscription bot, is running from that. And because I wasn't here, I unplugged the server. So then therefore it wasn't running. And then I got back yesterday. And yesterday I was focused on setting all this thing up for the streaming now. So I didn't have time to do that up. But after I'm done with this, I'll plug the server back in and run on my scripts again so it can be running. So that's why that's not running right now. Yeah, I was thinking of using like Heroku or something, but I figured I have that computer that's always on anyways. So I just, it's always there and I have local access to it. So that's why I did that. But yeah, I was thinking of doing that. Maybe I will eventually, just to kind of keep it going forever, Cool. So let's get back to this. Where are we at? Deletion confirmed that. Okay, now let's go ahead and I guess catch the case where we have multiple contacts, right? Like if we have things or phone numbers that have the same name, we have to have it, sorry, not the same name. For one, it's not possible to have the same name because whenever we create a new contact, the key itself is unique. So if you use the same key for a dictionary, what will happen is that that value will be overridden. So that's actually one of the things that I put in after this. So in the Let's Build Program section. So if you want, you could actually make it so that you could have, you can store duplicates, right? So for that, you will use something else in the dictionary. Maybe like a list of dictionaries might be useful for that. So there's different ways you can go about that, but that's why we can't have duplicate names. But this does not prevent us from having duplicate numbers, right? So if we have duplicate numbers, we need a way to go ahead and catch that so that it doesn't just delete all the numbers, especially if you don't want to do that, right? You want to go ahead and make sure that, I have the same number, but I don't want that contact. Maybe that contact is outdated or something. I just want to delete that contact. So we got to know what to go ahead and make that happen. So going back into, was the tutorial apply? No, it was context apply. Yeah, so going back into here, let me close this because we're no longer using them. Cool. So we have that. Going back into here, let's go ahead and implement that. So in the case where we have the same number, so when we have the same number, we want to go ahead and give the user the option to ask them, hey, what do you want to delete? Do you want to delete this one or that one? So first, let's go ahead and add some false statements, like F-A-L-L, like this, false statements. We'll go ahead and do that in case there's something that we could just skip. So for example, one of the things I could think of is once we get our contacts right, once we search for our contacts and we get them like that, a list of our contacts, if there are no contacts, we just want to skip this because there's no point in doing anything else. If the contact list is empty, meaning there's no contact with that name, why even bother going through any other logic, right? So if contact, like that, if contacts tells you if, and it's kind of weird because you might be thinking if contacts, like contacts is not a Boolean variable, but if you evaluate like this, context gives you, when it's empty, it gives you a false statement. Like if it's not, and then otherwise it gives you a true statement if it has something. So in this case, what we could do is we could do if not contacts, right? In other words, if contacts is empty, if there's nothing inside the contacts list, let me add an explanation here for you guys. So if contacts inside the list. So if there are no contacts inside the list, then we do this, meaning it's an empty list. What we're going to do here in this case is we want to go ahead and, let me catch up here. Oh, okay, just answering some questions. Gotcha. Thank you for that. Yeah, I've been seeing people like in the chat pretty active, like just asking and even helping each other out, which is awesome. You know, because that's just like I just keep lets me keep going. So that's cool. I appreciate that, guys. So if not context, although I feel that just programming was actually just asking stuff for people viewing, which is actually really nice. I appreciate that. You know, I appreciate the people that just ask stuff. I'm pretty sure some people know what they're talking about. It's just like, oh, what if this? Because it's important to like catch different things, and obviously it's stuff that I can't just go all over myself. You know, I'm gonna miss some stuff here and there, so it's cool that people point it out. Keep going. So if not context, meaning we have nothing inside our context list, then let's actually tell them, hey, there's nothing with that name. What I put here, I put that contact does not exist. Pretty sure that's how you spell exists. And then we'll do another statement here. If context is greater than 1, so we'll have to define that first. Remember that before we talked about you could get the length of a list using the length or the len function for lists. So what we can do here, we could define a variable here called number of contacts equals len contacts. The reason I'm doing this is because I want to have a scenario where, again, if we have multiple contacts of the same thing, like with the same thing that we return from our search contacts function, then we want to make it so that we know that we're in there. So that's why I did that. So basically, if number of contacts is greater than 1, meaning we have more than 1, which if you think about it, probably will never execute, and we'll do an elif statement, probably will never execute because of this anyways. Like if it's 1, you know, that happens, but if it's greater than 1, we have to go ahead and catch that. So that's what we have, that greater than 1. We could also just omit using a variable name and just put it directly in here like this, like that. But I do believe I used it later on, which is why I did that. So whenever you're repeating yourself, store it somewhere in the function, in the variable. That way you know to come back to it again and reuse it. So we have that. And then if that is the case, we'll go ahead and tell the user that we found multiple contacts with the same number. I did that by saying duplicate contact. And then I ask them which one they want to delete. Like that. And then what I want to do here is I want to give them an option to delete something, right? But for that, I need to be able to show them what I'm deleting. So in order to do that, what I'm going to do is I'm going to go ahead and do a loop of all the contacts we have and print them out. So we'll do, again, a loop like we did before, right? We could do it with range, with things like that. But since we know that we could get the length of a contact using the for loop by itself, we could just do for contact in contacts, right? And then print them out. Now, this is important. We could just go ahead and print them out, but we want an easy way for the user to go ahead and kind of choose the contact, especially because we're making a CLI application, meaning there is no buttons or stuff to click. It's all in the command line. So because of that, I thought it best to go with numbers, right? So instead of like having to type the name Alfredo, I want to delete Alfredo, or I want to delete this phone number. Instead of that, we could just print the contacts out for the user, and it's just be like, hey, which number do you want to delete? And it's just number them, you know, this is 0, this is 1, so on and so forth. That way we could have an easy way to go ahead and delete them. This just makes it so much easier for the user. So we'll go ahead and do that. We'll go ahead and print the contact out. So we'll do a print. Oh, cool. So the reason I did this, now I remember now. So I decided to go with index instead in range, because I want to go ahead and be able to index, right? We want to index the users that we have. So if we have like Alfredo as a contact, we want to give that the index 0 or 1, however you want to do it. I went with 0. And then the next user has index 1 and so on. And remember that the range function that we learned before gives us that flexibility, right? Of using indexes to access lists and get the length of it. Now, we already know the length of the contacts because we used it up here, right? Again, we're reusing it. That's why I put a variable, because we're going to reuse it again. So if I do in range of number of contacts, right? That gives us a range of the total number of contacts. And we're going to use another f string, super useful here. Use another f string to kind of indent things. I am going to use a /t. Now, remember I used something similar before. Before I use a \n. So we go back up here and find that somewhere. Right here, \n, right? \n was used to create a new line at the beginning of our context. That way we can have a separation, a nice separation between our stuff that we can see right here, before and afterwards. Right? A nice separation here and here, a new line. Now, /t is used for tabs. Now, you can go ahead and look these up. These are things that are used a lot. There's just like a tab. So this is saying, okay, I'm going to print something, but first I'm going to use tab. So I'm indenting it and then printing something. So that's what tab is. So I'm using a tab at the beginning here. And then for that, oh cool, I see something more people are joining. Hey guys, thank you for joining. Again, if you guys weren't here before, if at any time you have any questions, just go ahead and ask whenever you want. Just go ahead and talk or put it in the Learn with Alfredo channel. Go ahead and just ask your questions there if you're shy or don't have a mic or something. Okay, so we have that. We're going to use /t. Now, what I want to do is I'm going to go ahead and use the index. So again, with f strings, we could go ahead and use those curly braces to go ahead and index something, right? To go ahead and, not index it, but print a variable. So we'll do index, right? And as we know, range goes from 0 to some value exclusively, or with the last value is exclusive. That means that it's going to start at 0 and then print out the next of them. Now, because we do have the index, now we can actually go ahead and access the list using that index, right? It makes sense because we have it right there. Why not use it? So what we'll do is we'll go ahead and, again, use that thing. Remember last time we want to go ahead and, we want to go ahead and print a contact member list, like someone in the contact. And the way we've been doing that is formatting it, right? Like this. We've been formatting it, if we go up right here, like this, in this way. But if you notice, we have a function for that, and we're going to reuse it again. So this is why, again, it's important to have a function that you can reuse over and over again when we do code that's repeated. Because now we can just go ahead and call format contact and then use that function to format the contact, right? Really cool. We don't have to go ahead and rewrite logic again. So we go back here to here. We're going to go ahead and format contact like that. And we're going to go ahead and pass in the contact object. Now, remember, our list is a list of contacts, right? A list of tuples. So we could do contacts like that, and then index like that. So that's getting the first index or however many contacts we have in our list, right? And then it's going, okay, at index 0, we're going to print index 0, and then go ahead and print contacts at the 0 element. And then at index 1, print contact at the first element. So that's really cool because it just kind of works out really nicely. And that's why I did this and with the range function. So it's awesome. So we have that. Cool. And then what I'm doing next is I do have this, right? We want to go ahead and verify if we want to go ahead and change. Right? We did this when we want to go ahead and delete a contact. We want to delete a contact, so we ask the user, hey, do you want to delete this contact, yes or no? For purposes, to make sure that they just don't delete it by accident there. And I feel like I'm speaking fast now, but we'll slow down here. We'll do that. And then, so what I want to do is I want to go ahead and what I did before is I created a loop. And the reason I created a loop was to get an actual valid answer from the user. So remember that before, when we don't have a valid answer, like for example, inside here, in prompt user for verification, what I started doing was I did a loop that goes on forever until this value is changed, right? Until we change the value of prompt user. The reason I did that is because I want to make sure and I catch this, the invalid option. If there is an invalid option, go back to the top and ask the user again, hey, the answer you gave was invalid. Ask the question again, press yes or no. Again, if it's invalid, go back to the top forever until that happens. And once that happens, once it's true, like the value you give is actually valid, then we change the value of prompt user to false. And that makes it so that it stops asking questions. So that's why we did that. We're going to do something similar here, some similar logic, but instead we're going to do it for the numbers. Because again, we want to go ahead and make sure, where did I put that function? By the way, you can always control F to find it, but I don't remember what function I was working on. Oh, delete contact, okay. So in VS Code, you can do control F and then just search whatever you're looking for, right? Delete like that, and we're back here. So we have that. So yeah, what I want to do here, I want to do the same thing because I want to make sure that the user, the input or the input you give us back to the program, you give the program back, is an actual index that's in there. Like if we have a list from like 0 to 1, or let's just say 5 people, we have 5 people in the list. If you gave me number 10, Like, what do I do with that? You know, I don't have that. Number 10 doesn't exist in my list. I can't delete that. I can't do anything with that. So we want to make sure we get a valid response from the user. So we're going to implement something similar here. We're going to do a prompt user. Is this my inside? No, this is outside my statement. So we'll do a prompt user, set that to true again. This will be a loop control variable like before, and we'll do while prompt user, like that. While we prompt for the user, we want to make sure to ask them what index they want to go ahead and delete. So we'll call this index to delete. I heard a mic. Anyone have a question? Yeah, take that as a no. Again, anytime you guys have questions, just go ahead and ask. I'm hoping to make this a lot more interactive in the video, so that way you can actually go ahead and learn something if you have questions. So we're going like that, right? So we're asking for a number. We want the user to give us a number to go ahead and delete, right? A number, and this is going to be the index we're going to use. Now, a number. We'll get back to. I'll show you where that happens. Actually, I'll show you now. So by default, remember I said at the beginning that whenever you use the input function in Python, you actually get a string, right? It gives you a return of a value of a string. So in this case, what I want to do is I want to actually go ahead and make use of that number to go ahead and index this. So when I come back, remember here, we did this here to go ahead and delete an item. This was in the condition where we had one single user. If we had one single user, then we get the first element here of the user, and then get the name of the key for our contact dictionary here. So because of that, now we want to go ahead and handle the case where it's not just the first user in the string, because we're asking them to choose an index of what elements or what item they want to delete from the list of contacts. So to do that, we have to make sure we have this index to later use the index here to go ahead and delete the right person. So because of that, I'm gonna go ahead and instead do something that's called typecasting. Now, typecasting is something I didn't go over before, so let me just explain it really quickly. We're opening back the interpreter here real quick. So for example, in Python, you could do things like this. So you could go ahead, for example, name right now, we have a name of Alfredo, right? That's a string instead of that. We could go, for example, say we have a number, right? And the number is actually a string like this, because this is what input returns. Remember, input returns back a string. So we have number, and I misspelled number again, like that. We have number, and we'll go ahead and hit enter on that. Now what we can do is do a typecast like this. We could do int number. Now this, what's happening underneath is kind of weird when you think about it, but this is making it so that the number turns into an integer. So it's called a cast. It's typecasting. You can do this for various kinds of different objects, except for like the things you wouldn't expect. You can do this for booleans. Booleans can turn into integers. A boolean value of true gives you a value of 1, and a boolean value of false gives you a value of 0. So that's how that works. But if I do that here, enter, you see that we get a value of 1 back, right? That value no longer has quotes around it like we did here. There's no quotes, double quotes, or single quotes. This means that this is now a number, right? So that's how typecasting is. So we're using a string and we're getting back a number. So we'll make use of that in our program. So we have that. What we want to do is we want to go ahead and make sure that the user or the thing we're getting back is a valid answer. If not, we're going to keep prompting the user to give us a valid answer. So what I'm going to do here is I'm going to go ahead and use an if statement. And first, I'm going to check something called, first I'm going to check, because I am going to be using integers, right? One more thing I'm going to show you real quick, just to make sure you understand this. Like I said, before we had the name Alfredo, right? I can't do this. This doesn't make sense, right? It's like, how do you convert Alfredo into a number? I misspelled Alfredo. I misspelled my own name. Look at that, I just caught that. Anyways, how do you convert a number into a variable? You know, sorry, a string into a number. It doesn't make sense. You might maybe think of like the ASCII table and converting these to an ASCII number and doing that for every single one of them. But by default, the typecasting doesn't know what to do with this. So because of that, we want to make sure first that the input we're getting back from the user is actually a number before we typecast it. Otherwise, we're going to get an error like this that says invalid literal for int with base 10. We can't. You just can't do that. So we're gonna go ahead and first make sure to do that. And the way we do that is with a function for the integers. Well, it's not just for integers, it's for strings actually. It's for strings, and we check if something is a number. So again, we have name, right? And then we have my misspelled name here. So we'll go ahead and do, let me go ahead and clear this real quick, just because I'm gonna go ahead and make it a little easier for you guys to see. Right? So we'll go ahead and do the same thing. Name equals Alfredo. Now we want to check if that's an actual number, like an actual valid number, right? We know it's not, because Alfredo is not a number, even if it was as a string. So we use that, we do that using the isNumeric function. So we do this. We'll do name that is numeric. Look at that. And then we go ahead and enter that. It tells us false because we expected it, right? This, we can't do anything. That's not a number. But if instead name was a value of 10, like that, and we say name that is numeric, then that's true because we know that's a number, right? We could translate that to a number. So we're going to make use of that here to make sure that the input we're getting back from the user is fine. Now, one thing I want to point out is that, again, we didn't talk about these during the first lesson stuff, but this is stuff that you can find, right? This is stuff that you can find in the documentation itself. That's why I was kind of stressing the documentation at the beginning. But if you do like a quick Google for like isNumeric Python, you can find exactly what these things do, right? There's different documentations for it, and you could even go to the main one here. It's probably, I don't know if this is part of it. Probably is in here somewhere. Yep, here it is. So inside the Python documentation, right, you could search for stuff, and then there's things called isAlpha. It returns true if all characters in the string are alphabetic, or alphabetic characters, I guess it's meant to say, or one character. IsASCII, isDecimal. There's so many things, right? There's also isNumber, or alphanumeric, and there is at least one character. Oh, it's all, okay, it's all number. Yeah, so there's many things here, right? There's so many things. Is lower, is numeric, is printable. You could check so many different things if you want to go ahead and make sure, like, to do some operation with it. You could search that there. So we'll go back here, and we'll make use of that. So we'll go if yeah, yeah, I've seen that before somewhere. I don't know where it exactly is. I've never used it myself, but it's yeah, I've seen it before. So you can check the type of different things as well. Yeah. So I'll do that. Where was I at? I was here. So we have that. So we'll check if something is not numeric. So if the index to delete, the index we get from the user, is not numeric. Index to delete is right. Notice that I'm using isNumeric, but we're going with not. So not negates everything. So we're saying this, we know that it's going to be true or false. This negates it. So we're doing, if it's not numeric, right? That's how we read that. If it's not numeric, or if the integer index to delete, this is when we use typecasting, right? If it's greater than the number of characters, number of contacts, sorry, less than 1, and I'll explain this less than 1 in a bit, or minus 1, sorry, I'll explain that, then we do something, right? So this is just formatting. This is black again in the background, formatting my stuff. Makes it a lot nicer so I don't go over the character limit. So we have that. Now, this might be confusing, but we're typecasting, right? So first of all, we know it has to be numeric. If it is numeric, then this will evaluate to false, and therefore we could go to the next line, right? Because it's an OR statement. So if that works out, then we have int. And then this integer is being typecasted to an integer for delete, because at this point we know it's a number already. So we're good with that. Now, we want to make sure that this number is not greater. So if it's greater than this, then let me explain this first. So the number of contacts. Number of contacts, like we said before, it's just this, right? It's the length of all the contacts in the list. And then we have -1. The reason we have -1 is because if you remember at the very beginning, and I made a point to explain this, is that in a list, right? Let's show you one more time, just in case you forgot about this. This makes it simpler for me. Right? In a list like this, if we do the length of a name, or name is a list, so right, the length of that is 5, meaning we have 5 items in here inside this list. So that's cool and all, we have that in there. But we're doing here -1 because the index to delete, right, we're starting at 0 because we're printing them all out. So if you go back up here to our loop, for range and range. Remember that range, whenever you put a value here, it gives you back a number between 0 and the last number non-exclusive. So range, let's say we have 10 elements, right? We get 0 from 10, but 10 never actually prints. And we start with 0, so we go from 0 to 9. So because of that, in order to make a match, because let's say our list was 10 numbers long, we have to go ahead and add this -1, or else we have, we can't check for that, right? We can't check if our index is bigger than something that doesn't exist. So we have to go back 1, so -1. That way, if we're using for 10, we're checking if the maximum 10 is equal to the maximum number of 10. So that's what we use that -1. Hopefully that came out clear enough. So we have that. And then once we have that, we want to go ahead and if this happens, if this ever happens, if it's not numeric, or if we have a number that's greater than the number of possible choices we have in our list, then we're going to tell them, hey, we're going to tell them that the option is invalid. Right? And you can even go into detail here if you wanted to. You can make maybe like 2 different if statements and say, hey, it's not invalid because it's not a number, or you can only input numbers, or hey, it's invalid because you have that option doesn't exist, it's not within a list. So we have that. And again, we have this while loop, right? It's going forever and ever. If there is a case where this is not true, meaning the number is the value we're getting back, the string, is a number, and also it is within the range that is supposed to be for a list of contacts, then we could go ahead and just go ahead and stop this loop from happening, right? And we'll do that by changing our loop control variable. In this case, that's prompt user, so we'll go ahead and change prompt user to false. Cool. Hopefully that logic makes sense there. So we have that. And then once we have that all figured out, and we know that they're okay with deleting stuff, we could go ahead and take care of deleting stuff. And that's what this is for over here. Remember before I added a contact to delete, which is underlined right now because we never used it. We want to go ahead and take use of that now by actually go ahead getting that index that we want to use, that contact we want to get deleted. So what I'll do here is inside here, keep in mind that we're still inside our function, but now we're outside the while loop because we're done with this prompting the user for the option to delete. What we'll do here is we'll go ahead and use contact to delete, and we'll get it from contacts, right? Contacts is a list of contacts, a list of tuples that we're going to use, and we're going to go ahead and get the index. Sorry, we're going to go ahead and get the index for the actual person we want to go ahead and delete. So we'll do that by, again, indexing the array and using int because we want to go ahead and typecast it. If we don't do this, if we don't do that and just go index to delete, right? This makes it so that index to delete is actually a string, right? Because again, input gives us back index to delete as a string. So if we do that right there, that makes it so that it's not going to work. It's going to give you an error of like you have to use integers to go ahead and search a list. You can't use a string. So I'm just show that right now the error. So in case you ever see that error, you kind of know what to look for. So we have name still, or I call the name. So like that, name is a list, right, of different things. If we do something like name and index that by this, like something like that, a string, it tells you list indices must be integers or slices, not strings. So we can't have strings. You can't do that. So that's why we want to make sure we convert this into an integer by typecasting it. Go ahead and save that. So now we have the contact to delete, right? And then at the very end, let's add an else statement here. So we have if contacts is nothing, so that contact does not exist. There's nothing here. And then if it's greater than 1, let's add one more here, an else statement to kind of do everything else that this doesn't do, right here. So if that's the case, if the contacts, in other words, if we actually do have people inside our contact list, and the contact is not greater than 1, that must mean that we only have one contact, right? So we can go ahead and use this here, the function that we implemented before, right, for that. And then we can make this even nicer by actually go ahead and using that variable that I haven't used yet, or that I used before. Yep, so contact to delete. So we'll do contact to delete. And instead of just deleting it here by itself, because we still have to go ahead and confirm whether the user wants to delete the contact or not, we'll go ahead and store it in here. So we'll do contact 0, right? That's the first element. Again, if it's only one, if everything else fails, there has to be only one element, one person inside the contact list. So we have to do that. Yeah, thank you, man. So people have to go. That's totally cool with me. Again, this will be uploaded to YouTube later on, and all the information will be in the Learn with Alfredo channel. So thank you for, you stuck around for pretty long, so I appreciate that. That's really cool. So yeah, people that are joining, if you're new, if you have any questions along the thing, it's an introductory course to Python and programming. If you have any questions at any time, just go ahead and scream them out, or just type it in the Learn with Alfredo channel. I'm looking at that on my other monitor, so it's just, yep. Cool. So we'll keep going here. So, else, in the case where we only have one contact, we could just go ahead and store that inside contact to delete. And that's just one single contact of the contacts list. And in the case we have more than one, right, we get the index from the user, and then we go ahead and get that specific index as a contact to delete. So now that we have that, let's take care of the logic of asking the user if they want to go ahead and confirm the choice. And we do that like we did before. Right? We already have this here. Now let's implement it in such a way where we could do it for the rest of the function. So the way I did that before was go ahead and confirming it using the prompt here. We'll go ahead and add a little comment here showing you that that's what this is for. So let's just put confirming with user. So this is where we confirm. We're going to go ahead and delete the contact. And in order to do that, we're going to go ahead and use a prompt, which we already have here. So just move this up here. Like that. And what I'm going to do here is I'm actually going to go ahead and first, I have this mixed up like before. We're going to go ahead and print the contact first, right? First, we're going to go ahead and show you what contact we want to delete. But we don't want to necessarily go ahead and do it like this because we already know which index it is. It's no longer index 0. We already know from the logic above what index we want to go ahead and delete. Or go ahead and, yeah, delete. So we're going to go ahead and give the user that prompt. So we're going to go ahead and format the contact with the contact to delete because we already have that, right? We set it up here and here with contact to delete. And after we have that, we'll go ahead and ask the user, hey, do you want to delete it? As of now, we're going to go ahead and put something here because our if statement is not like valid as of now. There's nothing in here to put. So what we'll do for that is we'll go ahead and just go ahead and if they want to delete, go ahead and do what we did since before. Just go ahead and delete the contact, right? And we know that to do that, we use contacts like that, the dictionary, and then we'll go ahead and index it like that and tell it which key you want to delete. In this case, we want to go ahead and delete contact to delete, right? And we're going to go ahead and take the first element of that key. Yep, like that. And again, the reason behind this is because if you remember before, we have a tuple, right? Let me add a comment here. We have a tuple like this, and the tuple has a name inside, Alfredo, and it has a phone number, and these are strings. So I'm going to make this strings. So yeah, we have a name here, Alfredo, and a tuple here like that. And now this is just telling us, hey, delete contact based on contact to delete, which is this. Contact to delete has a variable here. I'm sorry, it has the first in the list, the first item in the list, which is Alfredo. So delete the contact name Alfredo. Basically, that's what that's telling you. So I'm gonna go ahead and put that here. Okay, so we have that contact to delete there, and now we know which contact we want to delete. So that's what that does, and that's the end of that function. So actually, let's try it out. So let's go ahead and scroll up here. Let's quit this, clear the screen, run the program again. Make sure I saved it. Yep. With that, let's add a contact. Let's give it the name Alfredo. Let's give it a phone number. Like that. Press enter. Let's print all the contacts out. And this is we have one. We have Alfredo. Let's add another contact. Hold on, let me print it again. Let's add another contact with the same number. This way our function catches that duplicate contact and it tells us about it. So let's go ahead and do that. Let's go ahead and add a contact. Let's call Tim. And let's put the same number like that. Now if we print them out, as you can see, we have two of them and both of these are the same number. So if we go over to delete something, delete contact, which is option number 4, and we go ahead and do it by number, like that. As you can see, it tells you, hey, we found a duplicate. There's a duplicate contact here. Which one do you want to delete? And because we indexed it in such a way where we had that before, we could actually choose which number we want to delete, right? Now, one thing that might be nicer here is if we go up here to this, let's just add a little opening, closing parentheses like that. That way we have like a parenthesis here. You won't see it because I have to rerun it, but that's what that does. And now that we have that, let's say we want to go ahead and delete Tim. So we give it the option 1 like that, and it asks you, hey, are you sure you want to delete this contact? Okay, we could do this, we could do that, we could do that, however we want. Let's go ahead and do that. And cool. If we press 3 to print all contacts, we can see that Tim is still there. Did I delete it? Let me see one more time. I'm pretty sure I deleted it, right? So name, number. Okay, we're going to go ahead and delete Tim. Yes, delete. Okay, so we have a logic error here somewhere, which is cool because I thought I finished the function. Let me see where we went wrong here. Else contact to delete, and then confirmation. Contact to delete is contact 0 because we... Oh, I see what I did wrong. Oh, wait, no, that's fine. Make it looking here. Find my mistake. So this is cool. I actually like this is happening just because then we actually get to see what I did wrong, right? I was going through the logic and everything makes sense to me so far. Obviously, like I said, I did make a program before and I know that works. So I could look at that, but I made a logic error here somewhere. So we just gotta find where I made a logic error. Something that I did that's not adding up. So I guess let's just kind of run through this again. So we get the index, right? The index not exist. Oh, I think I see my error. Hold on, let me see. So let's talk about see what I think. I think right now that I never actually got the index of the item I want to delete. Because I do have it here, right, print, but I don't see it anywhere else. Like I don't see that I saved it to anywhere. And I also see that deletion confirmed is something I haven't used yet. So I used that in my original code stream somewhere. So I just gotta see where it is that I used it. Let me just go ahead and do a quick search here. Oh, actually, I never used it. So this is a variable that I actually never used. Interesting enough. Good thing I saw that. So in my original thing, I never used it. So let's go through here and see where I did it. So right now I'm thinking that, again, that I did this, right? I went through the stuff, an index, but I don't see where I saved that. Which one do you want? It asks you which one do you want to delete? It gives you a list of that. It prompts the user down here. Okay, here it is. So index to delete equals the input of that. Even though I misspelled delete. Okay, we'll go that. Invalid option. It did not tell us invalid option, so I know that that's not part of it. And we could even test that just to make sure I can run through the logic here. So let's go ahead and run this again. Like that. Let me add a contact. Let me add another one. Right. Let's go ahead and delete the contact by the number. So if I put something here that's not valid, and do note that I went ahead and added these now, so we have these available, these little closing brackets, it looks a lot nicer. If we go ahead and do something like 4, invalid option, cool. So I know that's working. That's not a problem. Yeah, so yeah, that's definitely a way to do it. At the beginning, I talked about different editors and stuff that you could use. So Shell's program is just saying that if you find that this is too much for you, again, remember that you could always do, or VS Code is too much for you, you could always go ahead and use pretty much anything you want. Like I said, even if you wanted to, you could actually go ahead and just use, what's it called, like a notepad, if you wanted to use notepad, if you really wanted to. I mean, it's up to you, you know. I just found out this might be the easier way to kind of show you things. So that's where we're going with this. But yeah, there's so many options out there you could choose from. So let me see, I'm just trying to debug my program here. Well, prompt user, contact to delete. Else contact to delete equals contact 0. That should be fine. Are you sure you want to do that? And then it comes in here. The one thing I'm thinking about is that it's possible that it's not coming in here. That maybe prompt for verification, for whatever reason, maybe it's not coming in here. And we could debug this, right? We could do something like print here. A simple way to debug this would be like print in So if it's the case where this is not a problem and this goes through, that means that once we do that at the end here, we'll see that. So if we go ahead and run that. Go ahead and run that again. If I do add a contact. All right, and then I'll go ahead and delete the contact. Are you sure I want to delete this? Yes. So as soon as I go with yes, I should see this comment if it's working fine. Which I did. So that's not the issue. So everything seems to be running fine with the exception of this. Contacts to delete. So there's something going on here. Oh, okay. Is that what it was? Did I use something else? Let me see. Oh, yeah. I see what I did wrong. Good catch, guys. So it's not deleting anything from the list. So because, again, we forgot to use the delete keyword like that. So, I mean, yeah, see, things that happen. You just don't see it. You're running through it. Thank you guys for that. It's really cool that people are just coming on here just seeing what I'm doing because you get to see a lot quicker. Nice, cool. Yeah, Arch Linux is awesome. Someone has to go because I have to go and install Arch Linux. That's what I run on my laptop, which is what I wasn't doing the stream on, but then the GPU issues and things like that. So yeah, Arch is awesome. So yeah, I'm glad you guys are enjoying it so far. Yeah, so the problem was that I wasn't able to delete the list, and that was just because I didn't use delete. Like I was using this. I was doing that. I just forgot delete. So there you go. So now we have delete, and that should work fine. Oh, how did the computer not crash for 5 hours? This is a custom computer that I built a while ago. So I'm getting my money's worth, you know, so that's cool. So yeah, at least that's running fine. We're 5 hours straight now. Yeah, we're into 5 hours and 41 minutes and it's still going. So long stream, you guys. We're still going though. We're almost there. So we have that. Now, if that's fine, we should actually be able to delete stuff now, right? Because we weren't using delete keyword before. So we use that, contacts.py, add a contact, number, add another contact. Yep. And then now that we have that, let's print all the contacts. We have Alfredo and Tim. Let's go ahead and delete them by the number again. So delete a contact. Right. We have that, and now let's go ahead and delete Tim, like that. If we do that, are you sure you want to delete Tim? Yes, I am. We do that. And again, I never got rid of this statement here, so that tells us, but that should be good. And now we actually go ahead and print the producers. There you go. We no longer have Tim, now we have Alfredo. So there we go. That works fine for duplicate contacts. And this should also work fine for deleted contacts. So a contact that's not a duplicate. Let's do Alfredo. Right? And then are you sure you want to delete this contact? Yes. Cool. And we'll go ahead and print that out. And cool, we'll have no more contacts. So that's working exactly like we wanted to. That's awesome. Cool, so we're almost there. Yeah, thank you guys for sticking around. We're almost there, 5 hour stream. But that's what we have to do. We have add a contact. That's pretty much done. We could add some more stuff to that if we wanted to. Search for a contact. We did that. No, we haven't implemented search for a contact yet. Okay, so let's do that. So if option equals 2, we can use switch statements here. So we'll do the if statements again, and then we'll do a pass. Now we're gonna go ahead and search for a contact. Now, if you remember, we did that already, right? We did a function, search contacts, that we used for somewhere else, and we used it for printing for deleting contacts. So we go to delete, right here. We used it right here, search context. We built these functions for that, but the cool thing is that we have it already, and we already have the logic, so let's just go ahead and use it. That's awesome. So, and then we also have a way to print the context, right? Search context returns a context, right? A list of tuples, and then print context right here takes a list of tuples and prints context. So it's exactly what we needed. We have our list, and we have that. So let's do that. Let's first prompt the user for a context to search for. And we could do it both ways because our function takes care of both phone numbers and of also names. So we'll go ahead and do this. We'll do inputs. We'll call this search query. Search query equals a prompt here for the input. We'll do an input. And then we'll go ahead and ask the user to enter a name. Which is exactly this thing right here. Enter a name or number, and then we'll do to search. Okay, so that enters a name and number to search. Let's get rid of search. It's kind of redundant, but it's just enter a name and number. So we'll do that, and then now let's actually call our function, right? So we have a search function, search context. Let's pass in that search query, like that. And search query is a parameter. Remember, search query is a parameter, a default parameter that takes nothing to begin with. But like default parameters, like we saw before when we were explaining the difference between a default parameter and a position parameter, we could actually just pass it without the equal sign. So we could just give it a name. So we could just pass a name like that. So we could use just search query, and that works just fine. Search context, and now we have the context we want to search. Let's actually go ahead and print them. And we can do what we did before right here. Print context and then get all context. But in this case, let's print context here. Print context like that, and then of all the context we're getting from our search like that, and that should work just fine. Let's try that. Go ahead and py context, add a contact, Alfredo, and number. Cool. Let's search for a contact. It says enter a name or number. Let's do Alfredo, and there we go. We get back Alfredo, which is awesome. Now let's go ahead and search contact again by number. And there we go. We get Alfredo back with a number. So that works awesome. That was super easy because we already did the logic for that, right? We didn't have to re-implement that logic, which is awesome. So we have that. And I think that's the end of the program. So add contact, search. There are a little optimizations here that I did here and there. So for example, for our add contact, I remember that I went back up here. What did I do for it? And these are things you can always go back and do on your own, you know, it's just kind of things. Yeah, so we added a simple logic, and let's just do it right now. We're already five hours and 46 minutes into it. Let's go ahead and just keep going here. So we have that for add contacts. What we can do is, what if the user enters a contact that already exists, right? In this case, that's contact name. Like I said before, the way a dictionary works is that you cannot have any repeating keys. Whenever you repeat a key and you put the same value for a key, what happens is that value is overridden. So in order to prevent that, that user from creating a contact and then being like, hey, this is the contact I want, this is the name, this is the number, and then it's just overriding that information without telling them anything, let's prompt them, let's tell them what's going to happen. So what we'll do is here under add contacts, we'll create an override value. And that's just a Boolean value. So we'll call it override contact equals to true at the beginning. So the initial function will set it to true. That's the logic behind it. And then what we'll do is we'll do a search function, right? Because we want to make sure, like, we want to check if the contact already exists. Now, I believe there is a way of doing that with dictionaries. Water break. I'm also hungry. Anyways, almost done. I'll go eat afterwards. So there is a way to do that. I believe there's a function probably somewhere with contacts, but I figured, sorry, a function with dictionaries. But I figured since we're already here and we already made a function that does that for us, we could just reuse it, right? Again, that's what's cool about making functions that you can repeat. You can reuse them all you want, and you don't have to rewrite the code for them all over again. So we have that. Let's actually use that. Let's use our function to search for contacts. So we'll do contacts. We'll make another array here, or list of contacts. Contacts equals search contacts, and we'll search by contact name. Now you might be wondering, why is a search query in this case not like anything, a number or a phone number? And that's pretty self-explanatory, right? Because like I said, for a dictionary, you cannot, if you reuse the key for a dictionary, it overwrites it. So what we want to do is we want to go ahead and just search whether the contact name is already in the list. If the contact name is already in the dictionary, this way, when we do that, we know that, hey, that means that we're going to have a duplicate list, which means, or a duplicate item, which means we're going to override the value, which we don't want. So, which is, it's not possible to have a duplicate anyways, but it's the overriding that's important here. So we're going to go ahead and do a if context. Remember, if context like this, we explained this before. This basically is just context. This basically is just a way of saying if there's something in the list. If it's not, this will be false. If there is something in the list, it will be true. So if we do find something from a search results, that means we're going to go ahead and prompt the user. So we're going to tell them, hey, a contact with that name already exists. And then we're going to ask them if they want to override the contact. So remember, we already have this function, this logic, right? We implemented this before, right here, where we do a prompt for verification. The cool thing is that we prompted for verification with prompt. So we could pass our own prompt in here. The logic is the same. The only thing that has to change is this prompt. So that's really cool that we wrote it that way, because then we could actually go ahead and just reuse the function again. So if that's the case, we're going to go ahead and override the contact. I misspelled contact up here. Override contact. Like that. And what I'll do here is I'll go ahead and ask them override contact. Like that. And we'll set the value to prompt user. Prompt for verification. Like that. And we'll give it, we'll tell it, hey, do you want to override this value? Or this, I put value before, but let's take contact. So I say, do you want to override this contact? Like that. So we're asking if they want to override the contact, right? And then this is a variable here. And of course, remember that prompt for verification gives us back a Boolean value. So if they put no, this will be false. And if they put yes, this will be true. So that's what we're using that right there. And now that we have that, at the very end, what we could do is just go ahead and override it if they choose to override it. So if override contact, meaning we want to go ahead and override it, then we go ahead and do this. Like that, right? Like that. And then else, did I put an else statement here? Yep, else, then we have no reason to do that. So we'll go ahead and just do a prompt here. So we can just kind of explicitly tell what's going on. So we'll do print, no changes made, right? So like that. Now you might be wondering, okay, well, this is inside the if statement, right? So if this is inside the if statement, if they never actually find a duplicate item, will this ever delete? And the answer is yes, because remember at the very beginning, we said override contact to true. So because override contact is true to begin with, even if they never come in here and we never go ahead and change the value of our override contact, then it's always true. And by default, it'll go ahead and delete the actual contact anyways. So unless they come in here and they put no, then this will never happen. And then no changes were made. So that's what happens. Now, for the sake of it, let's go ahead and test this, right? Add contact. Right. And then that's add a contact again with the same name. Let's just do a different number for the sake of it. Cool. And then we do that. Menu. Nothing happened, interestingly enough. Did we implement that function anywhere? We'll see. So add contact, if contacts, or did I restart my program? I don't remember if I did. Let me see. Unless I may spell my name again, that's possible too. Okay, here we go. So I probably misspelled my name more than restarted. I don't remember what I did. 5 hours. I'm like drained right now. But anyways, a contact with that name already exists. Do you want to override this contact? And you can put yes or no. Remember, we could do this because we implemented it. This, we could do that. So let's actually go ahead and override it like that. And there we go. And now we go ahead and print our contacts. We see that our contact name has this value because we override the content, right? So yeah, we're done. Finally, after 5 hours of streaming, that seems to be the entire thing. Let me go check. 5 hours and 53 minutes, almost 6 minutes here. And that's okay because I have some more things to talk about. So let's just go over that real quick. So, like I said, we went through that program. You know, we got our own program running. What I will be doing after this is saving the stream. Hopefully, there's no corruption issues for any reason. So hopefully I'll go ahead and get that stream just fine. Upload that to YouTube. And then I'm going to go ahead and go over to, yeah, wow. Yeah, we've been here for 5 hours, almost 6. It's about to be 6 in a bit. What I'm going to do in a bit. Nice. I'm glad you liked it. Yeah. The point of the program is just to get as much information that we learn in there, just kind of into one thing. So that's really cool. One thing I want to know is that there are more things that you can actually go ahead and do. So for this section, there's so many things that we could do, right? But again, this stream is 6 hours long, so let's not do them. But these are things you can do on your own. So, and I listed these from easy to more difficult. So for example, you could go ahead and add more fields to the contact, right? So not just numbers, but you could add emails, addresses, images, whatever you want to add to it. For that, you would probably need a dictionary, and within that dictionary, you can go ahead and use another dictionary like we did before. So a dictionary with different keys, and then a dictionary inside that dictionary. So yeah, that's what we can do for that. I got a thing. I'll check it right now in a bit. So we have that, and then we have, you can make, so you could, oops. I don't know, it's a key binding, that's cool. Probably the mouse buttons are key bindings to switch windows. But anyways, we have that. You can actually go ahead and make it so you can have duplicates, right? So if for whatever reason you want to have a person that has the same name, like the same name and a different phone number, you could do that by, like I said before, maybe making a list of dictionaries. That way they don't have to be the same. We could go ahead and store contacts in a file so you don't have to lose them. So you probably noticed that whenever I went ahead and restarted the program, we had to go ahead and manually type in the stuff again. That's because that's not saved anywhere. So you would save that to like a file somewhere. And then once you save it, once you load the program again, load those files back in, load those names, those addresses, those contacts back in. And you can do that using JSON. So this, here I put something called JSON here. It points you back to the tutorial and it gives you a documentation exactly how to use that. So you could probably use that right there. And then something else you could do is you could add functions to validate data. So at this point, we didn't validate any data, right? We just kind of went ahead and used strings for everything. But for example, a name, I've never seen this, but I don't know about you guys. I've never seen a person that has a number for the name, you know? Maybe there's somebody out there. But if that's something you want to go ahead and omit, you could go ahead and make it so that all the names that you put in are checked before they're put into the actual contact list. So make sure they don't have any numbers, for example, make sure there's just numbers, right? And earlier we went through the documentation and we saw that we could check if they're alphabetical. So that's an easy way to check for numbers. Yeah, to make sure names are only strings. And then we also have phone numbers, right? Phone numbers right now I use strings, but for example, in the US, we have 10 digits long. They're 10 digits long, like that's how long our numbers are here, and they have area codes and stuff, but they cannot have letters. So you might want to go ahead and make some function that implements that, checks if there's any letters inside the numbers, and if there is numbers, then if there are letters inside the numbers, then, or inside a string, then you know it's not a valid phone number. And then you could also verify that it's 10 digits long, you know, using some of the things we learned, like length. We could use length to verify how long something is, you know, so we could use that to verify things. And then you can do that for other fields as well, right? We could do that not only for phone numbers, but also for email and addresses. We could verify that it's a valid email. A valid email has something like a name of some sort, and then the @ sign, and then a domain at the end. So we'll make sure that it has the @ sign. You could do that using the in, like check if something is inside the string, or you can get even more complicated to make sure it only has one of them, or things like that, you know? Just verify the data, that's important. Just making sure people don't use other stuff that's not supposed to be in there. But yeah, that's that. And at the end, I was going to talk about using pip. So let's just go over it super quickly here using pip. So pip is the Python package index, a package installer for Python. If you go here, this is where you can find different packages, right? So before I said how I'm running blank here. Before I said how Python comes with libraries that you have already included within Python, within the standard Python packages that you go ahead and install. But you can always install more, and this is a good way of doing it. It's a fly in here. This is a good way of doing that. Here, as you can see, they have training projects of different libraries you can install. And the way you do that is actually comes pre-installed with Python. So I don't know what this is, but let's say I look through this and it looks cool, whatever it might be. You could go ahead and install this. You see here, it says pip install ES tool. Let's go ahead and copy that real quick, like that. And what I'll do here is I'll exit this. You use this from your command line. So I'm gonna go ahead and exit this real quick. And I'm gonna go ahead and in Windows, you do this, CLS. In Windows, you do this by doing pi -m and then the install thing like that. Use that to install it like that. And then on Linux and Mac, you'll do this without the -m and you'll do pip like that. And pip 3 if you're using Python 3, so like that. So that's the way you do those. An example I could give you, I made a program a while back and it's actually inside the Python index. So let's go ahead and install that right now. Hopefully that's still working, so it'll be cool to show you. So it's called Venus. So I could go Venus py like that, and that installs it. Pip up again. This is Windows, right? So we do pi -m like that. Let me make this a little bit larger here, and then go ahead and hit enter on that one, and that goes through with it. It's installing. Here we go, and there you go. So that's and install my program. It's inside the Python index. So that's what it did that. And then one thing I'm gonna go ahead and point out, the program by itself, it changes wallpapers. So you run that using Venus, like that. In Windows, you'll do that using pi -m Venus, like that. And yep, it changes the wallpaper. So it just changes the wallpaper randomly from Unsplash. So I could do that again. And it works for like any operating system. So I know that's working, right? So we should install that using pip. So that's for that. But you could actually, let me see what we were saying. Yeah, so you can actually go ahead and set up your environments path. If you set it properly, you don't have to do pi -m pip. But for me, I just installed this yesterday on here on this computer to do my stream. So I don't have anything of that set up. It's just straight up from whatever it is. So yeah, if that's not working, if that works fine for you, then your path is set up. Otherwise, you have to go ahead and use that or set up your path variables, and you can look up on how to do that. But yeah, so that's working fine. So that's awesome. And then obviously my thing is an executable, meaning it works by doing something here, but you can also install libraries, right? And then once you install libraries like we saw before, all you have to go ahead and do, that's the wrong one. All you have to go ahead and do is go ahead and import them like we did before, like we did in here, for example. Or maybe I don't have it anymore, but you import it, right? Whenever you import something, it depends on the package, but let's say you downloaded something like Venus, for example, and you do like import Venus, they'll import the package, and then you can go ahead and use all its functions within the package. So yeah, that's just a quick thing. If you want to download anything else, there's a lot of really good Python packages or modules out there that you can go ahead and use. And yeah, that's it for the stream. How long did we go on? We got that 6 hour mark. Cool. So 6 hours. Yeah, awesome. I'm glad you enjoyed it. And you're the only one here at this point, so I'll just go ahead and end it, I guess, unless you have any questions. If you do, just go ahead and ask. Okay, so these streams are want to know how often they're going to be. Honestly, right now, I don't know. It depends on. First of all, I have to obviously figure out a better structure for it, so we won't have to do this like in a 6 hour sit where people are like sleeping and stuff. So that was a learning experience on my part. But it depends, right? So I did put that thing on there, the form of what people want to learn, and there's a lot of different things. So hopefully if I have time, right now we're like on break anyways. So if I have time, I'll probably go in here and like just start making stuff, you know. Maybe the next thing might be like web development, since people want to get into that. That might be kind of cool. I think that was like the second most popular response. And then, yeah, I mean, as soon as I have time, I mean, the more time I have, the more time I can dedicate to these streams, right? So to kind of go ahead and do it. And even then I could just compartmentalize, I guess, just kind of split them up into different parts so that We don't have to do it all in one sit, right? And then just kind of do it here and there. But I still have to figure out how my schedule works with that stuff. But yeah, hopefully we get more of these because it turned out pretty well. I like that people learned from it and that people liked it. Yeah, so yeah, that's the answer for that. Let me go ahead and look in my DMs here because I have someone that messaged me. So somebody asked, where is the stream live? Only on Discord? Yeah, so right now it's only on Discord. Yeah, that's a good point, right? Maybe I should go ahead and make it so that we put it live on other places as well. But right now, since we started here on this Discord, I thought let's just go ahead and make it here. But the upload will be on YouTube. So I'm going to go ahead and, once this is done, I'm going to go ahead and save this file. Hopefully we have no corruptions or anything, and hopefully the audio is there and everything's there. I did test it before, so if everything's still working the way it's supposed to be, everything should work still fine. And that will be up that whole... I don't even think I'm going to edit it. I'm going to just put the whole 6-hour thing up there. So, yeah. Cool. So I think that's the end of the stream. Hopefully you guys got a lot out of it. Hopefully you learned a lot. That's my point, that you learned a lot. And there was definitely less questions than I expected, although there's some good questions there. So that's cool. And I appreciate people just hopping on in the comments, which is really cool. And yeah, we'll end the stream there. Thank you. Someone said you like my YouTube channel. Let me go ahead and plug that real quick while we're here. So this is my channel. You can actually access it by going to alfredo.lol. Alfredo.lol, like that, and that redirects you to the channel. So yeah, I mean, I'm hoping to post more things on here. So hopefully I post more things in here and keep doing it. You know, I've been posting pretty consistently. So hopefully I think of more ideas, and the more ideas I could think of, I could just make videos of it because it's really fun. It's really fun to just make a video of something random that I think, you know, and it's just kind of making it to life and just documents it. How do I make the videos? I mean, I just come up with an idea, right? If I have an idea, I went ahead and by the way, share your channel so I can see what it is. Just gonna paste it in here. I just gotta think of an idea. I record it, you know, record myself, and it's just gonna do some basic edits to put them together, and it's just put them up. Oh, cool. That's cool. I didn't know that was a thing. So Av said that he saw my video in a recommendation. That's really cool. Yeah, hopefully that happens more, right? Because well, the more people see my stuff, the more I could go ahead and grow my channel. But yeah, we'll get there eventually. We'll get there. Any other questions at the end, guys? Anything else? Or are we good? It's cool. Just post it anyways. I'll check it out. Just paste the link and I'll check out. I have 537 subs. It's not like I'm like, you know, flowing with subscribers either. So. Nice. Programming machine code. Maybe we'll do a stream here. We'll do an assembly streams at some point. That might be kind of interesting, but kind of like you know, because assembly is cool, but it's one of those things where it's just like it's different from everything else, so it's cool. Yeah, cool. Nice. I'll check your channel out, man. All right, guys. So that's the end for the stream. I'm gonna go ahead and end it here. I'll see you guys next time. Hopefully we'll do another one of these, so we can go ahead and do it. And yeah, I'll be uploading everything to the Discord channel. I'll put the list of stuff we did, and I'll paste a link there for the YouTube upload. And yeah, we'll leave it there. See you guys. Peace.